In order to learn any programming language, the best way is to start writing the programs. What type of data each variable can hold and what are the type of operations we can do on this. You could have also used the ternary operator. In the ternary operator, what we do is, so in C programming language, you can visualize or you can think of the entire memory as a one-dimensional array. The mind mapping technique has helped me to remember this. I'll just tell you what technique I use to this function scanf. This scanf, exactly like printf, is a library function. You write that piece of code in a separate function, simply call that function and get the thing done. We take programs and then we try to analyze them and we teach you through programs. Hi, in order to learn any programming language, not just C, the best way is to start writing the programs. So that is why I'll start writing the programs, and whenever I give you any program, you do just execute it just for the sake of learning, even though the programs are not very big. And one other assumption is, I assume that you are all going to use Linux operating system. Any variation of Linux is fine. I assume that you are going to run all these programs on a Linux system, right? And we shall start off with this hello world program. So what you can do is just type this program in any editor. You can start with gedit, or if you are comfortable with Linux environment, you can go with vi or vim, and you just write, type this entire program first, right? Now the program is #include studio.h main, and then curly braces and printf hello world. So you save it with any name ending with .c. Now you can save it as hello.c or any name, right? Let us say you are saving it with hello.c. Okay, so typically every C program should always end with .c in Linux environment, right? It is better if you write it this way. And after you save it, you can go to the command prompt and you can give the command gcc. So gcc stands for GNU C compiler, right? Which means you are calling the C compiler and you pass to the compiler whichever program you have stored. Let us say hello.c. Now if you compile this program, then in the same folder you are going to get a.out, which is going to be created as the compiled file, right? Now you take this a.out, again you go to the command prompt and you just give a.out. Now if you write a.out, it is going to run the program, and as an output you are going to see hello world printed. Okay, in the output you are going to see this hello world. Okay, now what has happened here is, in this program we have just given that we want to print hello world, that is why hello world is printed. Now let's see what are all the components that we have used while writing this program. Now the main parts in any programming language like C, or especially C, will contain two things. One is it will contain the functions, and the other thing is it will contain the variables. Now what are the functions is, this function will contain, or the functions will contain the commands which will say what is the work to be done, and these variables are going to store the values which will be useful while executing these commands, either to store the input or to store the output. We are going to use the variables, right? Now if you look at the way the program is written, now the first line is #include studio.h. So it is we are going to include a header file. So we shall talk about the library and header files later. So for now assume that we have to include this standard input output library in all the functions. Okay, so in all the programs we are going to have this line. Exactly what is this header file and why we should include it, we shall see it later. And the next one is, we are going to see this name main followed by some braces here, and then there is curly brace. So this stands for a function. Now typically you can choose any name to be given to a function, but then every C program, if you have to run it, it should definitely contain main somewhere, right? So other than this particular function, if you have any other function, you can give it any name you wish, but then only there should definitely be a function which is going to contain main if you have to run it. The reason is, your C program will start executing starting from the main function. That is why if you have to execute it, you should have main. And now between these curly braces, so the body of the function is going to be present. So this is the name of the function and this is the body of the function, and in the body you can have many commands, right? So here you have only one line, which is print and again something. If you look at this printf is again a function which is not written by you, it is already present in the library and you are going to use it, right? So just to use it, you are going to include this header file. I'll tell you what is the relation between this one and the function here, okay, later. And now if you see this is the name of the function, and then between these braces you are going to send some arguments. So whatever is present between these braces, whenever you call a function, this is called as the argument list. Now in this list you have passed only one argument, and that argument here is just a sequence of characters which are present in this apostrophes, or you can say double quotes, okay. Now whenever you see this is called as, whenever you see a string of characters in these double quotes, then you can say that this is a string constant, okay, string constant or a string, fine. And now this particular string constant is passed to this function, and this function will be executed taking this one as the input, okay. So how this function is written, that depends on how it is implemented in the library, so we shall see it later. So finally the output is going to be hello.c. So in this one we are not going to use, or we have not used any of the variables. We shall see some examples where we can use variables. Now what you can do is just execute this function and you try to modify wherever you can and see what errors you get and what type of output you can see, okay, fine. In order to learn any programming language, the best way is to start writing the programs, right? So I suggest that you start writing the programs right from the first day. So here also I'll start with a program and explain you how to learn the programming language, especially C programming language. Now for this programming language, I suggest that you follow the Linux programming environment. The reason is, if you get into any product-based company, generally all the product-based companies will use Linux operating systems in order to have their products built on. Now even if in your college if they are using Windows, I suggest that in your laptop or in your desktop you install one Linux operating system and you start working on it, okay. So all the programs here, I assume that you are working on a Linux operating system. And next thing is, if you want to follow a good book for this, especially for this one, I suggest that you follow the C programming language by Dennis Ritchie. Even I too follow the same book, but then the problem is it is a complex book. If you directly start reading it, if you are let's say BTech first year, or if you are not very comfortable with C language, if you start reading it, you might not be able to understand. So follow my videos, and after you finish the videos, if you read the book, it will be very, very beneficial. Okay, now I assume that you are new to Linux and C, and so I'll start explaining you both of them simultaneously, in the sense wherever I need Linux commands, I'll just give you the Linux commands as well. So first thing is, you need to create the program, you need to edit it, and you need to save it in a file. So the best editor in Linux is Vim or VI editor. So go to the command prompt in Linux and you just give this command VI followed by the file name, the name with which you want to save the file. Let us say the file you want to save is, let us say file itself, file, file.c, right? Generally, if you are writing any C program, it is a convention that you use .c as the extension. If you are writing C++, you generally use CPP. If you are writing Java, you generally use .java. That is just a convention, okay? Now, once you type this, you are going to get a window, right? So that is the editor. Now in this window, you just type this entire text, hash include studio.h, void main, printf hello. And after this is done, you give colon wq. If you give it and if you type enter, then the file will be saved. And now again you go to the command prompt, and once you have saved this file, just try to compile it. Now we are going to use the GCC compiler, which will automatically be installed in your when you install this Linux in your computer. It is also going to be installed. You need not install it in many cases. Now what is GCC is, it is GNU compiler collection, and this is the software which you are going to invoke in order to compile the file. So when you write GCC, this is the command, this is the command which is going to run that software. Now what is the file that you want to compile? File.c, you just give it. So GCC file.c is going to compile this file, and it is going to produce an output a.out, which will generally be saved in the same directory in which you are working in. Now if you want to run it, then you just give ./a.out. This is the command which you are going to run this file. Okay, now if you run this file, you are going to see hello world. So there it is. You have written your first C program, right? A simple program which has displayed hello world. Now even though it is looking so simple, actually what happens when you write this, and what is compiler, and what is this high level language? So there are many things that you might have to see. We shall see all of them one by one now. Okay, now if you see various lines in this program, the first line is containing #include studio.h. Now studio.h means it is a header file. It is a file. .h means it is a header file, right? So what is a header file? Exactly what it is we shall see later. But then stdio stands for standard input output. Now if you want to give any functions, if you want to use any functions which are responsible for reading the input from the keyboard or writing something onto the screen, generally we have to include this std.h, right? And since you are using printf here, you are supposed to include it. Okay, now if you look at this hash, generally #include is called as preprocessor directive. #include and #define are called as preprocessor directives. Now by writing this line, what we generally do, what is the main intention of this line is, it is to tell the preprocessor to include this entire file, which means just you delete this line and you include whatever are the contents present in this file into this file, which means our file name is file.c, but then there is a file called as studio.h, stdio.h. Now you go and fetch that file stdio.h, and whatever contents are there, you just paste all the contents here before you process it further. That is the meaning of it. Similarly, there is one more directive, preprocessor directive, called as #define, right? Now #define is also a preprocessor directive which is used for macro expansion. Now exactly what is this macros and what we do, we shall see later, but then just remember that whenever you see these two lines are intended for the preprocessor. Now what is a preprocessor, we shall see shortly. Don't worry, I'll go step by step. Okay, and now the next one is void main. Now if you observe it, this is a function. Now whenever you see any name followed by these two brackets, that is called as a function name, right? And after that you are going to have the function body, right? So the function body is going to start with curly braces and end with a curly brace. Now what will this function body contain? Some commands, right? So now if you typically look at a C program, it is generally going to contain these two parts. One is, it is going to contain functions which are going to do some task, and how are they going to achieve those tasks is by having commands inside the body, right? For example, you can think of this printf as a command, or if some other line as a command, right? And then it is going to have variables, right? A C program can simply be understood in terms of these two. It is going to contain functions and it is going to contain variables. Variables are used to store the data, and functions are used to do some tasks by using the data. Got it? So here in this case, if you see this main, this main especially is this main is a special name. In general, in a C program, you can use any name for a function, but then only one exception is there. If you have to run a program, you are supposed to include this main function in that. Whenever you start running a program, your your program will start running from the main function. So when you give the command, let's say /a.out, right? Then in order to run this program, our operating system will search for the main function inside the program, and then it will go into the main function and will start executing from there. That is why every program, if you want to run it, should contain main. Apart from this, if you have any other functions, you are free to use any name, right? And then after a function, you are going to see these brackets, right? So inside these brackets, you are going to pass some variables if you want to pass it. Now for example, inside this function there is one more function. See this, printf followed by some arguments. This is called as a argument. Argument means we are trying to send something to the function, right? So after printf, again you are going to see the brackets. Within the brackets you are going to have some arguments. In this case, this is just a string. Whenever you see a string within these double quotes, that is generally called as a string constant. Okay, now what we are trying to do is, we are trying to use this printf function, and we are trying to send this data to the printf function, so that this function will use this data and do the task. But then where is this function present? It is present in the library, right? So later we will link this file to that particular function, and then we execute it. Okay, I'll show you what happens exactly in some time. So now understand that this is a function name and this is a function name, right? And now you have ended this line. So every line in a C program is supposed to end with a semicolon, right? So next one is, your entire function is going to end here. Okay, so this is a simple function. Now let's see, if you observe it clearly, this entire thing is written in English, isn't it? But the problem is, since our computer doesn't know English, you have to convert this high level language into binary code, isn't it? So for that reason, we are going to use the compiler collection, right? Now this compiler collection is going to contain various modules which will take this high level language, and it will go on converting this high level language into a low level language step by step. Now what are all the steps involved in this compilation? We shall see it now. Okay, so what did you understand here? It is a high level language, and now it has to be somehow converted into bits and bits, so that our computer can understand. But then we are not writing the program in bits because we are not comfortable writing it that way, right? And we are comfortable in understanding English language, that is why I am writing it in English. But then our computer doesn't understand it, so I am going to use the compiler, right? Now let's get into what happens when we try to compile it, right? What are the various phases we have and all. Okay, in general, not just about C programming language, any programming language which has to be compiled will generally follow all these phases, right? So you are going to give a high level language initially. When you write the program, you are going to write in a high level language like English. Now initially that will be taken by preprocessor. Now what is the main purpose of preprocessor is, one thing is, it will remove all the comments. So what is comment is, just for the sake of readability, if you are writing a program and later if someone else has to read it and understand it, it is better that you include some comments in the file. So they are just helping the users to make the program more readable, but then they doesn't have any role to play in the execution. Therefore someone has to remove it before you give it to computer to execute it. So removing the comments will be done by preprocessor. Along with that, you are going to have your program will not be complete unless some other information has to be included in it, right? Therefore you have to sometimes include some other files. They are called as file inclusions, right? So in order to include the file, you can write some commands inside the program, and those commands will be taken by preprocessor, and the preprocessor will fetch that particular file and it will include in our given file, right? So an example of this is, we have just seen hash include. So whenever I write hash include some file name, it means that you take this file and you see whatever text is given in this and include in our file, right? And this file inclusion is done by our preprocessor. Now apart from it, there is also macro expansion. Now what is macro expansion is, I'll tell you later when, but then just remember that there is something you can use it as hash define. So there you are going to use macro expansion. Now all these three things will be done by preprocessor. Now once you give the high level language to your preprocessor is going to do all this, and it is going to produce again a file which will be still in high level language. That is just simply called as pure high level language. I mean, there is no other name, so we are using it as pure high level language. Okay. Now after this, your compiler is going to take this pure high level language file and is going to compile it, and output of the compiler will be an assembly language file. Now if you look at this assembly language, it will not exactly be in a format which can be read by the machine, but it will not be as high as the high level language, right? Therefore, once you convert the program into assembly language, then depending on the machine in which you are working on, every machine will have its own assembler. Now that assembler will understand this assembly language and convert it into machine language, right? You can think of this assembly language as some kind of intermediate representation if you want to understand it. An intermediate representation which will be easy for to convert it into machine language, but difficult for a user to directly write in it. Okay, so this high level language is very close to the user's language, and this assembly language will exactly stand between high level language and the machine language, right? And every hardware, the architecture, it will have its own assembler, and your compiler will know what is the hardware for which it is compiling, and depending on the hardware in which you are going to run, your compiler is going to generate that specific assembly language. Got it? Like x86, right? So I mean, let's not get into many details, because since it is introduction to C programming language, and I'm sure most of you doesn't know what I am talking about here in detail if you are in first year of your BTech. So let's try to be I'll just use some informal language to get you used to this. Later we shall see them in detail. Okay, and now once you give this to assembler is going to convert this assembly language into the machine code, but then this machine code is not directly runnable in most of the cases. The reason is you are going to have many files which are compiled differently, which are compiled individually. Later you might have to link all of them to run it. For example, in the previous case, if you observe it, you have written you have in your file you have written a function, right? Main is the function there, and inside the main you have used printf, but then you have not actually given the code for printf. Now the printf is present somewhere else in the library, right? And that is written in a separate file. Now these two files have to be linked, right? Now that is where your linker is going to play a major role, right? So this linker and loader, they are going to convert this relocatable code so that it will be finally, your operating system will be finally able to run it, right? So what is this relocatable code? You can leave it to the later part. You might not be able to understand it as of now. So for now you can understand that there are various things which are going on in the compiler. When you just use the command gcc, there are all the things which are going on. Now the tricky question is, will I be able to see what is the output produced after every phase, right? Yes, you will be able to see it. Now here if you observe it, here I have directly given gcc file.c, and now I have shown you that this high level program file.c is somehow directly converted into a form in which it can directly execute, and you are executing it. But then intermediate, there are these many phases, and you can see what each phase is going to generate, right? Now if you want to see what each phase is going to do, you can use this sequence of commands. Now let us say your file is file.c. Now instead of directly giving gcc, you could give gcc minus e followed by, let's say, this file.c. Now if you see this, give this command, you are going to get a text which is going to be printed on your screen. Now that text will show you how the file will look like, this file.c will look like after pre-processing phase, right? Therefore, if you want to see what happens after pre-processor phase, you just use this command gcc minus c. Generally what happens is all the comments will be removed if you have any comments. Okay, I didn't tell you what a comment is. Generally you can write a comment like this. You can put 2 slashes and then you can write, this is a function, something like this. Now such lines will be deleted, right? So you can see that all the functions are deleted, and you can see that this hash include file is substituted or replaced with completely some other text which is from that file, and also you can see that hash define are also removed. So you can see all such things happening here. So if you give this command gcc minus c file.c, you are going to see what happens to the file after pre-processing phase, right? Now let us say the file produced is saved as file.i. If you want to save this file, you can just use a pipe, or you can just put -o, or you can just write like this, the command. I'm just writing the command. So $gcc minus c file.c, you can just write like this, file.i. Now why I? It is just a convention. Okay, generally we follow the convention that after pre-processing the file will be named as .i. Now this .i file, if you want to see what happens after compilation, now generally what happens after compilation, see this, after compilation your pure high level language is supposed to produce assembly language code. Now if you want to see the assembly language code, you just take this file.i and you give this command, which means if you give this $gcc minus s, okay, one more thing, capital E, and here it is capital S, okay, minus capital S, right? Now if you give file.i, whatever you get here, or you can directly give file.c as well to this. Now either you give file.c or file.i, it will finally produce assembly code and it will store it in file.s. You can see that a new file is going to be created, which is file.s. If you want to see what are the contents in it, you can use the command vi file.s. Now if you see this, what are the comments present in this, you will see that it is all in the assembly language. Now that assembly language will be specific to the machine you are working on. Depending on the architecture, there will be different assembly languages for different architectures, right? So that will be hardware dependent. Okay, now you are going to see this assembly language here. Okay, now this assembly language file, if you have to assemble it, if you give it to the assembler, then you are going to get machine language, isn't it? So if you want to see what happens after assembler, right, so you can take this file.s and you can give gcc minus c. Let us say the command is $ followed by gcc minus c. If we give file.s, this is the command which is going to be given, then it is going to produce file.o. Again, one more thing, here you can directly give file.c, or you can start with file.s. Whatever you give here, finally you are going to see a machine code, right? Now if you try to open it and see it, it will all be in a zeros and ones. It will not be in a readable format. Till here it will be in the readable format, but if you try to open it, it will not be in a readable format. Okay, which means it is now in machine language. Now if you have many files written separately, and if you have to execute them, and in case if you want to execute them, if all of them have to be linked together, then you can finally give it to the linker, right? So you can give many files. Let us say this is file.o. You have separately compiled some other file, file1.o, and you have separately compiled some other file, file2.o, something like this. Now you can link all these files together if they are related, right? You can link all these files together using this gcc minus o command. Now this is the command which is used for linking, right? gcc minus o, if you give file1, file all these files, then it is going to produce the final output, right? Now the final output will be stored in a.out. Okay, so you can do it individually. See, all these phases you need, in order to compile the file, you can directly go with gcc. You need not do all these things all the time. Out of curiosity, if you want to see what is really happening, and if you want to learn and inquire in depth, then you can use all this and just check it. It doesn't mean that you have to do these commands every time. Okay, you can just go with gcc, but it is just better that you understand what is going on, okay, so that you will have an in-depth understanding. Now one more command is gcc minus wall minus save minus temps file.c. If you give this command, then all these temporary files will be saved. So instead of giving finding these files one by one, if you want to save all these files at once, and if you want to see it later, you just give this one command. By giving this one command, file.i will be created, file.s will be created, file.o will be created, and now you can see all those files. Okay, so this is all about the high level view of what happens when you try to compile a file. Okay, now let's see other details one by one. As I told you, the main way, the approach that we follow is we take programs and then we try to analyze them, and we teach you through programs. Okay, and also if you are trying to learn the C programming right from scratch, it is better you execute whatever program I give you. Okay, fine. Now let's see how all the format specifiers are going to work here. If you write %d, now it will print the variable as a decimal number. Right, it will take the bits in the variable, present in the variable, and it will interpret as if it is a decimal number, and it is going to print it in the output screen. Now if you have %6d, now it is also going to do the same thing, but then it will try to see that in the output we are going to have the display in at least 6 characters. The meaning is, let us say a variable is containing a value 10. And now if 10 has to be displayed onto the screen. Now if you write like this %60, then it is going to use 6 spaces, and in the 6 spaces only here it is going to print 110. That is the meaning of it, right? So it is going to use up at least 6 spaces. Okay, that is how you are going to see the output. It is better, instead of looking it as a theory, I think you could just do it as an experimentation. What you can do is execute that code which I have given you now, and in the code, just in place of d, you just substitute with 6d, and you can see for yourself what is really happening there. Right? You are going to see 4 blank spaces followed by 2 of this, if in case the number is this one. Now if 300 has to be printed, then 300 will be printed like this, right? And you are going to see three blank spaces before it, right? Now if the given number is more than this 6, then it is going to cross here, right? Let us say 70123 something number is this, but then you have given only 60, then it is going to take up more than 6. So if you observe it, at least 6 will be used, and if required, even more characters will be used, right? And similarly, %f says that whatever are the bits present in this variable, you interpret it as a floating point number and print the output as a floating point number. That is the meaning of it. And the same thing is for %6f as well, which means you display the floating point number in 6 characters, in at least 6 characters. If the result that has to be displayed is less than 6 characters, then you leave the spaces in the leading beginning of the number. That is the meaning of it. And %0.2f, it means that after the in a floating point number, after this floating point, you are supposed to have at least two characters, right? In case if you don't have any characters here, it is going to just put 2 zeros. That is the meaning of it. And you can experiment it, okay? And %6.2 means before this floating point, you are going to have 6 places, and after the floating point you are going to have 2 places at least. And %C means you interpret the given bits as a ASCII character, and depending on what that character is, you print that particular character. That is the meaning of it. Now these are only some of the examples. There is a very big list. I'll give you the list later. Okay, fine. Now let's see some of the library functions which are used to read a character and print a character. Now character input and output. Okay, now see this getChar. getChar is a library function which will be used to get an input character from a stream. It reads the next input character from a text stream and returns that as its value. Now if you observe it, what is a text stream is, it is nothing but sequence of lines, and each line will contain many characters, and each line will end with a new line. Okay, now by writing getChar, we are going to read one character, and whatever character we read, we are going to store it in C. That is, this line is going to do that. So C has to be a variable of type char. Now the variable C contains the next character of the line. Okay, putchar C means if you are trying to print C onto the output screen, you can see this putchar. Now putchar prints a character each time it is called. So let's see the example. Let's see the program how it looks like. Now copy the input to output. Let us say we want to just copy the input and simply print it to the output. Okay, void main void int C equal to getChar, which means we are reading a character, and while C is not equal to end of the file. So as long as C is not equal to end of the file, we are going to putchar. Putchar means we are going to print that character. And again, after we print a character, we read the next character, C equal to getChar. Are you getting this? Initially we get the first character in the stream and we check whether it is end of the file or not. As long as it is not end of the file, we keep on printing the characters in the output, and we read a character and we print a character, and that is going to happen forever. Okay, as long as you don't reach the end of the file. Now if you observe this, here we have used getChar once and here we have used getChar once. Now we can just optimize the code. Instead of using it 2 times, what you could have done is simply we could have written it as C equal to like this, C equal to getChar here itself, right? And then as long as getChar is not equal to end of the file, you could have written it this way, right? And now you could have removed this statement and also this statement. So this is also going to do the same thing. So what is that we are going to do is, every time we are going to read a character and test whether it is equal to end of the file or not. If it is not equal to the end of the file, we are simply going to print it. Okay, fine. Now where does it read the data from and where it will print is, if you don't specify any files as input and output, it is going to read the data from the keyboard and it is going to print the data onto the monitor. In case if you want to provide some input file and output file, you can do that. For example, if you want this program, let's say you have compiled this code and after compiling you got a.out, now you are going to execute it. So /a.out, let us say you are going to execute it, okay, at the command prompt. Now to this, if you want to provide some file as input, you can put this less than symbol and then you can say in file. So this is the name of some file. Now what will happen is, this particular program will open this file, and in this file it will take character one by one and it will keep on printing onto the output screen as long as it doesn't meet the end of the file. Once it meets the end of the file, it is going to stop there, right? Otherwise, if you put like this, then it will read the characters from this in file and it will keep on writing the characters onto the out file. Okay, fine. So till now in our examples we have seen some variables, and what is a variable is, it is going to hold some data, right? Now what type of data each variable can hold, and what are the type of operations we can do on it, that depends on what is the type of the variable, right? That is why we shall see what are the different types a variable can be taking, which means a variable can be declared as, right? For example, there can be variables of type character, there can be variables of type integer, there can be variables of type float, of type double. Generally all the variables, they start with a name which is a character, which should not be a number, right? So in the variable names you can use the characters, the alphabets you can use, or you can use the numbers, or you can use underscore, which means you can use anything from A to Z and capital A to capital Z and 0 to 9 and underscore in order to name a variable. But there are few rules here. Now always the name of a variable should start with either this set or this set, which means either from small a to small z or capital A to capital Z. It should not start with 0 to 9 or underscore. Now in between you can have 0 to 9 and underscores, they are allowed. Okay, now these are the small rules that you might have to remember coming to a variable. Now you should always know what is the type of the variable, because depending on the type of the variable, you know what are the type of operations you can perform on it, right? So let's see what are the types basic types that C programming language has given us. Now first one is char. A char is simply a single byte which is used to represent generally a character, and in most of the machines it is always 1 byte, right? And it can hold from 0 to 255. With 8 bits you can hold numbers from 0 to 255, and each decimal number will be encoded as a digit, it will be encoded as a character. Got it? And then integer is generally used to represent an integer. Int is used to represent an integer, and the size of this is machine dependent and your compiler dependent. Now what is the hardware you are working on and what is the compiler that you are using, depending on the properties, these two, this size will depend on it. And float is generally a single precision floating point number, and double is generally double precision floating point number. As you know, in order to represent single precision floating point number, you should have at least 32 bits, right? And then some machines might go beyond 32, but you are supposed to have at least 32 bits. And in a double precision floating point number, at least 64 bits are required, and some machines can have beyond that, but then these are the minimum number of bits that you are supposed to have. Okay. Now apart from this, if you are going to add these quantifiers, then the sizes can vary depending on the machine you are working on. Again, it is implementation dependent, right? So there is nothing like a constant here. Now if you want to know exactly in your machine what is the size of char, what is the size of int, float and double, you can use an operator size of. So C has an operator called as size of, just like plus, minus and star. And this is also an operator, right? Size of. If you give, let us say, int, and if you put it in printf percentile d size of int, then you are going to see how many bytes is integer data type taking in your system. Using that size of, you can find out size of char, int, float and double in your computer. Okay. And then we have quantifiers. Now when you are going to use these quantifiers, generally these short and long are the quantifiers which are going to be used along with the int, which means you can say short int, right? Or you can say long int. Generally when you write int, it is going to have some size, and short int is going to have some size, and long int is going to have some size, and your int typically is supposed to have a size between these two, right? Which means you can directly use, without using int also, you can directly use short in order to declare a variable. You can say short sh, or you can write short int sh, long sh, long, let us say long I or long int I, then that variable I will be long. Typically the relationship between these three are supposed to be like this, which means short is supposed to be shorter than or equal to int, and long is supposed to be longer than the size of int, right? In most of the computers, short will contain, let's say if int is containing 16 bits, short will contain 8 bits and long will contain 32 bits. But again, this is all implementation dependent, right? So again, in your computer, if you want to see what is the size of short, long, you can use size of and you find it out. Okay. And similarly, we can use unsigned and signed as qualifiers. Now these unsigned and signed are used generally for integers and character types. Right, now what is the meaning of this unsigned and signed is, if you are going to use unsigned int, let us say if you write something as unsigned int I, then the meaning is, if int is of size, let us say 16 bits or let us say 8 bits, if the size of int is 8 bits, then the number of values it can hold are all unsigned numbers, and so they will start from 0 and end at 255. Right, in case if it is a signed int, by default int means signed int, right? So in that case what happens is, the range, if it is 8 bits, is going to be from -128 to 127. Got it? This is the range. Now depending on how you write it, either unsigned or signed, the range is going to vary. Got it? And char is generally unsigned only, right? And we generally don't have signed char. I mean, we generally don't use that way. So unsigned char only we use it. And similarly, if you want to have numbers, floating point numbers which are larger than double, some implementations will use long double. Right, so which means this long qualifier will be used with double, then it is supposed to provide you with much greater precision. Maybe you might have 128 bits in that case, but anyway, everything that we have discussed here is all system dependent and compiler dependent, right? And their sizes will be actually constants which are declared here. If you want to see what their sizes are, you can get into these files limits.h or float.h and you can see it, or simply you can write a program and you can see it using size of operator. Okay, fine. Now let's see enumeration constant. That is one type of constant which will be helpful in improving the readability of a program, right? So instead of using the let us say numeric constants, if you use some enumeration constants, it will just give you better readability. For example, let us say here you have enum boolean, which means enum is the keyword which is used to define some enumeration constants, and boolean is the name of the set of constants. Okay, and now we are having no and yes defined within this set. Now what will happen is, this no will automatically be taking a value 0 and s will automatically be taking a value 1. Now why will this one be useful is, if you are going to write a program where you are searching for an element and you have a variable found, let us say found is a variable which is of type int, and now if found is going to have a value 0, it means that we didn't find the value we are searching for. And if it is having a value 1, let us say it means that we have found the value which we are searching for, right? Now if you are trying to compare the value like this, found equal to 0, which means you are trying to compare the value found with 0 directly, or if you are trying to compare the value with 1, which means found equal to 1, instead of writing like this, if you could have written it this way, let us say found is equal to yes, which means this is more readable, isn't it? So if the value is found, if s, that is the meaning of it, right? Instead of comparing it with 0 and 1, by defining this way and by writing this, the program will be more meaningful, right? Similarly, okay, one more thing is, the default value of the first one will be 0 and the second one will be 1, and so on, it will increment unless you specifically mention some numbers there. For example, in this case, enum months, now here again you are using these enumeration constants. If you are given the first value here, a value of 1, then the second one will be given 2, 3, which means it is not starting with 0. Got it? So if you specify some values, you can always do that. For example, you can say that Feb equal to 3 and then March equal to 5. You can also do that. Or if you leave some of the values specified and some of the values unspecified, from where you have stopped specifying, from there onwards the next one will take a value incrementing 1, which means let us say you have specified values till April and April is given a value 10. Then if you leave out specifying the values for May, so on, then May will take 11, June will take 12, like that. Okay, now why will this be more readable compared to this is, let us say you have a variable month. Okay, now if I say month equal to, let's say 2, it doesn't look good, isn't it? If you say month equal to Feb, then it will be more readable, isn't it? So like that, whenever required, whenever it is meaningful, you can improve the readability by doing this. Now one other way of having such readable code is by using hash define constants. Now you also can use hash define in order to write these constants. You can say hash define no as 0 and hash define s as 1. You can do this as well, but the problem is you might have to write for every one word here, you have to write one line of code. That is one thing. Second thing is hash define doesn't have any scope rules. So what is scope rule and all we shall see later, but then enumeration has got that scoping rules, right? So that is why we generally go with enum whenever it is meaningful. Okay, fine. Now sometimes we need to convert a variable from one type to the other type. I'll just tell you some examples here. Let us say you have an operation plus and two operators are provided, A and B. Two operands are provided. Now let us assume that B is float and A is integer. Now we cannot add an integer with a float, right? Either you have to add both integers, because that is how we have the adders written, isn't it? Floating point addition, or we are going to do integer addition, right? Therefore, if both of them are of different types, before you apply the operation, it is better, or it is mandatory that you convert both of them to the same type and then you apply the operation, right? Now what is the best thing is, now let us say this data type is having a capacity of 32 bits and this data type is having a capacity of 16 bits. Now if I have to convert both of them to one type, it is obviously better that we convert the smaller one into larger one, so that we will not lose any information, isn't it? If you have to convert a number which is represented in 32 bits into a number which can be represented in 16 bits, then we will be losing an information, isn't it? That is why convert both of these to 32 bits and then you try to apply the operation, right? So the convention here followed is, you see among all the operands which one is the highest one. Highest one means the data type which is having the biggest space, and you convert all the other data types into that particular data type. Now the order is followed like this. Now if one of the operator is let us say one of the operand is long double, assuming that in your machine long double size is greater than double is greater than float is greater than short or int, assuming that short or int both are of same size and carries of the least size, then first priority should be given like this. If one of the operand is long double, then convert the other operand also to long double, right? If this is not the case, which means if both of your operands are not long double, then go to the next case. The next case is if one of the operand is, let us say, double, then convert the other operand to double, right? If this is not the case, which means your operands are not long doubles or doubles, then the next one is go to this case. If one of them is float, then convert the other one to float, right? If this is not the case, then go to the next one. If one of them is short or int, then convert the other one to int, right? Similar to the next one. So this is the convention that we are going to follow here, okay? And then what about the result? After applying this operation, then the result will also be automatically be given in the form of the bigger one, which means if you convert both the operands into, let us say, long double, then the result will also be given in the long double only, right? That is one way. And this is about one type of type conversions in the mathematical expressions. And the second type of type conversions is in the assignments. Let us say you have an assignment like this, A equal to B, right? Now in this case, since we have to place the contents of the variable B into A, and depending on the size of A, we have to convert it, because finally it has to fit in here, isn't it? Now let us assume that the size of B is 32 bits, right? And the size of A is 16 bits. So ultimately this one has to be stored here, and so we are going to convert this type to this type and we are going to save it here. That is the second type of conversion. So in case of assignments, we are always going to convert the right hand side into the type of the left hand side, right? In case if it is an expression, right, whatever type you get as a result of this expression, you are going to convert into this type and we are going to save here. Now because of this there might be sometimes a loss in information. Yes, there will definitely be, and so you have to be careful while using such statements. Okay, now for example, if you have something like this, char I, and let us say int I and char C. If this is the two variables are there and they have been assigned some values, and let us say at some point in time you are writing C equal to I, then what happens is, in case if I is integer is represented with 16 bits and character is represented with 8 bits, now the information which has been earlier stored using 16 bits has to be stored in 8 bits now, therefore there will be a loss in information, right? But then if you write something like this, I equal to C, then what happens is the information which was earlier present in 8 bits has to be stored in 16 bits, therefore there will be no loss in information. Got it? And similarly, when you are trying to save or store a number which is double into float, then also the same thing will happen, loss of information. Got it? But anyway, we cannot avoid it, and so you should be careful while you are writing such statements, right? The rule says that whatever is the type of the left hand side, you have to convert the right hand side into it. Got it? Okay. And and then coming to the function calls, okay, we shall see. You might not be able to understand it now. I'll just try to say it, but then if you are not able to understand it, leave it for the later. Now assume that you have a function like this, sqrt, okay, and it is taking as the argument, let us say double, okay, and it is returning, let us say double. So this is a declaration of a function. Now it means that the function name is sqrt, it is taking one argument whose type is double, and it is returning one argument whose type is, it is returning a value whose type is double. Now if you call this function somewhere like this, sqrt, now what is a function, what is a function call? Anyway, we are going to see it later, but try to understand it if you can here. Now if I say sqrt of 2, now this is an integer which you are trying to pass it to a function which is actually expecting a double, right? So this is also a kind of assignment, isn't it? You are sending a value into a variable whose type is double, right? So ultimately it boils down to a simple assignment statement, isn't it? Then what happens? Again the same rules. So this 2 will automatically be converted to double and it will be sent there, right? Now you can also do this changing this types explicitly, that is called as casting, right? So what is casting means is, you can just, let us say you have to store some value 10 into a variable which is a float type. Then here if you write like this float, then it means that you convert this integer constant into float type and then save it here. That is the meaning of it, right? Similarly, if you have an expression, mathematical expression, and you don't know what type it is returning, and finally if you want to save it an integer, then you convert the result into this integer and then you save it here, right? So this is done explicitly, right? So when you are doing it explicitly, see here we didn't do it explicitly, our machine was actually, our compiler was actually doing it, right? But here when you do this, this is explicit typecasting, isn't it? So this is also called as typecasting, and this operator is called as casting operator. Got it? So you can also do it if it is required at any place. Okay, fine. Now let's see this constants. So whenever you write a number like this 1 2 3 4, you have to understand that the type that it will take, it will be classified as is int. Now why should you understand this one is, if you have let us say an expression like this, a by b, let's say plus c, okay, now what will be the result of this expression? Will it be int, or will it be float, or will it be double? That depends on what is the type of A, what is the type of B, and what is the type of C, right? That is why the output, the final output, the type of the final output of a arithmetic operation or an arithmetic expression will depend on what are the types of individual variables you have in it, right? Now coming to these variables A, B and C, you will definitely know their types just by looking at their declarations. But then if you have a constant involved, right, then depending on the type of the constant, the final result is going to vary, and what is the type of that constant, that you can derive from by looking at this. So if you have simply a number like this, then it will be allocated integer type, and if you have a number followed by L, either small l or capital L, then it will be considered as a long int. Now if you have a number with a decimal point 12.34, then that number will be taken as a float type. If you have a number starting with 0, then this number will be considered as a octal, right? This is a number which is octal, right? And if you have to see the decimal value of it, the decimal value of it will be 3 into 8 plus 7. That is the decimal value of it. Even though it is looking like 37, it is not actually 37, okay? And now if you have this one 0 followed by x, this means this is actually hexadecimal number, and if you are going to use it in an expression, arithmetic expression, it will be converted into decimal number, and then the decimal number will be taken, okay? And similarly 0xl, which means this is a hexadecimal and it is a long type, okay? And if you have character which is in quotes like this, okay, that is a character constant. Now when you are going to use this one in any numerical expression, then the ASCII value of this one will be taken, of the character will be taken, and it will be used there, right? For example, if you are going to say A plus 10, something like this, then it is going to be 75, right? Why? The ASCII value of A is going to be 65, and therefore 65 plus 10 is 75. Now this is how you can know whenever a constant is present in an expression what type it is, and depending on the type, the output you can see that output is going to depend on that. Fine. Now the second thing is, if we have to save these constants or store this constant somewhere, because if let us say there is a number pi, right, and the pi value is, let's say, 3.14 something, right, and if you are going to use it many times, then it is better you save it somewhere and use it, right? In that case, let's say you are going to use float, the variable name is pi is equal to 3.14. Now what is the problem with this one is, even though this is a constant, which means you don't want this pi to be changed and it should always be 3.14, there is a chance that accidentally someone might again change its value. Let us say pi plus plus, it is allowed, right? Pi equal to pi plus 1 or something like this. If they try to change it, is allowed. But then if you want to keep it as a constant throughout the execution of the program, then while declaring it, you could just add this const. So const is a qualifier, it is a keyword which is a qualifier, which if it is used with any declaration, it will make that particular variable a constant, and whenever anyone tries to change it, it will just throw an error, okay? So by writing like this, you can declare constants also, okay? And one other way of having the constants is hash define. If you are going to have hash define pi 3.14, right, by writing like this, you are defining pi to be a 3.14, right? Now what is the difference between these two is, here pi is actually a variable which will be visible in your program, and you can use the value of pi while writing the program, but once you start the program, once you start running the program, pi will still be there. But coming to hash define, this kind, your preprocessor is going to replace every occurrence of pi in the program with 3.14, and so after the preprocessing phase, pi will not exist there. It will simply be replaced with 3.14, right? And whenever you want to refer to the value of pi, if you declare it this way, you have to go to the variable pi and then fetch its value. But then if you are going to replace all the occurrences of pi, the access will be faster, isn't it? So there is no need to go to the variable to get its value, right? So as much as possible, whenever you want to use a constant, you can use these conventions, and if you are going to use the same constant again and again, and if you need to save it, you use hash define this representation. Okay, fine. Now let's look at string constants. Generally, string constants are represented using double quotes. Let us say if I write double quotes string like this, now this entire thing is a string constant, right? So one thing you should observe here is, or remember here is, even though the number of characters here is 1 2 3 4 5 6 characters, and if you assume that each character is taking 1 byte, here you have to use 7 characters space to store it. The reason is, even if it is not being shown here, every string constant will end with a null. So this symbol is called as null. Okay, \0, this symbol is called as a null. Now every string constant is going to end with a null. Okay, and if you have, let us say, an empty string, you can directly represent like this. Okay, and also you can apply concatenation on these strings. For example, if you write like this, hello world, hello world, it is as good as writing it as simply hello. In case if there is a space here, then hello world. Okay, now let us see a small C program which will be used to count the number of characters in a string constant. Okay, now assume that this is the function that we are writing, and this is the comment. Okay, returns the length of the string. Now this is the name of the function. See, you cannot directly execute this program because you don't have main in this program. If you take it as a program, it cannot be executed, but then you can use this part in some other program and you can execute it. Okay, so that is the meaning of this function. So string length is the name of the function, and it is taking something as an argument. And what is the type of this argument? Character. And we'll talk about this in detail later. So if you can understand it now, just understand it. Otherwise, we'll again get into what is this symbol. This is an array, right? So it means that S is a character array that is being passed to this particular function as an argument, and is going to return int. So this is called as return type. So we shall again see what is the function and what is the definition of a function and how to declare it, all these things. If you can understand it, better you try it. Okay, so this is the name of the function, it is a return type, and this is the argument. Okay, now as we go into the function body, it is going to initialize I to 0. So this is called as initialization. While declaring a variable itself, right, integer I is declared as an int. While declaring a variable itself, you are going to assign some value to it, right? That is called as definition. That is called as initialization. Okay, and now while s of I not equal to null, I equal to I plus plus. Now I am going to use a while loop, but then if you observe it, inside this these braces there is a condition. This is called as while condition. Only when you satisfy this condition you are going to get into it. Okay, but then if you see this, there is only one line in the body of the while loop. That is why I am not using the curly braces. So if you have only one line in the body, you need not use the curly braces for this while loop, right? Otherwise, if you want to use it, you can still use it like this. You can put this in that. Otherwise, they are not required as well, right? Now what is that this one is going to do is, initially s is going to point to this. Let us say this is s. Let us say the string passed here is ravi, right? Now what is a pointer and what is an array? Depending on that, we can see everything later, but for now let's keep the thing simple. Initially I is 0, therefore s of 0 means, let us say this one, s of 0 is not equal to null, therefore I equal to I plus plus. Now what will I become? I initially is 0, now it will become 1. Now again it will go back here, right? I equal to I plus 1. Now again s of I. Now it will check what is I value here. S of I value here, it is not equal to null, therefore it will again enter, it will make 2, right? Now I value is 2. Now again it will go back and it will see s of I. So now s of I is this. So this is s of, these are the indexes, right? Now it is v not equal to null, therefore it will be made 3. Now again it will come here and it will check not equal to this. null, therefore 4. Finally, when I equal to 4, s of I not equal to null will fail because s of I is actually equal to null. That is when you are going to come out of this while loop and you are going to return 4. So 4 will be returned. Got it? Okay, now what is, if we can understand this, it is fine. If we don't understand it, we shall see it later. And one more thing you might have to remember here is, see, writing like this, if I write a here, now this is actually a string constant. Now if I write like this is representing the integer value of this a in the character set, right? In the ASCII set, what is the integer used to represent this a, that number will be returned here, which means you can use this representation in the mathematical operations and then you can get the value, ASCII value of a substituted in its place. But if you are going to have this is a string constant and it cannot be actually given it for any mathematical operation, right? And in fact it is actually a 2-character string. Okay, it will contain this a followed by null, but here it is simply an a. Okay, that is the difference between these two. Okay, now what I mean to say is you cannot use a plus 10, right? It will give you an error, but then you can use like this a plus 10, where this value, this will be substituted, this will be replaced by the ASCII value of a in the ASCII set. Okay, now let's see these assignment operators. So if you have an expression like this, I equal to I plus 2, here I want to increment the value of I by 2 and I want to store the result in the variable I itself. Now whenever you are going to write like this, it is there is a shorthand notation which you could use in this place. So if I directly write I plus is equal to this, it is enough, right? Now the same meaning, so whatever is the meaning of this one is equal to the meaning of this. So this is as good as writing I equal to I plus 2, right? When will it be useful is if these expressions are very big and if you have to repeat it, then it is going to be useful, right? So just see this one. If you have an expression, let us say I have something like this, expression 1 is equal to expression 1 operator expression 2. If I have something like this, right, then this entire thing is as good as writing like this, expression 1 op is equal to expression 2. And what could be this operator? It can be any binary operator you can think of, right? It can be plus, minus, star, division, or bitwise operators, right? So if you can replace any of these in place of op, then you can write it this way. Okay, now let's see the bitwise operators. Now assume that integer is stored in 8 bits. Okay, so one number is 60 and the other number is 13. Now this is the bit pattern for 60 and this is the bit pattern for 13. Okay, so 60 is 00 11 11 00 1 2 3 4 1 1 0 1. Okay, now if I use bitwise AND operation, this is bitwise AND operation, right? Then what happens is bitwise we are going to take every 2 bits and we are applying AND. So what will happen here? 0 and 0 is 0, 0 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0, 1 and 1 is 1, 1 and 1 is 1, 0 and 0. So this is what you are going to see here. Now the next one is, this symbol is bitwise OR. So bitwise OR means we are going to take every 2 bits and we are going to apply OR, right? So 0 or 0 is 0, like this. Now if I apply OR, it is going to be 0 0 1 1 1 1 0 1. Okay, and next one is exclusive OR. So what is exclusive OR is I take 2 bits, add them, and I take the remainder, right? So if I take 2 bits, add them and take the remainder, 0 and 0 if I add, it is going to be 0. If I take the remainder when I divide with 2, then it is going to be 0 itself, right? So again 0. Now 0 1, if I add these two, this sum is 1, and if I take the remainder when I divide it with 2, again it is going to be 1. So 0 0 1 1, and if I add these two, it is going to be, sum is going to be 2. If I take the remainder when I divide with 2, it is 0. And again the same thing here, 0, 0 and 1, right? So this is exclusive OR. And this is not operation, means we take bitwise not. So we take each bit and we apply not to it. So if it is 0, we make it 1. If it is 1, we make it 0, right? So if you observe this, that is what is happening. And the next one is A left shift 2. So this is left shift operator, and this is, let us say, integer. And now when I write like this, it means that I want to left shift all the bits by 2, right? So if you see this here, now left shift all the bits by 1, then what do I get? 0 followed by 1, 4 ones followed by 3 zeros, and then again left shift it by 1, then what do I get? 4 ones followed by 4 zeros, right? So if you observe it, the value has become 240. Now why did this happen is, whenever we left shift a number by, let us say, 1, it is nothing but multiplying with 2 power 1, right? Whenever I left shift the number by 2 bits, it is nothing but multiplying it by 2 power 2, right? If I left shift it 3 times, it is nothing but multiplying it with 2 power 3, provided that your integer, or the data type should be capable of storing this big value. If it can hold this big value, every left shift is nothing but multiplication with 2 power some number. Got it? And the next one is right shift. So right shift by 2 means, see, in this case, if you right shift it by 2, so it means that when I right shift it by 1, dividing by 2, right? And if I right shift by 2, it means that it is dividing by 2 power 2, right? If you see this number 60 when it is right shifted by 2, it means that 60 is divided by 2 power 2, which means 60 by 4, right? So which is 15. Got it? In case if you get any fractions, that will be just not stored there. Okay, fine. Now let's see how to use these operators with a program. Okay, now instead of using if else, you could have also used the ternary operator. In the ternary operator, what we do is, we take the condition. Let us say, what is the condition we have to check? Whether this number is divisible by 2 or not, right? So the condition is, you take the number and you find out the remainder when I divide it with 2. If I divide it with 2, if the remainder happens to be 0, then this number is divisible by 2, right? In this case, I have to print that the number is even, right? Therefore, I can write printf number is even, right? If this is not the case, which means if this condition fails, then I'll execute this statement which is after this colon. Are you getting this? There will be a statement here ending with a colon. Now if this condition is true, then this statement will be executed. If this condition is false, then the statement after the colon will be executed. Let us say after the colon you are writing printf number is odd. Got it? And you close it with the semicolon, right? Now what happens is, if the number is even, this will be printed. If the number is odd, this will be printed. Now if you want to understand more about this ternary operator, let's take one more example. Let us say we have two integers a and b, and now we want to compare a and b, and we want to assign whichever is bigger into another variable max. Now if a is greater than b, then let us say, then what should happen is max equal to a. Otherwise, let me say, put a question mark, right? Otherwise max is equal to b. Now this is as good as writing this way: if a is greater than b, then max is equal to a, else max is equal to b, right? So whatever statement you want to write with if else, if it is more readable, if you write it in a ternary manner, you can write it. Otherwise, if you feel that if else is more readable in this example, you can use this. Okay, so both can be used. That is what I mean to say. Okay. Now when you want to increment the value of n or any variable, there are two ways: plus plus n or n plus plus, or you can also write n equal to n plus 1, right? So generally not to write it in elegant form, we use plus plus n or n plus plus. But then there is a difference between these two. If you are going to use plus plus n or n plus plus, individually as a statement it doesn't make any difference, right? So if I say plus plus n or n plus plus, individually as a statement it doesn't make any difference, but then if I use it as an expression, in an expression, then it will make a difference, right? Now see this, increments n before its value is used. So n plus plus n means, this is called as pre-increment. Pre means before, okay, and n plus plus means post increment. Post means after. Increments n value after its value has been used. Now if you observe this, x equal to n plus plus, now n is a variable, its value has to be incremented, fine, but then x is going to take the value of n. Now n is going to have here there are two cases. Should x take the value before it has incremented or after? Now that conflict will be resolved by this. Plus plus means post increment is used here. Now the value of this one will be provided in this expression to be used, and after that value is used, finally at the end it will be incremented. Now let us say initially n value is 10. Okay, now if you write x equal to n plus plus, it means that first the value of n, the value of 10 will be stored in x, right, and then n will be incremented. This is the meaning of it. Therefore by the end of this execution, x will have 10 and n will have 11. So before this statement, if n is having a value of 10, after this statement x will have a value of 10 and n will have a value of 11. The same thing applies for this one as well. I mean, just see the explanation here. Now if you observe this, let us say n's value is 10 before you execute this statement, and now x is there. Now if you see this, pre-increment is there. Now it means that you first increment it and then use its value, right? So its value is used in order to save it in x, right? Therefore first increment it. If I increment it, its value is going to become 11. Now this 11 has to be stored in x, right? Therefore x is going to get 11. Got it? So after this statement, both of them are going to get 11. So this is the difference when they are used in expressions. So remember that whenever its value is needed, in case of post increment we use the value first and then increment it. In case of pre increment we actually increment it first and then use the value. Got it? Okay. These are the various operators used in C programming language, and whenever all the operators occur together in an expression, then the main dilemma is which operation should I evaluate first or which operation should I carry out first, right? So that depends on two things. One is called as precedence and other is called as associativity. Precedence means this, when I have a plus b into c, then you are going to carry out b into c first and then plus, isn't it? Which means multiplication is having higher precedence than plus. So precedence means that way. And associativity means when you have all the operators of same precedence, then which one are you going to evaluate first? So first thing is, in an expression, when you have various operators means all this, these are all the operators in C programming language. When you have various operators in an expression, then if all of them are of various precedence, then we are going to take the one with the highest precedence first and evaluate it. In case if all the operators are having the same precedence, then there is a dilemma, which one to evaluate. There we are going to use associativity. So we are going to have precedence and associativity, and these two are going to decide the order in which we carry out or evaluate the expression, right? And depending on which the value of the expression will be varying. Okay, so what I'll do is I'll just explain you this table, but then I'll not take any examples right now. I'll take the examples whenever they are required when I'm discussing about the programs. And one more thing, for data structures, I'm going to at some points I'm going to use C programming language. So the entire data structures course is completely based on C programming language whenever required. I'm not going to use any other language, only C programming language. And when I discuss about the C programs, then maybe these will be useful, which means when I have various expressions and then these operators, then if you could refer this. So what I'll ask you is, this is also present in various books and you could Google out the diagram or you can write it down somewhere. And whenever I discuss about any program and when I try to talk about these operators, you please refer to this table and you can understand it. Okay, so let me explain what are these operators and then how they are arranged. Later we shall discuss about the examples whenever they come. Okay, now first of all I'll just explain all this. See, these operators are arranged in various rows. Okay, so the way they are arranged in the rows, that shows the precedence, which means the first row is having the highest precedence than the second row, and second row is having higher precedence than the third row, and next one like this. So the way when you are going down, it means that the precedence is decreasing. Okay, and you know, one more thing, when you have the operators of same precedence, then what is the associativity? Then the corresponding associativity is referred here. So generally we have left associative and right associative. Left associative means, you know, when we have a big expression with all the operators of same precedence, or either two or more operators of same precedence anywhere, then you have to come from the left, and whichever occurs in the leftmost we are going to evaluate it, which means we, you know, when we have many operators like this, we are coming from the left like this, and whichever occurs at the first starting point we will evaluate it. When is that? Whenever the precedence of all the operators are same. Got it? Let me explain you all this. This is generally, you know, this parenthesis, right? The braces, and you know where they are used, generally function calls in general, or sometimes even if you want to give some expression highest precedence, we are going to use this. So this is having the highest precedence, right? And this one is also having highest precedence. This is used for array indexing, if you remember, array indexing, isn't it? And these two are used to access the members of a structure. So structure and members, we shall discuss it. Okay, and this is not, right? And this is, you know, one's complement. So one's complement means you know, if I have 101, then it is going to be 010. This is one's complement, and this is not, logical not, and one's complement, and this is plus plus and minus minus, or increment and decrement. Okay, and this plus and minus, they are unary plus and minus. Okay, so sometimes what happens is this same symbol will be used in two places, and you know, they say that one is unary and other is binary. And whenever they occur in the program, how will you distinguish whether it is unary or binary? That depends on the context. If plus is used only with one operator, one operand, then it is unary operator. If plus is used with two operands, then it is binary operator. Okay, so here in this row, right, this plus and this minus are unary. In fact, all are unary. Okay, and then star. This star is used with the pointer indirection. I'll talk about it. So this star is generally used with pointers. Okay, and this ampersand is also called as address operator. Address means you can find out the address of an element in the memory using this ampersand, right? I'll talk about it later. And then this type is for typecasting. So what is typecasting is, sometimes we want to change the type of a variable from one type to other type. There we are going to use this. Okay, and size of is used to get the size of a element. For example, if you type size of int, right, then you are going to get what is the size of int in that platform or in that operating system which you are using, right? So anyway, all these are unary operators, and they have the highest precedence next to this one. And if you watch this one, it is right to left associative, which means if I have all these operators in one row, then you have to come from the right, and whichever occurs in the rightmost, that will get evaluated first, right? That is how this row operates. And the next row is binary operator. Star is multiplication, division, and modulo operator. So these are having higher precedence than plus and minus. Plus and minus are also arithmetic operators. So these two rows are arithmetic operators. This is unary, these two are arithmetic operators. And this is less than, it is left shift and right shift. These are shift operators. So you know shift, right? Okay, even if you don't know it, I'll take examples later. And next one is, this is less than, these are all relational operators, which means we want to compare, right? So I want to compare between various elements, then I'm going to compare using this. Less than or equal to, greater than or equal to or not equal to, right? And these are bitwise operators. This is bitwise and ANDing means 0 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0, like that. Bitwise and this is bitwise exclusive OR, and this is bitwise inclusive OR. You know exclusive OR and inclusive OR, right? Inclusive OR means normal OR. Exclusive OR means you know that we have seen already in digital, right? And this one is this two ampersand, these two are logical operators. This is logical AND and this is logical OR. Okay, and this is ternary operator, which is used for comparison. In the sense, we can write bigger expressions, in a small compact way using these ternary operators. I'll give some examples later. And the last row is assignment operators, equal to, plus equal to, minus equal to. They are also called as shorthand operators, right? So using these operators, we can represent a big expression in a compact manner. Okay, anyway, these are all assignment operators, and the last one is comma operator. So one thing you should remember is almost all the operators are left associative except 3 rows. So one row is this, the unary operators, and the second row is this, the ternary operator, and the third row is assignment operator. So you by heart these 3. I mean, it is very easy to remember. Everything else is left associative. Only the right associative operators are unary operators and ternary operator and then assignment operator. Everything else is left associative. Okay, so there are various ways to remember this. I mean, I have read somewhere long back, I don't remember where I read it, but then this mind mapping technique has helped me to remember this. I'll just tell you what technique I used from somewhere, and if you like it you can use it, otherwise you form your own. See, you forget about this, you remember this somehow, that function calling and then array indexing and structure membership, these are all of highest priority or highest precedence. You remember it somehow, and the remaining how you can remember is, if you look at the first one, right, the first one is unary, right, and the second one, in fact these 2 rows, these 2 are arithmetic, A. And how to find, these 2 rows are represented with 1 letter, but then you should know how to differentiate or which one is having higher precedence among these 5. That is very easy, I feel. And then this is yes, shift operator, S letter is used, and then the next one is these 2 are comparison. You just have to by heart remember that these 2 are at lower precedence compared to this, right? And these 3 are bitwise, and you have to remember that bitwise and is greater and then exclusive OR and then inclusive OR. And these are logical operators, and this ternary you have to remember it somehow, and then this is assignment, and in the last there is comma, right? Okay, so now this is comma operator, right? Now how you can remember it is, now if you put all the letters together, initial letters together, you can form ask, ask, black, blac, black. Okay, so one exception is before this assignment there is this ternary operator. Okay, so without this, these 2 rows, you can put all these letters together and you can remember it as ask black. I mean, I used it and I still remember it. Maybe if you don't like this one, you form some other thing, means you use some kind of mind mapping so that you can remember such tables easily. Okay, so once you remember it, you can easily answer some questions. Sometimes you might get a question from this table, in the sense they'll give you an expression and they'll ask you what is the value of it, right? So in that case, maybe remembering it is going to help you. I'm not going to ask you to by heart everything, but at least this table is worth remembering. In the sense, when you go for any product-based companies interviews, whenever they have C programming language, sometimes they are going to ask you this, because even Java is also having these operators, and almost Java is also having the same kind of precedence and associativity. Therefore, some companies, they will even ask you this. So even if it is not for gate, for interview purpose, at least you have to remember it. Somehow, someday you are going to use it. Therefore, remember it now, and you try to map it well. Okay, so I'll explain with these operators with examples whenever they are required. It is not that everything is required, but then whenever they are required, I'll just come to this table and refer this, and I'll explain it with examples. Okay, fine. Let's see some of the properties of C programming language by taking an example. Now let us assume that this is the program which is written in order to convert Fahrenheit to Celsius. The temperature which is given in Fahrenheit, let's say we want to convert it to Celsius, and we are going to convert like this. For given Fahrenheit 0, what is its Celsius value, and for the given Fahrenheit 20, what is its Celsius value, so on for the given Fahrenheit 300, what is its Celsius value. So what I mean to say is, now I want to print a table saying that for 0, if Fahrenheit is 0, then what is its temperature in Celsius, right? And for Fahrenheit 20, what is the temperature in Celsius, and then 40, and so on till 300, right? So what is it? I want to find out these conversions for these values in steps of 20, right? See this, the difference between these two values is 20, 20, 20, right? Therefore I'm computing it in the steps of 20, starting from 0, ending at 300. Okay, now let's see the program written for this. Hash include stdio.h. Now this line is just a preprocessor directive which is showing, which will indicate the preprocessor to include this file in this program. Why is it needed? As I told you that wherever you are going to use printf, since printf is a library function and we are not declaring it. Now before you use any function, you have to declare it. So one rule in C programming language is, before you use a function or you use a variable, you are supposed to have their declarations, right? And if a function is from a library, we generally don't declare it. Okay, so all those declarations will be present in the header files, and we simply include the header file in it, right? So that is why we are using it. We shall see about it later, more details later. And the next one is, if you see this line starting with backslash followed by a star, it is generally comments, right? It means that the comment is starting at backslash followed by a star and ending with star followed by a slash, right? So this okay, now sorry, it is a forward slash, right? So forward slash followed by a star. So generally we are going to write the comments like this: forward slash star, it is starting, and you can write any amount of text in that, and then star followed by slash, right? So whatever is present between these two, this everything is considered as a comment, and this comment is generally used for the readability. Now why do we include it? So that people who are reading this program will understand what this program is about. If you want to include that, increase the readability of your program, just include it. Now if you see this, it is just saying that print Fahrenheit to Celsius table for Fahrenheit 0, 20, 300, which means it is just giving us the information about this entire program. But then this is not really useful for executing the program, which means our computer need not know about this, right? Therefore your preprocessor will simply remove it. So this is going to be present in the text format of our program, but while compiling it will be removed and it will not be used, right? And the next one is, we are starting the program, and as I told you, if you have to execute a program, you should definitely contain the main function. That is why I am writing the main function. And if you see it, nothing is there in the arguments. Therefore you need not send any argument to main, you can directly write it, right? So for any function, if you want to send some arguments, you can send them, or if you don't want to send anything, you can leave it like that. Okay, now we are going to start the body of the main function. Now if you observe it, we are writing int farh, it is a variable, and then Celsius, it is a variable. Now if you observe this entire line, int Fahrenheit comma Celsius, right, this is a statement, and this statement is saying that Fahrenheit and Celsius both are variables of type int. Int means integer, right? So this is called as declaration. Now in a declaration, we generally specify what are the variables we are going to use and what are their types, right? And we can have any number of variables of a type or variables of different types. So later we shall see what are all the types of variables possible. Here we are just using integer. Now what is the meaning of this one is, it means that Fahrenheit is a farh, this is a variable which will have a capacity to hold a number which is an integer, and this capacity is already predetermined based on what your implementation is. For example, some implementations will try to make this integers to be a 16-bit number, right? And some of them will use it to be 32-bit number, right? Now in case if it is a 16-bit number, right, and if it is a signed number, right, then it is going to have a particular range. In case if it is 32-bit, it is going to have a particular range, right? Generally the range of this one is going to be minus 2 power minus 15 to 2 power 15 minus 1. So this is the range if you assume that we are having a 16-bit number. Now if you assume that it is 32-bit, the range is going to be minus 2 power 31 to 2 power 31 minus 1. Now what does it mean is, if you are going to have a system in which integer is implemented as 16-bit number, then the numbers that you can store in this foreign heat can range from here to here, right? If it is implemented in a system in which integer is given 32-bit size, then the numbers can range from here to here. That is the meaning of it, right? So every variable before it is used has to be declared, and this is the statement which is used for declaration. It is simply saying that there are two variables and these two variables are of type integer. Got it? And the next one is, in the next line we are again declaring few more variables, right? So you need not use two statements to declare 5 variables separately. You could have done it in the same statement, but then you can also do it in different statements as well. Also you can declare every variable in a separate line also, which means you would have written int foreign heat, int Celsius, int lower, int upper, like that. It is all up to you, so how you want to write, okay? And the next one is lower equal to 0. So this is called as initialization. Initialization means we are simply initializing lower to 0, which means we are assuming that initial value of lower is going to be 0 before we start execution, right? And again this is a comment, right? It is saying that lower limit of the table, which means we are starting from 0. And similarly upper value is taken to be 300. It is simply saying that we are going from 0 to 300. That is the meaning of it, okay? And step equal to 20. So it is also initialization. One more thing you should understand is every statement should always end with a semicolon in C. If you miss this semicolon, it will be a compilation error, okay? Now why are we using these 3 variables is, I want to later use these 3 variables in such a way that we are going to start from 0 and we are going to end at 300 and we are going to increment in the steps of 20, okay? And these are the comments about them. And the next one is foreign heat equal to lower, which means before starting I'm assuming that initial foreign heat equal to lower, right? Now while is the loop, okay, see this. Now you can take each value, and for each value you can compute the Celsius value and you can print it there. But then by writing while loop, right? So why are we, okay, see, one more thing, this entire thing is called as a while loop. So there is while followed by this parenthesis and there is a condition inside and followed by this curly braces. Now this entire thing is called as the body of the while loop. Now why do we use this while loop is, if we have to do certain thing over and again, then instead of writing this same code many times, you just write the code once and then you put it in the while loop. Then what happens is, it will be executed once, and after executing again you are going to check the condition, and again it will be executed if the condition is true. So this one will be executed many times, right? Now for every value here for the foreign heat, I have to find out what the Celsius value is, isn't it? Now this code which is converting this foreign heat into Celsius is actually the same thing. Now I don't want to do it many times, therefore I'll just write it for one time conversion and then I'll put it in a while loop in such a way that while loop is going to take care of all the remaining occurrences, right? So now here if you observe it, while foreign heat is less than or equal to upper, which means till we are going to start from 0, isn't it? Foreign heat equal to lower means we are starting from 0, and foreign heat is less than or equal to upper means still we reach 300, which means 0 to 300. We are going to do this, right? Now what is this actually doing? Celsius equal to 5 into foreign heat minus 32 by 9. So this entire line is simply the formula used for conversion, right? So we know what the foreign heat is. Initially it will be 0, Now it will be 0 minus 32 by 9 into 5. Now you are going to get some value for this that will be stored in the Celsius. Now we are going to print. So the printf is just going to print something onto the screen. Now what is that we are going to print? Now this entire thing, this entire string here is containing %d backslash t, %d backslash t. Now if you observe it, this %d is called as type format specifier. Okay, now this says what is the format in which you want to see the output, right? Format specifier means this. So if you have to understand what it really stands for, %d, it means that, see this. Now okay, one more thing is, whenever you have this %d, after this string constant, whatever you have, it will be matched with this, right? The number of occurrences of this percentile followed by a character like this, %d, again %d is there, they should match up with the number here. Okay, now how many have you given here? 2. Now how many are present here? 2, right? Now what it means is, take the variable Fahrenheit, FAHR. Now assume that it is a 16-bit number, right? Now there will be some value present in this, isn't it? Now let us say the value present here is, I'm just randomly taking 0 0 1 0, something like this, 1 1. Now these are sequence of bits. Now what does these bits have to be interpreted as? Now if you have a sequence of bits, they can be interpreted in many ways, isn't it? If you convert them into hexadecimal, they look like something. If you convert it into a decimal number, they look like something. If you assume that this number is this entire, all the bits are representing a character, and if you find out the number of that character and go to the ASCII table, that character will look like something, right? Now here you are specifying that these bits have to be displayed as these bits have to be printed as a decimal number. That is the meaning of this one, right? So what is the meaning of %d is, this is specifying that the bits present in this one have to be interpreted as a decimal number, and you want to see the decimal number in the output printed, right? The same thing applies here. Again, the bits which are present in this variable Celsius has to be interpreted as a decimal number, and that decimal number has to be printed onto the screen. That is the meaning of it, right? Now similar to %d, there are various format specifiers, right? So some of the format specifiers I'll just explain you here. After this we shall see what these format specifiers are. Now again, if you see this, there is one more escape sequence. This is called as escape sequence / followed by t. Now what is this one specifying is, after printing the value in this as a decimal number, you just print a tab means 4 spaces, right? And again there is \n. So this \n is saying that after printing this number as a decimal, the value present in here as a decimal number, you print you go to the next line. That is the meaning of it, right? So these everything put together, they will be used for formatting the output, and so this entire string can also be called as a formatting string, right? So they are just showing what is the format that our output should appear as. That is the meaning of it. Got it? Fine. Now what will happen is, for every value of the Fahrenheit, it will first print the decimal value of the Fahrenheit temperature, and now it will give 4 spaces, and after that it will print the value of the Celsius temperature, and then it will go to the next line, right? So what you are going to see is some Fahrenheit, Fahrenheit temperature followed by 4 blank spaces, and then the Celsius temperature, and then we go to the next line and we do the next thing. Got it? And after that, Fahrenheit equal to Fahrenheit plus step, which means initially if it is 0, now it is going to be incremented by 20, and again that value will be stored in foreign, right? So before entering the while loop, we will check this condition. Only if it is right, we enter it, right? Now what is initial condition? Fahrenheit is less than or equal to upper. Initially Fahrenheit is set to 0. 0 is less than or equal to 300. So we enter it and we do this everything, and after that Fahrenheit is incremented by 20. Y step is 20, which means Fahrenheit will become 20. Now we come out of this while loop, and again we get into this, and again we check the condition. Now again we check the condition, checking whether Fahrenheit is less than or equal to upper. Now the Fahrenheit is 20. 20 is less than or equal to 300, which is true. So again we execute the same thing. Now what happens is, for 20 the corresponding value will be printed, the Celsius value, right? Now if you observe it, since both the values here, both the Fahrenheit and the Celsius, since they are declared as the integers, the output also you are going to see it as integers. Okay, we shall see there is something called as truncating. Now when I do integer division, if there is a variable integer, now if I do 5 by 2, if these two are integers, then what happens is the result is going to be automatically integers. We shall see the rules that are used by the C programming language later, but for now you understand that even though it is 5 by 2, even though you are supposed to have 2.5, this 0.5 will be truncated completely, right? And only you are going to see the integer values. Now if you want to see the fractions also as a floating point number, I'll show you how it will be done later. Okay, so this entire program is simply used to take what is the Fahrenheit value and convert it into Celsius from 0 to 300. Okay, now if you observe this, we have seen percentile D, how it is going to be used. Now we shall see various modifications of this, or various variations which are present for this one. Now if you see this here, in the previous program, if you run it, you are going to see the output like this. So it means that for this Fahrenheit, this is the Celsius temperature. For this Fahrenheit, this is the Celsius temperature. Now if you observe it, actual value has to be something like 17.8. So these are the actual values which have to be printed. 17.8 and something is there, but then we are just truncating it to only one value there, right? So after the decimal point, we are just taking one value. Now if you observe it, there is a difference between these two, right? So this is the actual value and this is the truncated value, isn't it? So why did we get this one is because we have declared both the variables as integers, and now when we perform the division and multiplication, that was all about integer division and integer multiplication. So whenever you, as I told you, whenever you divide two integers, let us say 5 by 2, now if these two are declared as integers, right, for example this is a variable and this is a variable, and if these two are integers, then in the output you are just going to see 2, you are not going to see 2.5. Now if you have to see 2.5 in the output, you have to declare them as floating point numbers, right? For that we have to use the type float. Now just to see this output, we are doing some modification here. Let's see this one. The code is modified here. Now where did we modify the code is, earlier Fahrenheit and Celsius were taken as integers, but now I am going to take it as float. Okay, and now if you observe it here, when I am converting this Fahrenheit minus some number, this number is also given as a floating point number. 32 is an integer, 32.0 is a floating point number, right? And here also 5 by 9 was there earlier. Now we have taken it as 5.0, which is a floating point number, divided by 9.0, right? Now if you see this, finally it is going to be printed as percentile 3.0f and percentile 6.1f. It means that the value which is present in the Fahrenheit, the variable FAHR, has to be printed as a number like this. It has to be printed, it has to be taken as a floating point number only, because the variable itself is a floating point number, therefore it has to match up. And how do you want to print the floating point number is, you use 3 places to represent the number before the dot, and after the dot 0 places, which means you don't want to see anything after the floating point. Okay, only before the floating point you are going to see 0. Therefore how you will see the output as, now if 0 is there, it will simply be 0. Next 20 is there, it will simply be 20, right? After point there will be nothing. And finally if you have 300, it will simply be 300. Now it is as good as writing it as percentile D, but then you are not going to write percentile D here, that will give you an error. If you write percentile D and then if you have FAHR here, that will be an error. The reason is FAHR is declared as a floating point number, and so you have to use percentile F to interpret it correctly, right? And now see why it should happen is because while storing the value in FAHR, the format of floating point will be used, and now if you write it as percentile d, it will be interpreted as a decimal number, and therefore while converting that number, see the number is when it is represented, okay, let us say there is a number 20.0, right? Now it will be represented in bits. Let us say this is some sequence which is used to represent some bits. Now when you are going to interpret it back, you have to use the same method which you have used here, isn't it? How you have converted this this number into a floating point and represent it. Now if you use a different way of interpreting it, right, let's say if you interpret it as a decimal number, then the value you get here might change. Maybe it will become something like this. Okay, so that is the reason when you are declaring a variable as a floating point number, then while printing the values content which are present in it, you are supposed to use f. But then if you don't want to see after decimal point anything, if you want to print it just as a decimal number, then you can put .0. Then you are going to see a plain like this. Now, and the number of digits here will be a minimum 3. At least 3, which means there will be a blank space here, there will be 2 blank spaces here, right, and there will be blank space here like this. Now the next one is, let us say after this you want to give maybe some space, you can put \t, then you are going to see 4 blank spaces here, right, and after that percentile 6.1f, it means that whatever result you got which is present in this Celsius has to be displayed as a floating point number only, which will contain at least 1 digit after this floating point and then 6 digits before it, right? So it means that whatever value you get, let us say it is -17.8, that will be represented as 1, 2, 3 followed by -17, which means 1, 2, 3, 4, 5, 6. So 6 digits will be used before this floating point, and then after this floating point 1 digit will be used. 6.1 means 1 digit will be used, and so 8, which means even though the number present in this particular variable is more than this one, let us say the number even is, if it is 812, that 12 will be truncated. That is the meaning of it. Got it? So this is how you can see that you can actually print the floating point numbers, and also you can print them to the precision you want depending on how much you want by using this float data type, right? So that is how we can use various data types. Okay, as we go along we shall see what are other data types available for us. Okay, now in some problems we come across a situation where we might have to execute a piece of code only if a condition is true, otherwise we want to skip that code, right? That is called as conditional execution. Okay, so we want to take execute some code only when a condition is true, which means we should have the capability to decide, that is decision making, right, to decide whether to execute a code or not based on a condition. Now we have various ways we can do it. One of the way is by using the if condition. Okay, now the keyword if will be used to do such kind of conditional evaluation. Just see this example once here. So let us say this is a program #include studio.h int main int a equal to 10. Now if a is less than 20, I want to print that a is less than 20. If a is not less than 20, then I don't want to print it, right? That is why I am using this keyword if, and I am writing the condition if a is less than 20. Only in this case, if a is less than 20, this particular statement will be executed, which means whatever is given in this block, right? So this is called as if block. So whatever is given in this block starting from here to here will be executed only if a is less than 20. Sometimes what happens is we don't know until we come till that condition whether it is true or false, right? Here it is very simple, but sometimes we might not be able to know what happens. That is why we are just going to include this piece of code in every program, and only if this condition is going to be true, then we are executing it, otherwise we don't execute it, right? Now if you want to see how the control flows in a if statement, okay, let's see the syntax here first. The syntax is like this: if you are going to give some boolean expression, right, and now depending on the value of this boolean expression, if this condition happens to be true, then only I'll execute the statements. The statements will execute only if the Boolean expression is true. Whatever statements you place here will be executed only when it is true, otherwise it will not be executed. Now let's see how the control actually flows in that case. So this is the flow control. Now if you observe it, first we are going to test the condition. Okay, now let us say it is something like this. If we have some condition, right, and then after the condition we have conditional code. If this is the case, then what happens is, first we are going to test the condition. So we are going to first test the condition. In case if the condition is true, then only we are going to execute the conditional code, which means then only we are going to execute this. If this is false, then without executing this code, we just go to the line below this code and we start executing the remaining program. Got it? Okay. Now let us say we have a situation where we have many pieces of code, and now we want to execute only one of them. Okay, then in this case also we can use if statement along with if, else if, and then else. Now let's see how to execute this. Now let us say this is a program #include studio.h main a equal to 10. Now if a is less than 20, printf a is less than 20, else if a is less than 100, printf a is between 20 and 100, else print a is greater than 100. Okay, now what happens is, initially whenever the number a is given, we are checking whether it is less than 20 or not. In case if it is less than 20, I'll print it. In case if it is not less than 20, then I'll check whether it is less than 100. If this happens to be true, then what is the meaning? It is definitely greater than 20 and less than 100. Therefore, it is between 20 and 100. So that is what I am going to print here. Otherwise, if this condition is also false, then I can declare that a is greater than 100. Got it? Now the syntax of this one is like this. See this? If, and then else if, and then else. So here I have given you only one else if, but then you can have any number of else ifs, which means you can have if, else if, followed by else if, followed by else if, followed by else if. I can have any number. Okay, now if Boolean expression 1, so these are the statements and these will be executed, this block will be executed only if Boolean expression 1 is true. In case if Boolean expression 1 is true, then these statements will be executed, and without executing any of these, we go to the end, which means we don't check this condition, we don't execute these statements, no checking, no execution, we directly go to the end, right? Otherwise, which means if this is false, only in this condition, only in that case, we go and execute this. Got it? So now if this is true, then these statements will be executed. The statements which are present in this block will be executed. Now when will these statements be executed? When this condition is false and this condition is true. Got it? Now if this condition happens to be true and if this condition happens to be false, and once you have executed the statements which are present in this block, from this block you directly go out without executing this one. Now in case if these two conditions fail, then only this default this one will be executed, right? So this block will be executed only if these two conditions completely fail, right? Now let's see the flowchart for this, right? Now condition 1, let us say you have like this: if condition 1 is there and then some statements are there, and let us say these statements are represented by block A, and then you have else if condition 2 is there and then some statements are there, let us say these statements are represented by block B, and then you have else, and in this else let us say there is block C. Okay, now how will this one execute is, first we are going to check condition 1, so condition 1 will be checked here. In case if this condition is true, then the statements A will be executed. Okay, if this condition is false, then we are going to check condition 2, right? Therefore C2 will be checked here. In case if this condition happens to be true, only in this case, if this condition happens to be true, then we are going to execute the code which is present in block B, right? In case if this also happens to be false, then we are going to execute the else code, which means block C. Now if you observe it, if you have to execute this code, both of them have to fail. If you have to execute this code, this has to fail and this has to pass. Got it? Now like this, you can have any number of else ifs, and you can have any number of pieces of code, and you can choose only one of those pieces to be executed depending on the conditions. Got it? Okay. Now here one few things you have to notice is this else is not always mandatory. You could write only if, or if with else if, right? Or if with else if and then else, right? So it is not always required that you should write else or else if. So, and also you can have nested blocks, which means I can have a if, and then inside a if I can have one more if, and along with that I can have else, right? And inside this if I can have one more if, like this. So you can have any nesting. So whenever we come across some interesting programs, I'll examine those things. Okay, fine. Now let's see the usage of if else. So here it is extension to if. In case if you are using only if, only some part is skipped and immediately we are going to the other one. Now if we have two types of statements, let's see this example here. Now hash include studio.h int main int a equal to 10. If a is less than 20, printf a is less than 20, else print a is greater than 20. Right? Now if you observe it, depending on the value of a, either this statement has to be printed or this statement has to be printed. Any one of them have to be printed. If the condition is true, this statement has to be printed. If the condition is false, this statement has to be printed. In this case, if else will be very useful, right? So whatever statements that have to be executed, if this condition happens to be true, will be written in the if block, and whatever statements that have to be executed if this is false will be written in the else block. Therefore we are going to have if block and else block here, right? Now let's see the syntax here. Syntax is if followed by a boolean expression. So here you are going to have a boolean expression, and based on the value of this expression, whether it is true or false, if it is true, this block will be executed, right? If block. Otherwise, if it is false, then this block will be executed. Now let's see the flow of control here using a flow chart. Now the condition given in the if will be tested here. If the if condition is true, then the conditional code of the if will be executed, and if it is false, then it will be executed, which means if you want to see it this way, if condition is, let us say A, then let us say I want to execute this statement B, else let us say I want to execute statements which are represented by C, then A will be tested here. In case if this condition happens to be true, then the code which will be executed is B, right? In case if it is false, then the code which will be executed is C. That is the meaning of it, right? Now either you are going to go to the next line, either after executing the if block or the else block. Therefore at least one of them will definitely be executed. Okay, fine. Now let's see a simple program which is checking whether a number is even or odd. Now if you are planning to use some printf or scanf statements, then we are always going to include standard io.h. Okay, now we have to run this program, and so you are supposed to have main function and you need not pass any arguments to it. Generally it is a convention that we have to put some return type. Still now we have been putting void or int. We shall later discuss, while we discuss about the functions, what is the meaning of it. For now we assume that this is either you can put void or int there. Okay, now let's try to have a integer number. Okay, and let us try to read something into this number first. Okay, so I'm going to write a statement onto the screen which will ask the user to enter a number. So enter a number. Okay, now after seeing this, the user will enter something onto the screen and we are supposed to read it. Now generally printf, when we use like this, it is going to print the string onto the output screen, right? Now let's say whatever the user has entered, I want to read it. Okay, Now where do I want to read it is into this number, and what is the type of this variable? Integer. That is why I am going to specify percentile d, which means read the number as if it is a decimal number, and then store it. Now you are supposed to give the address of this one, right? Where do you want to store the number which is read from the user is, you have to give the address. Address is given by ampersand, right? So ampersand number means this is nothing but the address of the variable number, right? So what we are trying to do is to this function scanf. This scanf, exactly like printf, is a library function. Printf is used to print something onto the screen, and scanf is used to read something from outside, right? And generally it is from the keyboard. Now from the keyboard we are reading this. Okay, what is that we are reading? Percentile d. We are reading this number into this address. Okay, now every variable is supposed to have some address. Now let us say this is the name of the variable is num. If I write ampersand, right, it means that the address of this will be returned. Now once you have read the value into num, this number, the variable number, you can test whether this is even or not. If num, let us say percentile means this is modulus operator. If number modulus 2, so the meaning of this one is what is the remainder of the num, this number, when I divide it with 2. In case if this remainder happens to be 0, right, then we can printf number is even, right? Otherwise, else we can printf number is odd. If it is not even, it is going to be odd. Got it? And you can close it. Okay, so this is how you can read. Now what about this printf and scanf? These are the library functions. And where are these declarations? Generally before you use a variable or a function, you are supposed to declare it. Now see this, before using the number I have declared it. Similarly before using this function you are supposed to declare it, but declaration is not here. That is why I am including this header file. Now this header file will contain all the declarations required in order to execute these two functions. Okay. Now one thing you have to observe here is, depending on what type of number it is, either this statement will be printed or this statement will be printed. If this condition happens to be true, then this number is an even number, then printing this statement is right. In case if this is odd, then printing this statement is right. Now if you observe it, one more thing, we have given that the main is returning some value of type integer. So for that reason you have a return statement here, right? So return, let us say 0. Now why is this useful is, it will just tell the calling function what is the status of this particular program is, right? Now who is calling this function is operating system will start executing it. So once the execution of this program is done, the status will be sent to the operating system. Then operating system can look at the status, and depending on it, it will guess whether it is successful or failure. Okay, anyway you need not worry about it. Since I am using int here, I am trying to return something here, right? You have written something, otherwise there will be an error. Now if in case if you don't want to put any return statement here, then you just use void. Okay, fine. Now let's see this question. Find the largest among three numbers. Let us assume that all these three numbers are distinct. Okay, now in this case what we can the one way of writing the program is this: hash include studio.h. Okay, now let us say this is the main function. Okay, now main, and let's not have any return type, so either you can have int or void, whatever it is, fine. Okay, now you are going to have hash include studio.h. Okay, now let's see this. First one is, we are having three numbers and we are going to read all the three numbers from the users, right? So enter three numbers, percentile d, percentile d, percentile d, ampersand n1, ampersand n2, ampersand n3, which means the three numbers which are entered with a space between them will be read into n1, n2 and n3. So address of n1 and address of n2 and address of n3 are given to scanf, right? So now I want to test if n1 is greater than both of these numbers. Therefore I am writing this: if n1 is greater than n2 and if n1 is greater than n3, right? So if both are greater, okay, if n1 is greater than both n1 and n2, then I am going to print the largest number is n1, right? So I am going to even print that value. Next, if this is not the case, right, even after checking this, I am going to go here and again I am going to write this. So if I want to check whether if n2 is greater than both of them or not. If n2 is greater than n1 and n2 is greater than n3, which means if n2 is greater than both n1 and n3, I am going to print that n2 is greater. Now finally I am going to check if n3 is greater than n2 or not, both of them or not. If n3 is greater than n2 and n3 is greater than n1, then definitely n3 is greater. Now if you see this, all these three if statements will be executed even if the first if condition is valid, isn't it? If all the three numbers are distinct, right, if all the three numbers are distinct like 10, 20 and 30, only one of the number is going to be greater and therefore only one statement has to be executed. And once you have found out that statement, you need not evaluate the statements below. For example, if n1 happens to be greater, then you need not execute this and you need not execute this. But then the way we have written these statements, it is making sure that even after finding out that n1 is greater, still these two conditions will be checked, right? So just to avoid that, you could have written it this way: if this is true, then you check this. Only if this is false, then only you have to check it. For that reason, I had to add else. Now by adding else, what happens is, only in case if this one is false, then only this one will be checked. In case if this one is true, this one will be skipped, right? Now let us say this is false, then this one will be checked. Now in case if this is false, then only if it has to be checked, you can add else if again, right? This is one way of writing it. Otherwise, if this one is false and this one is false, definitely it means that n3 is greater. What does it mean? n1 is not greater, n2 is not greater, then definitely n3 is greater. Then there is no need of checking the condition at all. Then you can simply remove this completely and you could have written it as else printf %d n3 is greater. So this is the best way of writing it, okay? Now one other way of writing it is without using if, else, if and else, you could have even used nested ifs. Nested ifs means there could be an if statement inside some other if statement, right? Now let's see this. Now instead of these three statements, this part, I'm just going to replace this part with some other code. That code will be looking like this. See this? If n1 is greater than n2, then again inside this block, again n1 is greater than n3 is compared and again else is there. Now this if has to be matched with this else and this if has to be matched with this else and this if has to be matched with this else. In C, the rule followed is every else has to be matched with the closest if, right? Therefore for this else, the closest if is here, and for this else the closest if is here, got it? And for this else the closest if is here. Okay, now see this one. If n1 is greater than n2, if this is true, then what does it mean? Out of these two numbers, n1 is greater. Now we go inside this loop and we execute the if part, which means we execute this entire code, right? Now here again, if n1 is greater than n3, if these two are true, then definitely n1 is greater. Therefore we are going to print that n1 is greater, and once you have printed this, there is no need of going into this else because this if is already, this condition is already true, so we don't execute this condition. Similarly, when we come out of this, since this happened to be true, this else will not be executed, and that is where we are going to end. Otherwise, what happens is, in case if this happens to be false, or let us say if n1 is greater than n2, this happens to be true, and then now if n1 is greater than n3, this is false, then what does it mean? n1 is definitely greater than n2, but n3 is greater than n1, therefore n3 must be the greatest. That is why printf n3 is greater. So this statement will be executed. Are you getting this? If this one is true and if this one is false, then this statement will be executed. right? Now let us say this one happened to be false, which means n1 greater than n2 is false. What does it mean? n2 is greater than n1, right? Now you are going to go here and execute it. Now already n2 is greater than n1. Now we'll check whether n2 is greater than n3 also. In case if this is the case, right, which means n2 is greater than both n1 and n3, then we can say that n2 is the largest element, therefore this is printed. Otherwise what happens? n2 is greater than n1 but n3 is greater than n2, then in that case n3 is largest. We'll print this. Got it? So this way of writing it is using nested if else, right? Both of them will work. Okay, if you have to write a program using a multi-way decision statement, multi-way decision, then the best way to go with it is using a switch statement. Now I'll just take an example and I'll show you what I mean. Let us see this program. Hash include studio.h, void main, int weekday, printf, enter weekday, scanf, %d, ampersand weekday, which means we are reading into the variable weekday what the day it is, right? Now assume that if the user has entered 0, it means it is Sunday. If the user has entered 1, it means it is Monday, right? Or let's say if a user has entered 0, it is Monday, and 1 means Tuesday, 2 means Wednesday, so on, 6 means Sunday. So 0 to 6 user can enter any number. Depending on the number you have to printf what he has, what the day it is, right? Now how you can write it is, if you directly use, let's say, if statement, then you have to compare like this. If weekday equal to 0, then printf it is Monday, else if weekday equal to 1. So like that you might have to write. If I have to write it using if else, then I have to write it like this: if weekday equal to 0, then I have to printf, let's say, Monday, right? Else if weekday equal to 1, then I have to printf Tuesday. Like this I have to keep on writing it. Now one other way of writing this in a better readable manner is using switch statement. Now what does the switch statement do is, see this: switch, to the switch we are going to send as the argument weekday, which is a statement, and now we are going to have various cases in it. In case if this weekday happens to be 0, then this case will be taken, right? Then what will be printed is Monday. In case if this weekday happens to be 1, if the value of this weekday happens to be 1, then this case will be hit. We will not be printing this, we directly go to this case and we are going to print it that it is Tuesday. Like that, if it is any values between 0 to 6, we go to that exact case and we are going to print it. Now if this is there is no match here, which means weekday has taken a number which is not between 0 and 6. If it has taken, let us say, 7, then default case will be a hit and we are going to print enter a valid input, which means the given input is not valid. Now one more thing you have to observe here is, at the end of every case we are writing the break statement, which means how many other statements we have in each case, at the end of it we are going to write break statement. Why is it important is, in case if case number 0 is hit, and if we have not written all these break statements, then what happens is, after this case number 0, it will execute every case, right? Now in case if you write break, it means that this case has been hit, therefore you come out of this switch completely. That is the meaning of it, right? So whenever you hit break, it means that you come out of this completely. Got it? Okay. Now few points to remember about this switch cases. Whenever you have this case, after this case only integers are allowed, only integer values are allowed, and you are not supposed to have anything other than integers, which means you cannot have any floating point number here. You cannot write 0.1, 0.2, something like this. You are supposed to have only the integers here, okay? And in case if you have an expression, that expression should also be a that should contain only the constants, okay? It should not contain any variables, okay? So here no variables are allowed. And also if you observe it, two cases cannot have the same number. I cannot say this one also has case 1 and this one also has case 1. Every case should have a different value, Okay, and these values whichever you have given, they need not be contiguous, which means you can give for case 0 and then let us say case 5, that's it, and you need not have all the other cases as well. And having a default is just a optional, and it is better if you use it. That is how you can understand that no case has been hit. If no case has been hit, you will not be able to know if you don't have any default saying that enter a default valid value. And default need not always be present at the end. It can be present anywhere. It can be present at the beginning, or it can be present in the middle, or it can be present anywhere. Okay, so all these values should always be integers. Okay, now let's try to write a small program in order to build a simple calculator. So here I am assuming that we are going to implement few operations, few binary operations, and since we are talking about binary operations, we are supposed to read the operation, the kind of operation from the user, and 2 operands. Okay, so before looking at the code that I have written, you please try the code on your own. Maybe you try to write it using if else. I have written it using switch. Okay, now let's see how it works. Now first thing is void main character operator. Now I am going to use the operator variable in order to read a character from the user. Okay, and then double a comma b. So a and b are used. These are the 2 operands which are going to read the value from the user. Printf, enter an operator from these options: plus, minus, star, divided by, and modulus. And whatever the user enters, we are going to read it into this operator variable. Okay, that is why %c ampersand this variable. And now printf, enter 2 operands. So we are going to ask the user to enter 2 operands, and whatever he enters, we are going to read them into a and b, right? So lf is the format specifier for double. Okay, and switch operator, which means we are using the switch, and in the case we are using all these values of the characters that have been entered by the user. Now as I told you, if you remember, after the case we are always supposed to have integers, and as these are actually integers only, right? Now what are these integers? These are the numbers which are representing these characters in the ASCII code, right? Even though you are looking at a character here, when you write it using this single quotes, it is giving us the number with which we represent this in a ASCII code. Okay, and now therefore switch is going to this is all actually integers, and if this operator matches it with plus, then what is that we are supposed to do? Addition. So that is why we are doing addition, and also we are printing it. Addition of a and b is %lf a plus b, right? And similarly, if it is minus, then we are doing subtraction, and we are printing subtraction of a and b is %lf a minus b. And in case if it is star, it is multiplication, then I am printing multiplication of a and b is %lf a into b. Like that we are printing, and after each case we are putting break, so that whenever a case is hit, we are not going to print all the remaining things. Got it? Now we didn't use default here, so it is better you write default as well. You can have a default case, and you can write printf, please enter a valid operator. If the operator doesn't match with any of this, then none of these cases will be hit, and so you will go to the default case if we have it there. Okay, fine. Now sometimes what happens is, in a program we might have a need that we have to execute certain piece of code over and again many times, right? In that case, writing the same code again and again is not very meaningful. So just to avoid this trap, C programming language has given us a construct called as while. So there are many constructs. First let's look at the construct while. Now using while, if you put a piece of code inside this while loop in the body of the while, now the same code will be executed many times depending on how many times you want to execute it. Okay, so now let's see this example. So void main int a equal to 10 while a less than 20, printf a value is %d a plus plus. Now what happens is, initially a value is 10, right? So whenever a value is 10, then we get into this while, and we check this statement: a is less than 20. Yes, 10 is less than 20, which is true. Therefore it will print a value as 10, right? After that it is going to do a plus plus. Then what happens? A value will become 11. Now again it will come out and again it will test. A is less than 20. Yes, A is less than 20. 11 is less than 20. Again it will print A value 11, right? So on, it will keep on printing until this condition is going to fail. When A value becomes 19, it will be printed A value as 19, and then A plus plus will happen, which means A value will hit 20. Now it will check if A is less than 20, but then this condition will fail. A is not less than 20, therefore we are going to come out of the while loop, right? Now let's see the syntax of this, and also with the let's see the flow of this with a flow chart, how the flow happens. Now the syntax is going to look like this. While there will be a condition, first we check the condition, and only if this condition is true we are going to execute this statement. Now one thing you should be careful is you have to write a statement inside this while loop which will at some point make this condition false. Otherwise, if you keep on if this condition is going to be true all the time, then you might fall in infinite loop. So just to see that it doesn't happen, you have to have some lines inside this while loop itself in such a way that at some point in time this condition will become false even though it is initially true. Got it? Now how does this work is, first we are going to check the condition. In case if the condition is true, then only we are going to execute this block, and after the block is done, and again we are going to go back and check the condition. In case if it evaluates to be true, again we execute it. Therefore this code will be executed, the block which is present here, this code will be executed as many number of times as you want, depending on how you set this condition, right? In case if this condition happens to be false, then you go out without executing this body of this while loop. Now one thing you should observe about this while loop is, now initially if this condition happens to be false, then this might be executed even 0 times, which means we might never enter the while loop if this condition happens to be false right away in the beginning. Okay, fine. Now while discussing about while, I told you that there is a chance that the statements present in the while might not be executed at all, right? Now if you want the statements to be executed at least once, irrespective of what the condition is, then it is better you go with do while. Now I'll just show you what the difference between while and do while is. Now see this, int main, int a equal to 20. Now do and while is going to be here. So this is how you are going to write it, do followed by the body of do and then ending with a while, right? And the condition is going to be present inside the while, and here you are going to have the body. Now initially a is equal to 20, right? And when you start executing this, so initially do will be seen, and now it will execute this statement irrespective of what this condition is. It is not going to look at the condition at all. It is going to right up execute these two and then look at the condition, right? Therefore it will print a value is %da, which means it will print a value is 20. Okay, a value as 20. So this is what it will be printed, and after printing the a value, a plus plus will be done, and now it will test the condition. Now a is less than 20. Now the value of a is 21. Now 21 is less than 20 is false, and so executing this code will stop. Fine. Now what is the difference between while and do while here is, if you could have written the same condition in a while, and if you had placed while here instead of do while, then the right away this condition will be false and the statements will never be executed. Got it? Now let's see the syntax of do while along with the flowchart. Okay. Now if you see the syntax of the do while, it is going to look like this: do statements and then while followed by condition semicolon. Now we are going to put the statements here and do here and then while here, and the condition will be placed here followed by semicolon. Now how will the flow look like is, initially without testing the condition at all, will right away execute the code which is present in this block. So whatever is present in this block the code block that will be executed, and after the executing the code block, then we are going to test this condition. So we test the condition. In case if the condition happens to be true, then again we get back and execute the code. If the condition happens to be false, then we leave the block and we come out. Okay. Now similar to while loop, we can use for loop as well. So if we have a piece of code and if we have to execute it over and again, then instead of writing it many times, just write it once and put it in a loop and see that loop executed many times, right? Now that is what we did with while and do while. Exactly the same way we can use for also. So let's see how this for loop is going to work. Now the syntax of for is going to look like this. For, there will be some initializations followed by condition, and this is the condition which will be checked, okay, and then followed by either incrementation or decrementation. Here just we have written some increment. It could be either incrementation or decrementation, and then followed by the code, right? So what is the sequence in which all these will get executed is, first we'll execute all the initialization statements which are present here. There can be many initialization statements, or there may not be anything, right? Which means this is either optional or you can put any number of statements there, initialization, okay? After that you are going to have a condition, right? So after initialization is over, we are going to check the condition. In case if the condition is true, then we are going to execute the conditional statement. In case if it is true, then we are going to execute the this conditional code. The code whichever is present in this block, that entire code is going to be executed. Now after this is done, then we go to this part. This can be either increment or decrement or whatever the statement here present is, we are going to execute it, okay? So after this we are going to execute it, and again if after this one is over, we are going to execute the condition, and again if it is true, we are going to come here. In case if the condition is false, we are going to go to the next statement, okay? We are going to come out of the for loop and we are going to go to the next statement. Now if you look at the flow is like this: initialization first, and then we check the condition, and then if the condition is true, we execute this code, and after this code is over, we go here either increment or decrement, and again we check the condition and again the code, like this, okay? So this is how the loop is going to work, okay? Fine. Now let's see an example using which will demonstrate the usage of this for loop. Now see this: for a equal to 10, a less than 20, a equal to a plus 1, printf value of a colon the value percentile d a. Now this entire statement is going to start with this, right? The for loop is going to start with this initialization statement. Now the initialization statement is saying that a has to be equal to 10, right? Therefore initially a will be initialized to 10, and now it will check the condition: is a less than 20? Yes, a is less than 20, therefore it will execute this statement, right? It will execute this statement, and the output will be value of a colon whatever the value of a is. Initially a is 10, therefore 10 will be printed. Now after this one is done, again we are going to come back. After this statement, we are going to do this incrementation. Then what happens? A will become a plus 1, which means 10 will become 11. Now again we check the condition, right? Yes, 11 is less than 20, therefore again the statement will be printed. Therefore again value of a is 11 will be printed. So on, the statement will be printed many times until this condition fails, right? Now let us say value of a is 19, 19 is still less than 20, therefore it will be printed. After that, when you increment the value of a, now it will become 20. Now after this, if you check this, 20 is less than 20, the condition is going to fail, and so we are going to come out of the for loop, right? So this is what the output is. Now if you see this, the same statement printf has been executed 10 times. Just by writing the statement once, we are able to run it 10 times without writing it actually 10 times. Got it? That is the advantage of these constructs. Okay, fine. Now let's see, this is a program. So write a C program to calculate the sum of n natural numbers, which means we want to find out the sum of first n natural numbers. Okay, now what it means is, if you see the natural numbers 1, 2, 3, 4, so on, let us say first 5 natural numbers, then we want to add all this. Okay, now how to add them is, we might have to use the same statement again and again. So initially if you assume that sum is equal to 1 or sum is equal to 0, then to that sum we are going to add 1, and again to the sum we are going to add 2, and again to the sum we are going to add 3. So therefore I have to write something like this: sum equal to, if you assume that sum is going to store the final sum equal to sum plus, let us say, some number here, right? And this has to be executed over and again. Therefore it is better that you use a loop, a construct which is going to use the loops like for loop or while loop or do while. Now we shall see for loop. I'll just write the program using for loop. You can try it using while loop or do while loop. Now let's see how the program is written. Int n, I and sum. So n is the number that we are going to read from the user. Now it is going to say how many natural numbers they want to add. Now printf, enter the value of n, scanf %d %n. So using these two statements we are going to read from the user what is the value of n. Okay, and now for I equal to 1, I is less than or equal to n, I plus plus. So if you observe it, so initially I is initialized to 1, which means we are starting with number 1 and then we are going till number n. Therefore 1 to n we are covering everything. Okay, and every time we are incrementing I by 1. I plus plus means it is also equivalent to I equal to I plus 1. Okay, sum equal to sum plus I. Now what is that we are doing? Every time we are initializing sum to 0, and every time we are making it or we are incrementing it by I. So what will happen is initially sum will be 0, right? And now I equal to 1. So I is less than or equal to n. Let us say user has entered n equal to 5. Then what happens? 1 is less than or equal to 5. Yes, the condition gets satisfied, and now to the sum I is going to be added. So to the sum 0, I is going to be added. Here it is going to become 1. Now after this I is going to be incremented. Now if I increment I, now I will be 2, right? And again 2 will be checked with 5. 2 is less than or equal to 5. Therefore again to the sum 2 will be added, which means to 1 2 will be added, which means already it is having a value 1. If I add 2, it is going to become 3. That is the meaning of it. Now it is going to go on like this until we reach 5. So even when I equal to 5, still we enter the loop and 5 also will be added to the sum. Finally after this I reaches 5, when I do I plus plus, I will become 6. At that point 6 less than or equal to 5 will fail and we come out of it. And finally we are going to print the value. Now if you observe it, this is the heart of the program, isn't it? Now you can actually replace this either using a while loop or a do while loop. So you can do it as an exercise. Just change the program to using while loop and do while loop. Okay, fine. Now let's see this program. Write a program to read input until user enters a positive integer, which means user is going to give us some numbers, and as long as he is going to enter the negative numbers, we are going to read them all. But then whenever he hits the first positive number, we are supposed to stop, right? So now let us say the program is like this. So hash include studio.h, int main, int n. Now we are going to use do while. The reason why we are using do while is the best loop execution when you need not, or when you don't want to check the condition initially, and if you want to execute the statements at least once. The difference between while and do while is, in while, before executing the body of the while condition will be checked and then only it is going to execute. But in do while, we execute the body first and then check the condition to test whether we should execute the body again or not. That is the main difference. Now for this program, using do while is exactly going to fit, because we have to first read one element, then only we can decide whether we should continue reading or not, right? Before doing that we cannot do that, we cannot continue it, right? Now see this. Now printf, enter a value. Now user will be asked to enter a value. Now whatever value he is going to enter, we are going to read scanf %d into n. Okay, we are going to provide address of n, and into the value n we are going to read it, right? Now while n is less than or equal to 0, so as long as n is 0 or it is less than 0, which means it is not a positive number, we are again going to execute it. right? So the logic has been followed. Now as long as user is going to enter negative numbers or 0, we'll keep on asking the user to enter more values. Whenever he hits the first positive number, then what happens is this condition is going to fail, right? Then we are going to stop, right? Finally, whatever value he has entered, now when you come out of this loop, you have come out of the loop only when he has entered a value which is a positive value. We are just going to print it, right? Even though it is not necessary, we are just going to print it. And since you have given int here, I am just going to return 0. If you would have given void, there is no need to return it, right? We shall see it later anyway. Okay, now let's see this program. Now using this program, we'll be learning a usage of a new statement called as continue. I'll just explain you with this example. Write a C program to read 15 integers from the user and print the sum of only positive numbers. Now it means that you are going to read 15 numbers from the user. So you'll keep on asking the user to enter a number. Now let us say he's entering numbers like this. So 1, 2, -1, -3, 5, something like this, so on. He has entered 15 numbers. Now in these 15 numbers, we want to find out the sum of only positive integers and we want to print them. That is what we want. Now let's see how to run it. Hash include studio.h void main int n I sum equal to 0. Now for I equal to 0, I less than 15, I plus plus. So this is initialization, I is initialized to 0, and we are going to go till I reaches 15, which means as long as I is less than 15, we are going to execute these statements. Therefore these statements will be executed when I equal to 0, and since it is incremented in steps of 1, right? So every time I is incremented by 1, initially when I equal to 0, this will be executed, I equal to 1, this will be executed, 2 executed, 3 executed, so on till we reach 14. They all will be executed, and once we reach 15, we will not execute these statements, right? Therefore if you see how many times we enter this for loop, it is going to be 15 times. For I equal to 0, 1, 2, so on 14. If you count all this, it is going to be exactly 15 times, right? So 15 times we are going to enter this for loop, and every time when we enter the for loop, we are going to ask the user to enter an integer, and then we are going to read it into n, and we are going to test whether the number that is entered by the user is a negative number or not. In case if it is a negative number, if it is not a positive number, let us say n is less than or equal to 0, then we are going to write continue. Now this means that if the number is not positive number, right, then don't execute the statements after this continue. You just go to the incrementation directly from here. This is the meaning of it, right? So whenever you hit a continue statement, it means that you just don't execute the statements remaining in this block. Just go to the incrementation or decrementation, whatever you have here, and from there you go to the condition, and again you start everything. That is the meaning of it. Now why should we use this is, if the number is negative, you again go back and ask for the next number. Whenever you get a positive number, you add it to the sum, right? Sum already formed till then. Therefore we are going to ignore all the negative numbers, and for only positive numbers we are going to add them to the sum, right? So that is why this continue is going to be used, right? And now continue can be used both in the for loop, while loop, and do while loop. In all these we can use continue. Now what is the meaning of continue is here. So anyway we are going to print the sum at the end. Once you come out of the for loop, then we are going to print the sum. Okay, now how the continue is going to be helpful is, in case of for, let us say we have initialization, condition, and then incrementation here. Now let us say somewhere here there is continue. Okay, so for loop we are going to enter the for loop, and whenever we come across continue, we are going to get into this incrementation or decrementation, and after that we are going to check the condition. If the condition is true, again we start executing this entire thing, right? So whatever code is present between continue and the closing of this block, this loop, all these statements will not be executed once we execute continue, but then we'll continue to be in the for loop, and we'll do the same thing as you do normally, right? Now in the while loop also the same thing will happen, right? In the while loop what will happen is, if you have a condition here and the while loop, now whenever you come across a condition, right, now whatever this continue condition, let us say we come across the continue statement, and if the condition here given above the condition continue is true, which means if we execute this continue, what happens is whatever statements are between the continue statement and the closing of the while loop, all these will not be executed, they will be skipped, and from here control will directly go to this condition and it will check it. In the for loop, control will directly go to the incrementation or decrementation, from there it will go to the condition, but in the while loop control will directly go to the condition and test the condition, and it will decide whether to continue or not. Okay, now if we observe it, generally we have a habit of writing this incrementation or decrementation statements in while loop at the end, isn't it? But then if you try to put it there, now once the continue has been hit, right, then the problem is sometimes you might not be able to increment or decrement the statement here, and so you might fall in a infinite loop, right, if every time if continue is going to be hit. Therefore you have to be careful while using while loop and continue in such a way that you don't fall in the infinite loop. Okay, fine. Now if you observe it, the flow of control, it is, this is the way you are going to see. Let us say you are inside the conditional code, right, either in the for loop or in the while loop, you are in the body of the code. Now assume that you have come across the continue. Now if you are in the continue, generally in the for loop you will come to the incrementation or decrementation and then the condition, and once the condition is executed, if it is false we come out of the loop, if it is true again we go and execute it. In case of while loop, what happens is inside the body if you come across the continue, now you will directly go to the condition and again we do the same thing. If the condition is true we execute the entire body again, if the condition is false we come out. Okay, fine. Now let's see this program. Write a C program to read integers until user enters a negative number or number of integers read reaches to 15, which means you are supposed to read the integers either till you reach a count 15 or till the user enters a negative number, right? So what it means is, let us say user is entering, you are asking user to enter the numbers and the user has been entering the numbers like this 1 2 3 4 something like this, and he didn't enter any negative number, then you are going to read all the numbers which he is entering. Let us say he has entered 15, you are supposed to read them. Now in case if user has entered something like this 1 5 then minus 5, then you can stop there and you don't ask the user to enter any more numbers, which means either let him enter either 15 numbers or in between if he has entered any negative number we are going to stop there. That is the meaning of it. Okay, now let's see the program. Hash include studio.h, void main, int n, count, I. These are the variables which we are going to use in this program. Now for I equal to 0, I less than 15, I plus plus, which means we are starting from 0 and we are going to execute it till I reaches 14. Even when I reaches 14 we are going to go into this and we are going to execute it. Therefore the maximum number of times this particular code will be executed will be from I equal to 0 to I equal to 14. Now if you count from 0 to 14 it will be 15 times, right? Whenever I becomes 15 this condition will fail and so we come out of it. But then we have to be careful that it is not just about asking the user to enter a number and reading it. After they enter the number you have to test whether it is a negative number or not. In case if it is a negative number we are supposed to come out of the loop. That is extra condition we have. Now whenever we have such a condition, writing simply a for loop is not going to be sufficient. Now see, just observe this. Once you enter the for loop, if it is written this way, the only way you come out of the for loop if you don't use anything else is when this condition is going to fail, right? Now we can check only one condition in general, right? If you have to check two conditions you might have to write it using ampersand and you had to write it. Now let us say you have one more condition or even more conditions. Now if you don't want to put them all here, right, then the best way is use a break and then a condition there. Now how does this one work is, now we are asking the user to enter a number, and after he entered the number you are going to read it, and after you have read it we'll test whether it is a negative number or not. In case if it is a negative number, we are going to execute a statement called break. This is a special statement. Now whenever you use this break statement, even if this condition is not false, will come out of the for loop which is enclosing this break, right? So this particular loop, this particular break is enclosed in the body of this for, right? Now if whenever you touch this break, you are going to come out of this for loop, which means we'll come out of this and we execute the next statement after this one, right? So that is the advantage of break. So break is used whenever you want to come out of a for loop or while loop or do while loop, even without checking this condition, even without going till that condition, right? Now in case if you have many for loops, let us say like this, we have a for loop here, let us assume that some condition, initialization, everything is there, and inside the for loop again you have one more for loop, initialization, condition and incrementation, let's say something like this, okay? Now if you come across a break in the body of this for loop, then it means that you have to come out of this for loop, right? But then you have to start executing this for loop. Now in case if you have to come out of this particular for loop using a break, then you are supposed to write this in the body of this particular one, which means either you have to put it here, either break, or you have to put it here. Whenever you hit the break either here or here, then you are going to come out of this for loop, right? Now just see the flow of control, how it is supposed to work when you are going to have a for loop. Now let us assume that you are executing the code which is present in the conditional code block. So conditional code block means, let's say we have a for loop like this, right? And now this is the block we are talking about. This is called as the conditional block in this case. Now in this conditional code, when you are executing it, if somehow if you are able to hit the break, because the condition above the break is true, right? Now let us say there is a if condition here and then there is a break. Now somehow if you hit the break, then we don't go anywhere, we simply come out of this loop and we execute the next statements following that for loop or whatever loop we are present in. Now in case if you don't come across this for loop, then only after executing this entire conditional code we are going to get back and check the condition, assuming that the incrementation or decrementation is already included here. Now we check the condition, and if the condition is true, we will keep on executing the loop. So we will be in this loop as long as the condition here is satisfied and we don't come across a break. Now we come out of the loop either when this condition is going to fail, or let us say this condition is here, either when this condition is going to fail we are going to come out of the loop, or when we hit a break we are going to come out of the loop, right? Therefore in order to exit from a loop, now we have two cases. Whenever we hit a break we are going to come out of it, or whenever the condition is going to fail then we are going to come out of it. And we have seen already where break is used in switch. In switch, just to come out of the switch after executing a case without executing the remaining cases, we are using the break. Similarly here also we can use the break in order to come out of either for or while or do while loops, okay? Now let's see this program. Write a C program to check whether a number is prime or not. Now what is the definition of a prime number? There should not be any factors other than 1 and itself. If you find such a number, that is a prime number, right? So what is the logic we are going to use in this program is, before going into this I'll just give you an example. Let us say 24. If you want to check whether this 24 is a prime number or not, now you have to test if the numbers from 2 to 23, if all these numbers are not going to divide it. In case if any of these numbers divide it, then we can say that it is not a prime number. We know that 1 divides it and we know that 24 divides it. Now a prime number testing will be useless if you test with these two numbers, right? Therefore you have to test only with these numbers. Now one way is you can start from 2 and you can go till n-1 and you can test for every number whether it is divisible or not. but then you can do something better. So what I'm trying to say is, let us say this number is having more factors other than 1 and 24. So what are the factors it has? One is 2 and the other one is 12, right? And what are the other factors? 2 into 12 is 24. Similarly 3 into 8 is 24, and similarly 4 into 6 is 24, isn't it? Now if you observe this, one thing what you can do is, all these 2, 3 and 4 and this 12, 8 and 6, they will fall on two sides, or if you look at the square root of this number. Now what is the square root of this number? 24. It will roughly be 4 point something, isn't it? Let us say 4 point something. Now one of these factors, if you have this, if you are going to have 2 into 12, 3 into 8, 4 into 16, one of these factors will be less than 4 point something and the other factor will be greater than 4 point something. Therefore, if you can find one of these factors, it is enough. You need not find the other factors, right? So you need not check all the numbers. You can just check till root n. If you don't find any factors till then, there will be no factors after that. Are you getting this? If for 24, if you are not able to find any factor till root 24, then definitely there is no chance that you will find any factor after it, because if the number can be written as a product of two numbers, one of the number is going to fall here and the other number in the pair is going to fall here. If you don't find any number here, then there is no way that you can find any number there. Therefore, you need not go and execute the code for all the numbers till n minus 1. You could stop till root n. That is the best way to solve this one. But since we didn't tell you anything about the mathematical library or how to find out the square root of a number in C, let's take some other number instead of taking root n. So a number which is greater than root n, which will be simple to compute, is n by 2. Right? So at least by using n by 2, we are not computing the divisibility for all the numbers. We are just computing the divisibility for half of them. Right? Now let's say we'll start with 2 and we'll go till n by 2, and if you are going to find any number as a factor, we can declare that it is prime number. And if you are not able to find any factor, it means that we have checked from 2 to root n as well, and we are not able to find any factor, and after that there is no way we can find any factor, right? Then we can declare that it is a prime number. That is the logic we are going to use. Now see this, hash include studio.h void main int n I flag equal to 0, enter a positive number. We are asking the user to enter a positive number. Whatever positive number he has entered, I am going to read it into n. So %d ampersand n. Now I'll start checking. I'll start from I equal to 2 and I'll go till n by 2, because the strict way is to go till root n, but you don't know how to find the square root. That is why I'm going till n by 2. Anyway, if I reach till n by 2, I would have already crossed root n. That is why we are safe, right? So I equal to 2, I less than or equal to n by 2, I plus plus. I plus plus or plus plus I both are same in this case. Okay, it means that it is simply I equal to I plus 1. Now for every number here, I am testing the remainder when I divide with this, which means I'll divide the number with 2 first, and then 3, and then 4, and I'll test every time whether it is divisible or not. Divisible means if the remainder is 0 or not. In case if the remainder is 0, it means that this particular number I is a factor of n, right? In that case we can stop. We need not execute the for loop further. At least if you are able to find out one factor, you can stop it there, right? That is why I'm calling break in case if it is the case, and also I'm including flag here. So when flag equal to 1, see this, what does it mean? If you are going to come out of this code, there are two ways you will come out of this code. Either when I has increased by I is more than n by 2, in that case you come out of this loop, or the other case you come out of the loop is by break. Now before you reach the break, you would have already seen this statement flag equal to 1. Therefore by the time you come out of the for loop, if flag equal to 0, it means that you came out of the for loop because this condition has failed, which means you have checked all the numbers from 2 to n by 2 and you are not able to find any factor, and so you can say that it is not a prime number, isn't it? If flag equal to 0, it is not a prime number, right? It is not a prime number, isn't it? Let me just check it here. If flag equal to 0, what does it mean? This statement has not been encountered, right? If this statement has not been encountered, then what does it mean? Okay, there is no, yeah, right. If the statement is not encountered, then it means that no number is actually dividing n, which means we didn't find any factor, and so it is a prime number, right? Else, if flag equal to 1, which means if flag is not equal to 0, then it is going to be 1, right? In that case, what would have happened? If flag equal to 1 means there is a number which is dividing n, because of that flag has become 1, and because of that we came out of the for loop. That is why we are doing, it is not a prime number. Even we can do it without using the flag as well. Now, since you know that there are two ways you are going to exit from the for loop, one by this condition failing and other by this break, right? Whenever you come out of this way, whenever you come out of the for loop by this way, definitely I value would be n by 2 plus 1, isn't it? In that case, we fail to find out any factor. In that case, we can say that if I equal to n by 2 plus 1, then it is a prime. Otherwise, we can say it is not a prime, or you can use flag as well. Okay, so this is an example which will explain you how to use a break in a for loop. Okay, so this is not an optimal way of writing it. We could still optimize it. You can try it out, but since we didn't discuss about finding out the square root, we are going with this. Okay, anyway, it is a working code. Fine. Write a C program to find the factorial of a given number. So factorial of a given number is from 2 till that number you have to apply the product of all these numbers, and then that is called as the factorial, right? Now let's see how to write the program here. Void main int n comma I. Now we are going to find out the factorial, and we are going to store it in the variable called factorial, and the type of this factorial is the data type we are using is unsigned long. So long is either, it is an integer which is having a bigger size compared to the normal integer, right? Generally long is bigger than int, and when you write long, it is even bigger than int in some of the systems. In some of the systems it will simply be implemented as a long only, right? And when you're writing unsigned, it means that we want to have the complete range as the positive numbers. We don't want to go for the 2's complement representation, which means, let us say if 64 bits is used to represent this long type data type, then in case if you are going to use unsigned, then you can represent the numbers in the range of 0 to 2 power 64 minus 1, right? In case if you don't write it unsigned, then what happens is the range of numbers that can be represented will be from minus 2 power 63 to 2 power 63 minus 1, right? So this is the range, and the range is less compared to this, right? Therefore, since a factorial of a number is always going to be positive, it is better to use unsigned so that you will get a bigger range and you will be able to represent even the factorial of a very big number. Generally, factorial of a number tends to grow very fast as the number increases, right? That is why it is always better to declare it with the very big data type, as big data type as possible, right? Okay, now printf enter an integer. Now we are going to say, we are going to read the integer that is going to be entered, scanf %d ampersand n. If n is less than 0, which means if the given number is less than 0, then we are saying that factorial of the negative number doesn't exist. Okay, generally the factorial of a negative number is generally taken as 0, so we can say that it doesn't exist, right? Else, which means if it is a positive number, if it is not less than 0, right? Factor, it is not a negative number. If it is greater than or equal to 0, then we are going to start from 2, okay, and we are going to go till n, and we are going to product up, every time we are going to multiply that number with the factorial formed so far. So what I mean to say is, let us say we want to find out the factorial of 4, right? Then initially factorial value will be 1, right? Now as I becomes 2, 2 will be multiplied with this, and again as I becomes 3, 3 will be multiplied with this formed so far, which means it will become 6. As I becomes 4, 4 will be multiplied with this, which means 24, right? Now we are going to say that printf factorial of percentile d, factorial of this number is equal to percentile LLU. Why LLU is used? This format specifier is used because the data type of the factorial is unsigned, that is by U, long, that is by LLU. Got it? Okay. Now that is how we are going to find out the factorial of a number. Fine. Now let's see this question. Write a C program to print half pyramid using star. Now hash include studio.h, void main, int ij, comma number of rows. So let us say we are reading the number of rows from the user. Okay. For this program, let's say the number of rows is already taken as, assume that it is 4, but generally it is a better practice if we can read it from the user. You ask the user for the number of rows and then read it from the user, okay, printf and scanf. Now after that is done, now this is the logic which is used to print the picture like this, okay. Now for I equal to 0, I less than number of rows, I plus plus. For j equal to 0, j less than or equal to I, j plus plus, printf star, and after that printf new line. Now how is this one going to be executed is this way. For I equal to 0, I less than number of rows, I plus plus. Therefore how many times this outer for loop is going to execute is, in case if the number of rows is 4 here, now I will be initially 0, and then I will be 1, and then I will be 2, I will be 3, right? Now at this point it will become 4, and when it becomes 4, this condition will fail and it will not get executed. Therefore this entire code will be executed exactly when I equal to 0, I equal to 1, I equal to 2, I equal to 3, which means 4 times. This entire code is going to be executed 4 times, right? Okay, now every time we enter, this for loop is going to be we are going to come across this for loop. Now let us see how many times this for loop is going to execute. The body of this for loop is going to execute, which means the body of for loop means this part is going to execute depending on what the value of I is. Initially when I equal to 0, let's see, initially when I equal to 0, now j is initially 0, right? Now both of them will be compared, and it will check whether j is less than or equal to I or not. Yes, in this case j is less than or equal to I, therefore it will print star, so 1 star will be printed, right? And after this is over, it will go and increment j, so j value will become 1 now, right? And I value is still 0, right? And now it will be compared, so whether j is less than or equal to I or not. Now 1 is not less than or equal to 0, and so it will fail, so we are going to come out of this for loop. Once we come out of this for loop, the next line that has to be printed is this, printf new line. New line means we are going to take the cursor to the next line, so next whatever you print has to start from here. Got it? Okay, now after this we are going to end this for loop as well. Now once this for loop is over, we go and increment I, which means I will be I plus plus. Now the value of I is 1, right? Now again we get into this inside of this for loop with I equal to 1. Now again j is going to start initially with 0, right? Now 0 will be tested with 1, isn't it? Because I value is currently 1 and j value is 0, so 0 is less than or equal to 1, and so the condition is true, and so it will be printed. So printf star, yes, star is printed. Okay, and now after printing this, again j will be incremented, which means j will now be 1, right? And now I and j both are 1, and this condition is going to be satisfied because 1 is less than or equal to 1, and again this will be printed, so printf star. Now again j will be incremented, which means j will now be 2, right? Now 2 and 1 will be compared. 2 is not less than or equal to 1, this condition will fail, so coming out of this for loop, I am coming out of this for loop. After this for loop is over, printf new line is there, therefore I am going to the next new line, right? Now after this one is over, again I have to go and increment this value of I, because this for loop we are reached the end of this for loop, and so again we go and increment it. Now I is happening to be 3, I is happening to be 2. Now again j will start. Now j will become 0, so for that one star will be printed. Then j will become 1, again it is less than or equal to 2, one more star will be printed. Now j will become 2, again 2 is less than or equal to 2, one more star will be printed. Now j will become 3, but then 3 is not less than or equal to 2, therefore this for loop is going to end, and now we are going to come to printf, and new line will be, which means the cursor will go to the new line, printf new line, and after this I will reach 3. When I will reach 3, j will again start from 0, 0 is less than or equal to 3, so 1 star, and j will become 1, 1 is less than or equal to 3, so 1 star, j will become 2, 2 is less than or equal to 3, so 1 star, j will become 3, 3 is less than or equal to 3, therefore 1 star, and finally j will become 4. Now here this condition will fail, and so we will not enter this loop, we come out of this for loop, and now this line will be printed, which means we are going to come here, and after this again we are going to go I plus plus, right? So when we do this I plus plus, I will become finally 4. When I becomes 4, I is not less than number of rows, and so we are going to stop there. Okay, so this is what is going to be printed. So depending on the number of rows you want, you are going to get this structure. Here you have printed this structure for 4 rows. Now if you increase the number of rows to 10, you are going to see a better structure. Okay, now let's see this program. Write a C program to count the number of digits in an integer. Hash include studio.h, void main. So the logic which we are going to use is in the while loop, but let me read out the entire program here. Now n and count are the variables which are going to be used. So n is used to read the value from the user, in which we want to find out the number of digits present, and count is the variable which is used to count the number of digits which are present in n. Now enter the value, we are asking the user to enter the value, and we are reading it into n, scanf %d into n, while n is not equal to 0, n divided equal to this 10, which means it is a shorthand notation. It actually means that n equal to n by 10. This is the meaning of it. Okay, and then plus count. Plus count means count equal to count plus 1. So what is happening in this while loop is, let us say the number you have given is 123. Okay, now initially 123 will be compared with 0. In case if it is not equal to 0, we are going to enter this loop, right? Now n equal to n by 10 means this 123, this last one will be deleted, right? So why should this happen? If you observe it, n is declared as integer, right? And if I directly write 10 is also an integer. When I divide an integer by integer, the result is also supposed to be an integer, and therefore if I write n by 10, it is going to be 12 only, right? So I am going to get 12. Now count is incremented. So what will happen to count? Initially count is 0, now the count will become 1. Now again we enter the while loop, right? In the while loop again we test whether n is equal to 0 or not. Now since n is not equal to 0, again we enter it, and again we do n equal to n by 10, which means now n will become 1, right? Now count will be incremented, therefore count will become 2 now. Right, initially it was 0, then it became 1, now it is 2, right? As of now count value is 2. Now again we test whether n is not equal to 0. Yes, 1 is not equal to 0, therefore we are going to enter this, right? And again n equal to n by 10, which means now when I divide this by 10, it is going to be 0. N is finally going to become 0, and count equal to count plus plus, which means this one 3. Therefore count has become 3. So we are going to come out and we are going to say that number of digits is equal to %d, which is 3 here. Okay, now let's see this. Write a C program to check whether a given number is Armstrong number or not. So Armstrong number means, for example, if I take a number like this, let's say 371, right? Now what is the Armstrong number is, I'll take each digit and I'll raise it to the power of number of digits there in this number, right, without any leading zeros, right? Now I could write it as 3 cube plus 7 cube plus 1 cube. Now if these two are equal, then I can say that the number 371 is Armstrong number. So in this case, this number 371 is actually Armstrong number, because if you find it out, you are going to get the same. Now if you see the number, let us say 121. Now there are 3 digits, right? Now I want to check whether it is a Armstrong number or not. Now what should I check is, number of digits here are 3, therefore 1 cube plus 2 cube plus 1 cube. Now if you see this entire number is going to be 10, right? Now here it is 121, here it is 10, so both are not equal. So this number 121 is not a Armstrong number. Similarly, if you want to see one more number, let us say 1638, right? So 48. Okay, now if you try to find out whether this number is Armstrong number or not, you have to check 1 power 4 plus 6 power 4 plus 4 power 4 plus 8 power 4. Why power 4s? Because we are taking power 4s because the number of digits here are 4. Now if these two are equal, we can say that this is an Armstrong number, right? You just check it. I think they both are equal, right? Okay, just check it. I don't know, I'm not very sure, but then you have to check these two. If these two are equal, then we can say that it is an Armstrong number. Otherwise we can say that it is not an Armstrong number. Now what is the code we are going to use? The logic we are going to use is, first thing is, in the given number, find out the number of digits present in it. So we have already seen the code for it, right? And after finding out the number of digits, you take the digit one by one, right? And then you raise it to the power of number of digits, and then you add the result up. Okay, so if you see how to write it, just check this one. Now int number, original number, remainder, result, n, these are all the variables that we are going to use here. Now let us ask the user to enter an integer. Now whenever he has entered the integer, we are going to read it into number. So whatever number the user has entered, we are storing in this variable number. Okay, and now since we are going to modify that number in order to find out the number of digits in it, it is better you store that number. So in the variable called original number, I am storing this, right, the number which we read. Okay, and now we are trying to find out how many number of digits are there in that original number. So the same logic which we are going to use, right? So original number not equal to 0, while original number not equal to 0. At every step I am decreasing the number of digits in this original number by 1, and I am increasing the count of the number of digits, right? So by the end of this while loop, you are supposed to get the number of digits which are present in the given number, right? They will be stored in n. Now once you find out n, the next logic is, again, now if you observe it, this original number has been completely modified, so again copy it. Now the next logic is, take the digits one by one, raise it to the power of n, and then add it to the sum. Okay, so initially sum has been, or the result has been initialized to 0. Now see this, while original number not equal to 0, which means the number which is given is not equal to 0, remainder equal to original number modulo 10. Let us say the number given is 121. Now what I am taking is, I am taking this last digit. How do I get the last digit? If I divide any number by 10 and if I take the remainder, then I will be getting one digit from it, isn't it? So remainder means I am getting this first digit, and now result plus equal to power of remainder comma n, whatever number you got here, and already you have got the n equal to 3 for this number, isn't it, the number of digits. Now you take this number and raise it to the power of 3, right, power remainder comma n, take this number and raise it to the power of 3, right. Now whatever number you got, you add it to the result equal to result plus that number. Got it? So you keep on doing it until the number becomes 0, which means first time when I take the remainder, I got this. After that, what we are trying to do is, we are trying to divide that number by 10. Original number equal to original number by 10. When I do this, we are simply making the original number to be 12, which means after using up this digit, we are removing this digit from the number. Now the number will become 12. Again we do the same thing. Again we find out the remainder of this number when I divide with 10. Then the number happens to be 2. Now for that 2, I am going to find out what the I am going to raise it to the power of n, and again I am going to add that result to the so far formed sum. I'll keep on doing this until the entire number vanishes to 0. Got it? Now after it is done, I'll check whether the result is equal to the given number or not. In case if the result is equal to the given number, then I can print f, it is an Armstrong number. Otherwise I can say that it is not Armstrong number. Now if you observe this one, I'm using a ternary operator. In case if these two are equal, then the first statement will be printed, which means it will print that it is Armstrong number. In case if these two are not equal, then the second statement will be executed, which means it will say it is not an Armstrong number. Got it? Okay. Now let's see this question. Write a C program to print the following, which means here we are trying to print the entire pyramid. Okay. So how to print the entire pyramid is, if you observe it, let us say in this case I'm printing a pyramid whose size is 4 rows. Okay. Now if you see this, in the first row, before I print the first star, how many spaces should be there? Right? 3 spaces. And before I print the first star in the second row, how many spaces should be there? 2 spaces. Before I print the first star in the third row, how many spaces should be there? 1 space. Right? Now if the number of rows are 4, and let us say the total number of rows that we want to have is 4, and in that case the number of spaces I am supposed to get is 3 for the first row, right? Therefore the total number of rows minus the row number is going to give us the number of spaces that we have to print there. Okay, you can see this. So for the first one, the total number of rows here is 4 and minus the row number is 1, that is why 3 spaces are required. And for the second one, the total number of rows is 4, and since it is second row, if I do 4 minus 2, the number of spaces that have to be included is 4 minus 2. And for the third one, the total number of rows is 4, and if I subtract the row number, right, the row number is, so 1 space is required. And for the last one, the total number of rows is 4 and the row number is 4, therefore 0 spaces, so no spaces are required. So before you print the first star, you have to print the spaces, and the spaces have to be printed this way. Now the number of spaces at each row has to be number of rows minus the row number, right? So you remember the row number, and then you know anyway the number of rows required. Now at every time you have to compute it and you print those many. Now after that, how many stars have to be printed at each row? Now see this, in the first row the number of stars printed is 1. In the second row the number of stars printed is 3, which means 2 power or 2 into row number. Now what is the row number? 2 minus 1, isn't it? Now in the third row the number of stars printed is 5, so which is nothing but 2 into the row number minus 1. And in the fourth row the number of stars printed is 7, so which is nothing but 2 into 4 minus 1, right? So that is how you have to count. So one is the number of spaces that have to be printed, and the other one is number of stars that have to be printed. Now both of them are actually depending on one parameter, what is the row number you are looking at. Okay, so now let's see the program, how it is written. Void main int I comma j comma k, number of rows equal to 4. So here I am assuming that the number of rows is fixed, but then it is better if you can ask the user to enter the number of rows and read it. Okay, now for I equal to 1, I less than or equal to number of rows I plus plus. Now if you see this, in this entire code, the variable I will always give you what is the row at which you are currently standing in, right? Now depending on that row number, you will know how many spaces to be printed first. Okay, now let's enter and let's try to print the number of spaces required. Right, now how many spaces are required at each row, that depends on what is the the row number you are standing at, right? Initially for I equal to 1, the number of spaces required is 4 minus 1. That is why I am going to start j from I and I am going to go till number of rows. Now what will happen is, initially when you are looking at row number 1, let us say row is number 1, then j will start from 1 and then it will go as long as j is less than number of rows, which means 1, 2, 3. If you see this, only 3 times this particular for loop will enter this body. Are you getting this? Now the row number is 1 and I am starting j with 1 and I go till I reach number of rows which is 4, which means I start with 1 and I go till 3. Therefore, how many spaces we are going to print? 3 spaces. So 1, 2, 3. 3 spaces will be printed. Now after printing these 3 spaces, don't come out. You go and print the stars. Now how many stars you want to print? That depends on what is the row number, right? So the row number is, here is 1. Therefore 2 into 1 minus 1. That is why, see this. From 1 I start. K is going to start with 1. And I am going to go till I into 2. So row into 2. So what is it? Row into 2 is 2. But then I have to go till a number which is less than that. So I have to start with 1 and I should not reach 2. When I reach 2, I'll come out of the loop. Therefore, this for loop will be entered only one time, and so only 1 star will be printed. So that is how after 3 spaces 1 star will be printed for I equal to 1 for the first row. And after this loop is over, we are going to print next line, new line. So what does it mean? After printing these 3 spaces and 1 star, you are printing the new line. Therefore we go to the next line, and again we start everything by incrementing the row number. Now row number I plus plus will be done, and therefore the row number is 2. Now we are looking at row number 2. Now what happens at row number 2? Again the same thing. You have to find out how many spaces to be printed first. Now initially you start with j equal to I, right? Which means here you are going to start with j equal to 2, and then we are going till number of rows, which means j equal to 2 comma 3, but we are not going till 4. Whenever we reach 4, this loop will not be entered. Therefore this loop will be entered exactly 2 times, and so only 2 spaces will be printed there. Got it? And after 2 spaces are printed, we are going to come out, and now we have to decide about how many stars have to be printed. Now here the number of stars have to be printed is 2 into row number minus 1. That is why I am going to start with 1, and I will not reach till 2 into 2, I will reach till 2 into 2 minus 1. Now that is why k is starting with 1, and we are not going to reach till 2 into I, 2 into row number. So that is how I am guaranteeing that the number of stars that will be printed will be exactly 2 into I minus 1. Now if you want to see this, now the row number is 2. So the k value is going to start with 1, and what is 2 into I? 2 into I is 4, right? Therefore I'll go to 2, 3, and whenever it reaches 4, I'll not enter the loop. So how many times the for loop, this for loop code will be, the inside the for loop will be, we enter is exactly 3 times, right? Now we have entered exactly 3 times, and so only 3 stars will be printed. Got it? So likewise for the next time, one space and then 5 stars, and for the next time 0 spaces and 7 stars. Got it? So this is how the entire code is going to run. Okay. Now let's see this program. Write a C program to check whether a given number is palindrome or not. Now what is an example of palindrome is, if you have a number like this, let us say 121. Now if you read it left to right or right to left, it is always going to be same. That is why it is a palindrome. Now if you take a number, let's say 123, it is not a palindrome, because if you read it from left to right, it is 123, but if you read it from right to left, it is 321. That is why it is not a palindrome. Now what is the logic we are going to use is, we take the given number and then we try to reverse it and store it in a other variable, and later we check the given number and that finally formed reverse number and we compare them, right? So what I mean to say is, here we start with 121. Now I'll initially assume that I'll have some other variable, let us say some reverse r is the other variable. For now initially it will be 0. Now every time I'll take the least significant digit of the given number. Now how can I get the least significant digit of the given number? If we apply modulo 10 to this, right, then it is nothing but the remainder when you divide this number by 10. The remainder when you divide this number by 10 is going to be 1, isn't it? Now you take that and already so formed reverse number you are going to multiply with 10, and we are going to add this particular digit, right? Now what do you get here? Reverse number equal to 1 as of now. And after getting this 1 from the number, I'll just delete this number from this, delete this digit from this. Now how can I discard this digit? by dividing it with 10, right? When I do this integer division, if I say divide it with 10, then this number is going to be gone. Now what will remain? 12 will remain. Now again I'll take the least significant digit of this 12. Now how can I take the least significant digit? By taking percentile 10, which means take the remainder when you divide with 10. Now what do you get? 2. Now once you get 2, I'll take the so formed number and I'll multiply with 10 and I add it, that particular number, 2. Now what do I get? 12. Getting this? Now after this is done, I'll discard this. I'll just delete this last digit from the number. Why? Because I have already used it, right? Therefore, how can I delete it is simply divide this number by 10. Now you are going to get 1.2. Since it is integer division, this will be 1, isn't it? Both are integer constants, and so it will be integer. Now what is it? We got 1. Now again you find the remainder when you divide it with 10. Now you get 1. Now you multiply this one with 10 and add 1. Now what is it going to be? 121. Got it? So after this, again when you try to delete this by dividing with 10, then you are going to get 0. That is where you are going to stop, which means you have used up all the digits which are present and you have reversed them, right? Are you getting the logic? So if you want to see other number, let us say 123, how does the reversing work? Take this number and you put it here in the reverse initially, right? And again take this number, multiply this one with 10 and you add it here. Now what do you get? 32. Now again take this number, multiply this one with 10 and add that one. So what do you get? 321. So that is the logic we are going to use here. Okay, now since we are going to apply the same operation again and again, so what is the same operation? Finding out the remainder and then dividing with 10. Since we are going to do the same thing again and again, we can use a loop to do this, right? So that is why we are going to use a while loop here. Now see the code here. Int n, reverse number equal to initially 0, and then remainder. Every time we are going to get the remainder, that is why remainder is used, and original number is also one more variable which will hold the copy of the number entered. The reason why we have to hold again is because we are going to modify the number as we execute the code. That is why save the initial number. Now printf, enter a number, scanf %d %n, which means we are asking the user to enter a number and we are reading that number into n. Now original number equal to n, we are saving the copy of the number entered in the original number, which means the given number is going to be stored both in n as well as this, so that you can modify one of them, right? Okay, now while n is not equal to 0, which means we are modifying n, first find out the remainder. So what is that I am trying to do here is, if you have the number 123, it is stored in n as well as it is stored in reverse number also, right? So the variable it is stored in the original number also, right? On. Both of them are going to contain this. Okay, now initially remainder equal to n mod 10. I am going to find out this remainder by taking n mod 10. Now once I get the remainder, I am going to have the reverse number, right? So the reverse number is initially 0. I'll multiply that with 10 and I'll add this remainder. So remainder is 3. Therefore 3 is here, which means from n I have taken 3 and I have stored in the reverse number. Now I need not use it again, therefore get rid of it. How can you get rid of it? N equal to n by 10. This is the shorthand notation, isn't it? So what does it mean? N slash equal to 10 means n equal to n by 10. Now what will happen? N is an integer and 10 is an integer constant. When I apply division and when I am storing it into integer, automatically type conversion will happen, and even though 123 by 10 is supposed to be 12.3, since you are storing it in an integer, this one will be truncated and this number will be converted into integer, which means only 12 will be stored in n, right? Therefore n will contain 12 and 3 will be discarded. That is what is going to happen in this step, right? Now it will keep on happening until the entire number is reversed and stored in this, right? So how long we are going to see this? Every time we check whether n is not equal to 10 or not. Whenever n is not equal and when is not equal to 0 or not. Whenever n is equal to 0, we are going to stop, right? And finally after this is done, we are using this ternary operation. we are checking whether original number is equal to reverse number or not. In case if original number is equal to reverse number, we can print that, we can say that it is a palindrome. Otherwise, we can say that it is not a palindrome, right? It is a ternary operation, which we have already seen. Okay, fine. Now let's see this question. Write a C program to generate Fibonacci sequence given first number and second number of this sequence. Now generally what is a Fibonacci sequence is, you can think of it this way. The first one is 0 and the second one is 1, and the third one is, when you add these two, you are going to get the third one, so it is going to be 1, and the next number is when you add these two. So every time we add the previous two numbers to get the next number. When I add these two, 1 and 1, it is going to be 2, right? And next again when I add these two, 1 and 2, it is going to be 3, and when I add these two, 2 and 3, it is going to be 5, 8, right, 13, so on. So every time we have to add previous two numbers to get the next number, right? Now what is the program here is, user can give any two initial numbers. Let us say he has given 2, 3 as initial two numbers. Then we have to display the series starting with 2, 3. And let us say user has said that he want to see 3 numbers, then we are supposed to display these 3 numbers, right? So what is that we need from the user is, one is he is supposed to give us what is the first number he wants to start the sequence from, and then what is the second number. From there we'll take on, right? So once he gives us both of these, then we are going to start printing the next numbers in the sequence. And how many numbers are we going to print, that also we are going to ask the user how many he wants to print. Depending on that we are going to print. Now what is the logic we are going to use is, we can use first a variable first to store this one, and a variable second to store this one, and then a variable sum, okay, to get what the next number is. So how do I get the sum? So I'll add these two and I get this sum, then I'm going to get this one, right? Sum is going to be 5, then I'm going to print the next one. Now after this is done, now first should point to this, because for the next number the first number is going to be this, right? Therefore first should point to this. That is why I'm going to make first equal to second, then first is going to point to this and second has to point to sum, right? Now second is going to be here. Now again I'll do the same thing. What do I do? Again I add these two and I'll get the sum. Now sum will be 8 will be present here, and I print 8. Again first has to be moved here, second has to be moved here, and again sum has to be done. Now if you observe this, the same actions have to be done over and again until we reach our count, the number of values that I wanted to print. Until I print all the numbers, I have to do this over and again, right? For that reason, since you are going to do it again and again, it is better to write it in a loop. For that we are using while loop here. Now see this, the code: int first, second, sum, number and counter equal to 0. Okay, now enter the number of items, which means how many number of items you want to print. Okay, now that will be stored in the number. Now printf, enter the first number. Where do you want to start the sequence from? Then you are going to enter it into first. You are going to save it into the variable first. And next one is printf, enter the second number, and you are going to save it in the variable second. And next one is printf in the so now we are going to give the Fibonacci sequence, right? So printf new line, in the next line Fibonacci series is starting from here. So first and second will be printed. From there on I am supposed to print the next number, right? Now how to get the next number? Sum equal to first plus second. I am going to start with first plus second, that is the next number. Printf sum. Once sum is printed, now what should happen is, our previously second number will now become the first number, and our newly generated number will become the second number for the next computation, right? After that you are going to increment the count. Now how many times should this repeat? That depends on how many numbers you want to print, right? That depends on what is the count or what is the number that the user has given, right? Whatever number the user has given is already stored in num, isn't it? So let us say he has given a number as 4. Then what happens is, counter is going to start with 0 and counter is going to go to, after every plus 1, 2, 3, and whenever counter reaches 4 we are going to stop. Therefore we are going to enter the while loop as long as counter is 0, 1, 2, 3, 0, 1, 2, 3, which means 4 times. Therefore depending on what is the value present in this num, those many values will be printed, which means those many times this particular code will be executed. Got it? Okay. Now let's see the concept of functions now. So till now we have seen the uses of while loop, for loop and do while loop. Now if you see this, if you have a piece of code which has to be executed over and again, instead of writing it every time, we have been using loops, isn't it? There we had a flexibility that all these the entire code has to be at the same place. I mean the code has to be executed one after the other, and so we are keeping it in a loop. Sometimes what happens is there will be a code which will be frequently used, but then it will not be used in a sequence. It might be used anywhere randomly. Now in that case it is better that you write that piece of code in a separate entity called as function, so that without writing the same code again and again, you can simply call that code, you can simply call that function and get the thing done. For example, you look at printf. Now printf is the most frequently used part, isn't it? Therefore instead of writing the code of printf over and again, we have separately written the code inside the function printf, and in order to execute that code we are simply calling it, right? So that is the advantage of a function. Now a program can be written in such a way that it can contain any number of functions, right? And all these functions need not be present in the same file. They can be spread across multiple files, but only thing is you should not split the same function to be present in different files. So what I mean to say is, till now we have seen only the uses of main, right? Every function, if you are going to run it, it is supposed to have main. Now apart from this, now we are going to see something called as a function. Now for example, I'll just take this one simple example and I tell you. Now let us say we want to find out maximum of 2 numbers, right? So that is why I am writing this function int max. This is the name of the function, and whatever is present before the name, that is called as the return type. Now max return type is integer, so which means after the execution of this function it is going to return an integer. And now int x comma int y, so this is called as the argument list, okay? And to be even more in detail, it will be called as formal arguments, okay? Formal arguments. So x and y here are formal arguments, right? So which means this function is going to accept 2 arguments, and whatever you send to this function, that will be stored in the variable x and variable y, okay? Now the body of the function is like this: return an expression is there. In case if x is greater than y, it is a ternary operation. In case if x is greater than y, we are returning x, otherwise we are returning y, which means whichever is larger in these 2 numbers, we are simply returning it. Now if you see this, if this particular part, max is a frequently used code finding out maximum of 2 numbers, instead of writing it at all the places, we are simply writing it in a function, and whenever it is required we simply call it, right? That is called as function calling. Now some other function can call this function, okay? That is called as calling. Now whatever you have seen till this entire part is called as the function definition. Now what will function definition contain is a return type followed by the function name followed by the argument list. This argument list will be kept in these brackets, and then the curly brackets will be there, and inside the curly brackets you have the code, right? So this is called as function definition. Now if you want to execute a function, you are supposed to provide the definition as well, right? Now after this we are going to have one more function. So both of them can be written in the same file. In a single file you can have any number of functions. So there is a function, and after that I am going to write main. Now what does main contain? Now see this. Main is again a function, that is why it is its definition. So this is the definition of the main, right? Now what should the definition contain? Before main we are going to have void, which means it is not going to return anything, and the argument list is given as void, okay? So which means it is not going to take any argument. Now even if you miss it, it is going to take it as void, okay? And now int a equal to 100 and int b equal to 200. Int maximum equal to max of a comma b, which means here we are going to call the function, and to this function we are sending the parameters. What are the parameters we are sending? A and b. So here a and b are called as actual parameters. Got it? So while calling the function, whatever parameters you use in the function call, they are called as actual parameters, and whatever a function receives, they are called as formal parameters. Therefore here the actual parameters are a comma b and the formal parameters are x comma y. One important thing you should remember is, always when you are going to call a function, you should remember that the number of parameters that you send and the type of these parameters should match with this, right? So the number of parameters should match and the type should match. In case if the type is not matching, then there will be type coercion, which means some kind of type casting will be done, right? So whatever the type of this one is, that will be converted into this type and they will be sent into it. Got it? Okay. And now whenever you are returning, you can cache that return value into a variable. Now this is returning an integer and that is being caught in this maximum. Got it? Okay. Now this is called as the definition of main, right? And this particular statement is called as function calling, right? Now in C, it is very important that before you call any function, you should tell the compiler about it, which means you should say that there is a function with this name and it is going to return this type and these are the parameters. That is what you should specify, which means before this uses above it, you are supposed to mention somewhere that there is a function max, and here since you have given the definition itself, compiler will understand that, oh, there is a function called max. In case if you have written this definition below, then you are supposed to have a declaration there. Got it? So what is the declaration or prototype of a function is, it will not say everything about the function, it will just say the name of the function as this, and it will say that it is going to return int, and it will say that it is going to take two parameters, both are of type int. So if you write like this, this is called as declaration or prototype. Now in case if you had not had this definition here, if you have had this definition either below this or in other file, then in this file if you have to compile it, then you have to include this line. Got it? Otherwise compiler will get confused saying that there is, I don't know what about anything called max, and so it will give you an error. Now once you say this, compiler will be sure that, oh, this is a function and he is calling it as a function and it is taking two arguments, that is why he is sending two arguments. Got it? So you should always have a prototype or the declaration in case if the function is not defined above it, right? So the best example is printf. In printf, we don't have the function definition in your file, isn't it? You are just directly calling printf here, but then where is there is no definition as well as no declaration there. That is why we are including studio.h. Now as you include that file studio.h into your file, the preprocessor is going to include the entire contents. Now what happens is the required prototype will be present in that file, and so it will not give you any error. Got it? So before calling any function, you are supposed to have this some either definition or declaration. Now the next thing is, if you observe this, we are going to return some value here. Either you can directly return a value or you can return an expression. Finally this expression will be evaluated and converted into the type that you want to return. For example, if this entire expression is evaluated, let us say the value you got is a float, but then the value you are returning here is int. Therefore this one will be converted into int and it will be sent. Got it? So finally you can store it in a variable of type integer. And also it is not a requirement that you should always catch whatever it is returning. If you don't want to catch the value into max, you can leave it. You can simply call it and you can leave it, right? But anyway, doing that will not be meaningful in this case, right? So now there are some functions in which they need not return anything. In that case, what we can have is simply void if you don't want to return anything. A function can return anything except an array or if another function. Now in case if you want to return an array, It is not possible because every function is restricted to return only one, and an array is a collection of values. Therefore you are not supposed to return an array. So in case if you want to return an array, you can use a pointer to the array and you can send it. Okay, we shall see later with examples how to deal with that situation. Okay, and now one more interesting thing here is when you are sending this value here, A's value is initially 100 and B's value is initially 200. Let us say you are sending the values. Now what will be sent is only the values will be sent, which means 100 and 200 will be stored into X and Y, and this execution will start. Right now, in case if you modify this X and Y here, the values of A and B will not be changed, right? So this is because of the concept called as call by value. Generally all the programming languages, when they try to pass the arguments when the function calling, they will follow either call by value or call by reference, right? They will either follow call by value or call by reference. But then in our C programming language, we always use call by value, which means C programming language is providing only call by value. So what it means is, when we send the arguments, when we pass the arguments to a function, what we pass is the values of the function, the values of the arguments, and not the actual arguments. Therefore, even if you modify the formal parameters, the actual parameter values, they will not change. If you want to see an example, you can see it here. Just see the example here. Now let us say there is a function called fun, and this entire thing is simply the definition of the function. Right now, what is it doing? It is simply reading something into X. I mean, if you call the function, some value it will get into X, and whatever the value is irrespective of it, it is making it 30. Right now, see this one. So this is the definition of main. Both of them are in the same file when we are going to execute it. Okay, so void main, void, which means main is not returning anything and is not taking anything. Int X equal to 20. So it is having a variable called int and it is 20. Now fun, let us say I am passing X. Okay, now what will be passed? So this X here will be local to this main. Okay, later we shall see what are the types of variables. Now how many variables are there in this function? X is a variable, and again in this function also, if you see this, X is a variable. So we have two functions of this, two variables which are having the same name in two different functions, and it is definitely allowed, right? And now this copy will have its own name, so let's not confuse you. Let's just have some other name. Later I'll show you what are the different types of variables, what are local variables, what are external variables, then we can see it again. Now let us say int X equal to 20, and we are passing the value of X into the variable Y. Then what happens is, when I call this function, then the copy of the variable Y which is present in this function is going to get a value 20. Okay, now what is this function going to do? It is just making Y equal to 30. Therefore Y will be made 30 here. Right now that is done, and again we come back, and when I print X, here the copy of X is 20, and what will be printed is only the value of 20. So what does it mean? Even when you modify the formal parameters, the value present in the actual parameter doesn't change, which means both the formal parameters and actual parameters are different, and what we are actually passing here is just the value, and we are not passing the variable there, which means whatever they are using is a different variable, and whatever here we are using is a different variable. That is called as call by value. So because of the call by value, whatever modifications you do to the formal parameters will not actually affect the actual parameters. Got it? So we shall see now what are the types of variables later in some time. We shall see what are the types of variables, and then what are the scoping rules, and can I have the same name here and here. All those things we shall see later. Okay, fine. Now let's see in detail what happens with the function calling. Now let us see this program. Write a program to swap two numbers. Now the program is written this way: hash include studio.h, because we are using printf here, and void swap int star int star. Now if you observe it, void swap, this entire line, this one line is actually the prototype or the declaration, right? So why am I doing this is, now if you observe this, in the function main we are calling the function swap, but then its definition is already not given and its definition is present below. So compiler, if it reads till here, it will get confused that swap is not present. Just to say that this is the structure of this swap, it is going to take two integers pointers and it is not going to return anything. We have to specify the declaration here. Okay, and now anyway the definition of this swap is also given in the same file, but it is after the function calling is over. Okay, now void main int x comma y printf enter the value of x and y. So we are asking the user to enter the values, two values, and they are read into x and y. Now I want to swap these two values, that is why addresses of x and y are actually passed to the function which is called for swapping. Now after swapping we are printing the values of x and y. Now how is this swap written is, swap is taking two variables, both of which are integer pointers, and we are taking the value from a which is present. Okay, I'll just show you with examples how it is going to be executed. Now before that you should understand one thing. Whenever a function call is done, whenever a function call is made, for every function there will be something called as activation record created in the stack. Okay, so for this you might have to understand a bit of operating systems and a bit of compilers, but I'll just simplify the things and I'll show you what actually happens. Okay, now whenever you try to run a program, then a process will be created and the process will have all these components. Now the text section will contain the code that you are actually trying to run. Okay, now in the process there will be some part which will be given to the code, and then in the same code, after this there will be static variables and global variables. Now what are the static variables and global variables, and will our C have it or not, we shall see later. Okay, for now, and these two parts both are combinedly sometimes called as text section. Okay, now after this the remaining space is going to be used in two ways. One is for the function calls and the other is for the dynamic memory allocation, right? Now one part is called as the heap and the other part is called as the stack. Generally stack grows like this, okay, and heap grows like this, so that we are going to use this entire space efficiently, right? So since both of them are actually growing in the opposite direction, as long as there is some space remaining, anyone can use it, because we don't know, in some programs it might need more of heap is used for dynamic memory allocation. Okay, so some programs will need more of heap and some programs will need more of stack, and so we are not having any hard bound. Anyway, any part which needs space will occupy accordingly. Got it? So now what happens is, initially whenever we start the process, for every function we call, there will be an activation record created, right, in this stack section. Okay, and all the local variables will be created in the activation record. For example, for this function, whenever you start, we are starting with main function, isn't it? So for the main, activation record is going to be created. Okay, this part. Now whatever variables are declared inside main, they are called as local variables. Anyway, we shall see about the classification of variables later, but for now we have just these local variables x and y. Now for both x and y, some space will be allocated and that space will have address, right? Let us say the address of x is 100 and the address of y is 200, right? And whenever this main is going to call swap, whenever a function calling is done, then an activation record will be created for it. So this is the activation record, let's say, for main function, and this is the activation record, let's say, for the swap function. Okay, now if you observe it, swap is also having two variables, one is a and other one is b. So a is here, let's say this is a and this is b. Okay, now what are the types of these variables? Both are pointers, right? Now depending on the type of compiler you are using, appropriate sizes will be given. right? What is the size required for a pointer, that much size will be allocated there. Now if you observe it, initially what is happening, main is executing and main is asking us to enter the values of x and y. Let us say we have entered the values of x and y as some 8 and 9, something like this. Now x is 8 and y is 9. Fine. Now after this we are passing the addresses of x and y into the function swap, which means while calling the function swap we are using as the actual parameters addresses of x and y, which means what will be sent to this swap function is address of x and y, 100 and 200. Now where will they be caught? Address of x will be caught into A and address of y will be caught into B. Now are these variables capable of getting the address? Yes. Why? Because they are integer pointers and these are the addresses of the integers, therefore they will definitely accept it. So the address of x, which is 100, will be stored in A and the address of y, which is 200, will be stored in B. Got it? So A will now contain address of 100 and address of x, and B will now contain address of y. Now see the way the code is working. Now what is that we are doing is, in temp, which means one more local variable temp will be created where inside this swap itself. Therefore all the variables which are present in the argument list are local to this function, and for every variable which is local to this function they will be created inside the activation record. Therefore after the execution of this function, the activation record will be popped, which means that entire record will collapse, and so you will lose all the local variables which are present here. Okay, so anyway we shall see it when we look at the types of variables. For now just understand this code, only this code. Now in temp equal to *b. *b means value that is present at the variable whose address is given in B, isn't it? *b means now whatever value is present at the address pointed by B. Now B is saying that the address is 200, which means here now whatever value is present in this, which is 9, that has to be kept in temp. Therefore in the temp 9 will be kept, right? And now *b equal to *a. Whatever value is present in A, I mean the address pointed by A, has to be stored in the variable pointed by B, which means whatever value is pointed by A, so this value has to be stored in whatever value is now being pointed by B, so 8 has to be stored here. That is what is done. And what about the next statement, *a equal to B, *a equal to temp, which means take the value present in temp and store it in the variable whose address is given in A. Now variable whose address is given in A is 100, which means here we are going to put 9. So 8, 9 is now swapped as 9 and 8. Got it? So now once this is over, after you return, which means once this is over, this entire record will be popped off, which means after this function execution is over, there will be no variables A, B and temp. They will be completely gone and you will not be able to access it. Got it? So that is called as scope and lifetime. We shall see it later. Now let's see what is happening here. Now after this swap, now we are going to printf. After swapping the values of x and y, or this will be printed 9 and 8. Now this is how we can give the access to the actual parameters in the function called. Now till now I told you that the actual parameters will not get affected by the changes in the formal parameters, but then if you can send the address of the actual parameters into the function called, then it will have the ability to change the contents of the actual parameters, and this is the only way it can do it, otherwise it can't do it, right? Now there is a confusion here. Many people think that since we are passing the address, they will call it as call by reference, but it is wrong. See, it is always call by value only. Actually if you observe what is being passed, it is the value, which in this case is the address, right? Again a value is passed, which means even though you are changing the contents of the variables here, we are not actually passing the variables themselves, we are just passing the value. So again here the value happened to be the address, therefore it is still call by value only. Okay, fine. Now let's see this one. Write a custom C program to implement POW function. Now this POW function, this is actually present in math library, and it takes two arguments, right? So first argument will be base and second argument will be some number. What we want to find out is base to the power of n, right? So this is what we want to find out. Okay, now for this already it is implemented in C library, and you can directly use it by including math.h and then directly calling this function pow. Now let's see how to implement it ourselves. Okay, so let's see this one, int base comma n. So this function is going to take two parameters, one is base and one is n. So whatever, when the function is called, whatever parameters are passed, one first parameter is saved in base and the second parameter is saved in n. Now int p, for p equal to 1, n is greater than 0, minus n, p equal to p into base. So initially we assume that p equal to 1, right? And let us say, I'll just take an example and explain you. Let us say this is, I want to find out 2 power 3, so which is 8. Now what will be in the n? 3, and what will be in the base? Let's say 2. Now initially p equal to 1. Now I'll check whether p is initialized to 1 here. Now I'll check whether n is greater than 0 or not. Yes, it is greater than 0, right? Then I'm going to enter it. After entering it, what I do is p equal to p into base. Now what is base here? Base equal to 2. So p equal to p into base means this number is going to be 2, right? And now this one is going to be minus n. So initially n is 3, and now it is decreased by 1, which means n will become 2, right? Now we are going to again get into it and do the same code. P equal to p into base. Earlier p is 2, if I multiply with base 2, it is going to be 4, right? And after this is done, minus n, which means this will be decremented. Now I'll check whether n is greater than 0 or not. As n is greater than 0, again I'll do p equal to p into base. Now I'll multiply this one with 2, p equal to p into base. Now this one is going to become 8, right? Now again I'll decrement it by 1. Now it will become 0. Minus n means it will become 0. Now I'll check whether n is greater than 0 or not. No, n is not greater than 0, right? Therefore we'll stop here. Therefore we are able to find out 2 power 3. Now if you observe this code, actually this could be optimized further. I mean, we are not going to get into details, but then I just want to tell you that this is one way of writing the program, and the other way of writing the program is, by decreasing the number of times you hit this statement. Okay, so actually in algorithms, and while talking about algorithms, we talk about how to optimize a code, but here in C we just talk about how to implement something, right? So here it is not the best code, but then it is a running code. And one more thing, if you observe, if I keep on multiplying the number might get very big. Therefore if you could declare it as long, then it will be even better. Okay, so if the number is very big, declare it with long. Fine. So in C programming language, you can visualize, or you can think of the entire memory as a one-dimensional array. Even though you are going to have various data structures, and you could look at the data structures in a different view, but actually in C programming language it is accessed as if it is a one-dimensional array. So I'll just explain you how it works. See, you can think of this entire memory as one-dimensional array like this, right? And then if there is any object in C, like an integer or character, whatever, any variable that will be assigned. See, let us say they are all bytes. Okay, and your system could be either byte addressable or word addressable, right? And now if you declare any variable, that variable will generally be stored in the memory at some location, and in order to make it easy for you to access it, generally we have a name for the variable. For example, if you declare char a, right, then a will be given some storage, which means the name a is nothing but whenever you use this name a, you are actually inside this cell. If this cell is dedicated for the character a, then whenever you call this name a, you are actually standing inside this cell. That is the meaning of it. Okay, and now how many cells does a variable take or consume? That depends on the implementation. Sometimes that all depends on the implementation. See, many people think that character size is 1 byte and integer size is 2 bytes, long size is 4 bytes, but it is not fixed like that. And even if you can see that some of the questions are asked in which they might ask you what is the size of a character, they should not really ask you that, because the character size or integer size or long, whatever it is, that all depends on the implementation. Some implementations might use by implementation I mean the platform also. We have 64-bit operating system, 32-bit operating system. Therefore, depending on the platform on which your program is running, each variable is going to take some size, right? But the size is once decided, it is going to be fixed like that. But then you cannot fix it like character should always be 1 in all the platforms. It doesn't. It is not true. It varies from implementation to implementation, of system to system, or platform to platform. Anyway, most of the implementations have character size as 1, but then they should not really ask you such question, what is the size of a character, okay? And then if you have integer, let us assume that in this platform integer is going to take up 2 bytes and each cell is representing 2 bytes. Then whenever you talk about b, then b is actually now having these 2 bytes occupied. Got it? So this is b, this is a, like that. So whenever you want to access it, you can access it using the name. That is a quite popular method. The popular method to access any variable is by using their name. So whenever you are talking about the name of a variable, you are actually inside the cell and you are talking about that, right? And the other way to access it is by using their addresses. So any variable or any entity that has been given some memory inside that has been given some space inside the memory will definitely have a address. Now, in order to access that particular entity, you need not use the name always. Sometimes if you use the address, you can completely avoid the name, one thing. And second thing is, even if you have name, if you use the addresses, it will be faster to access. See, as you know, even though you are trying to access a variable by name, ultimately it has to be converted to logical address, and then logical address has to be converted to physical address. Therefore, anyway you need the address to access a element. So if you are already accessing the element by address, it will be faster. So sometimes it is convenient to use the addresses rather than the names. One thing is for sure, if you use the names, it will be easier for us to read it. If you use the addresses, it will be faster for the machine to implement it. That is where pointers come into picture. Pointers generally handle the addresses, and whenever you write any program or any entity with pointers, it is supposed to run faster compared to the programs which does not have pointers. That is one advantage. And the other advantage is generally the dynamically created data structures, you cannot name them when you create them. Therefore, at that point, only access or only handle to access them is address, right? So anyway, pointers are going to play a key role, especially in C programming language. Okay. Now let's talk about a pointer. You know this, these are all trivial. So character, integer, long, everything is trivial. Now let's talk about a pointer. What is a pointer is? Pointer is a variable which is supposed to contain the address of some other variable or some other entity. And let's see this. Let us assume that in this system the address is 16 bits. Physical address or logical address? Generally logical address. Okay, if the logical address space is 16 bits, right, then we use a pointer whose size is 16 bits. Okay, let me keep it simple. Let's not talk about logical addresses, physical addresses. That is really not required for Gate. I don't want to confuse you with that concepts combined with the pointers. Let's make things simple. Okay, so every system is going to have some length or some bits used to address the memory, and therefore your pointer should be able to hold those many number of bits. So the size of a pointer again depends on the platform. In some platforms they have 16-bit addresses. In that case, pointer is going to be 16-bit variable. In some platforms there is 32-bit addresses, therefore pointer size is going to be 32 bits. So either, okay, let's see this. How to declare a pointer is like this: int star, let us say p. This is how we declare a pointer. Now when I write like this, it means that star p, when I write like this, p is a pointer because it is written as star. And one other way of reading it is star p is a variable of type integer. Okay, I'll tell you what it is. Let us say now once you declare this, then what you could write is p equal to ampersand b. Okay, now this ampersand b will get the address of b and it will assign it to p. So if you watch it, if I write p equal to ampersand of b, there are two operators. One is equal to, another is ampersand, and we have already seen that ampersand is having highest precedence, right? Unary operator compared to the assignment. So this ampersand operator, it is also called as address operator. It is used to get the address of b, and you can get the addresses of only the variables and the other structures which are declared in the memory. For example, you cannot get the address of expression. Expression cannot be declared in the memory, or you cannot get the address of a constant. Only the things which you can get the address of are variables which are actually allocated some memory space, right? So by writing like this, what happens is you are going to get the address of b and you are going to put that address in p. For example, let us say in this platform, the address is 8 bits. Then pointer is going to take up only 1 byte, right? And now b is already somewhere. B is occupying 2 bytes, right? So even though b is occupying 2 bytes, you need not allocate 2 bytes to pointer, because pointer has to just hold the address. Let us assume that this entire addresses, all the addresses are just long enough to fit in 1 byte. Then what happens is, let us say the address of this one is 100, this element, and this one is 101. Then what is the starting address? 100. So by writing this line inside p, 100 will be saved. What is the meaning of this? That p is going to point to a element, right, which is of type integer, and the address is 100. Okay, it means like this. This is the meaning of a pointer, and either it is a integer or character or any other structure, pointer size is always going to be same. Why? Pointer is going to contain the address, and whatever the element it is, the size is going to vary, but its address is going to be constant, isn't it? So pointer size is going to be exactly the same number. Okay, so I'll tell you, if you want this any correlation, you can think of it like this. We have houses, and each house is of different size, isn't it? But all the houses will have same size address, right? Either it is a small house or a big house, address is always going to be same, isn't it? Therefore a pointer should be able to hold the address, so it is going to be the same for all the data structures. So remember this carefully. Any data structure it is, whatever it is, always the address is going to be same. You need not change the size of the pointer depending on the type of the pointer. Then why should we write this? If I say that everything is going to have the same size, then why should I write this? I could have even written this, right? Char star p, and p can point to integer, isn't it? Yes, that is true, you can do that, but the problem is there. The problem is address arithmetic. I'll talk about it later. Why should we say what type of element that a pointer is pointing to, instead of see, depending on whatever the type of the element it is, you are always going to have the same size of the pointer. Then why should you differentiate it? Why should I write int star p, char star p, or anything like that? The reason is, if you don't declare the type of it, later there is a problem called as arithmetic. Address arithmetic. I'll talk there why it is required. I'll say about it there. Okay. Now one thing is, p is pointing to this, right? So now if I use the name p is as good as using the address 100, right? Now when you have the address 100, it is as good as you are standing here. Understand this? Whenever you have address at hand, it is as good as standing there at the doorsteps. And if you have to get inside the element and access the element, then we have to use one more operator, which is called as star, right? So this star is also called as dereferencing or indirection operation. See, ampersand is used to get the address, okay, and star is also called as dereferencing or indirection operator. And whenever I apply this star to a pointer, what happens is, if you have the name of a pointer, you are actually standing outside that memory cell, and when I apply a star, you are actually getting inside it, right? So whenever you call it with a name, you are actually inside it. So if I use a name of a variable, I'm standing inside. If I use the address of a variable, I'm standing outside. And if I use star to the pointer, I'm standing inside. So if you have to access a variable inside the variable with a pointer, then you should always use the star. Remember this? So what it really means is, now whenever you do this, wherever you have used b, that can now be substituted with star p in every expression. So b and star p both are same, which means using a name to access a variable or star p to access a variable when p is pointing to b, both are same. Got it? Let's see this program, which will give you a clear idea about how the pointers work. It is better if you could write it and implement it. Okay. So watch it. First of all, x is a variable. Assume that the address of x is 100. X is a variable which is stored at the memory location 100, and don't worry about what is the size of it. Either it could be 1 byte or 2 bytes or 4 bytes. It is stored at some location 100, and inside x, the name of this location is x, and inside it is 5. So if I have this address, I'll be standing outside. If I put a star, I'll be standing inside. That is what I told you, right? And now y is one more variable, right, which is actually a pointer. Y is a pointer to integer, and y is going to take the address of x, right? So y is going to hold address of x, which means 100. So this is y, right? And it might be stored at some other location 1000. So if you want to see how it really looks like, I told you that you can visualize in C the entire memory as a one-dimensional array, right? So I'm saying that x is located at some point. This is x, and its address is 100, and it is holding a value of 5, right? And I'm saying that y is located at some other address at 1000, right? And it is holding some address 100, which is nothing but the address of this. So that is how y is pointing to x, right? This is the actual memory organization. Okay. And now I'm trying to do this printf %d x, which means I want to print this line wants to print the value of x. So what will be printed because of this line? Whatever is present in x, which is 5. And the next line is printf %u %x, which means it is going to print the address of x. So what is the address of x here? Address of x is 100. So it is 100. So did you observe this type specifier? Here %d is used for specifying the integer, and %u is used to say that it is an unsigned integer. Unsigned integer means it is always a positive number. Why? Because addresses are generally positive numbers, isn't it? So have you ever seen a house number with -100 or something like that? And similarly, printf %uy. So even y is a pointer which contains the value of a address. Therefore, %y pointer is going to contain. Now printf %uy, again y is a pointer which actually holds the address, and therefore it has to be a positive, unsigned integer. So y is going to hold 100. So even this one is also going to print the same thing, isn't it? Y was actually assigned with the value %x. If you see this, y is actually assigned the value %x. Therefore %x or y both are same, right? And then the next one is %d star y. Star y is, I told you, so when you are talking about y has 100. Having a number 100 is as good as standing outside the cell, right? And whenever you put a star, it is getting inside the cell, right? So whenever I put star y, it is actually inside the element, and which is 5 here in this case, right? And then printf %u %y. So %y means I want to print the address of the pointer, right? So address of the pointer is how much? 1000. Got it? Which is an unsigned number, right? So either ampersand, which means the referencing operator, or star, dereferencing operator, acts in the opposite way in the sense Ampersand is going to give me the address and star is going to give me the value, which means ampersand is going to give me the outer value and star is going to give me the inner value. I mean, if you can visualize that outer and inner kind of visualization, I mean, see, whatever I am doing here is just to make things simple. It is not that you are standing outside and it is not that you are standing inside, but if you have this kind of visualization, it will be easy for us, even to understand some difficult topics like structures and pointers. Okay. In C programming language, whenever you pass some parameters to a function, it is actually call by value. Call by value means what is actually passed is the value of the function. Okay. So let's see this example. I'll just explain you what it really means. Let us say we have a main function, and in the main function I have two variables a and b. So what does it mean? Inside the stack, right, local variables will be created, and local variables a and b are local variables to the function main. Okay. What I mean to say is a is created here and b is created here in the memory somewhere in the stack. Okay, let us say a equal to 3 and b equal to 4. That is what is done, which means a equal to 3 and b equal to 4. Now I want to swap the values of a and b. Then I am going to write this function called swap a comma b. So it means that I want to put 4 here and then 3 here. That is what I want to do, right? Then how can I swap it is, instead of swapping directly a code here, I wanted to write a function. Then to that function I am going to pass a and b. So these are called as actual parameters. Whenever you call any function with some parameters, they are called as actual parameters, and therefore the function which is called will be invocated now. Now in this function invocation, what happens is these parameters, they are called as formal parameters, and C follows call by value. So there are various types of calling. Here it is called as call by value. I'll discuss about it later. Okay. Now call by value means, now whatever is the value of a and whatever is the value of b, that one will be passed into x and y. So whenever you do like this, one more copy, or in fact two copies, x and y will be copied, created here, and whenever I say swap a comma b, whatever was the value of a and whatever was the value of b, that will be copied into x and y. So what is the value of a? 3. What is the value of b? 4. So into x and y, 3 and 4 will be copied, right? And now temp equal to x and x equal to y and y equal to temp. This is nothing but the code which is used to swap these two values. So actually what happens is, we have one more value called temp. I'm just showing you. I think you must be knowing this anyway. One more variable called temp will be created, and temp equal to x, which means this value will move here, 3, and then x equal to y, which means this value will move here, which means 4 will move here, right? And y equal to temp, so which means this value will move here, which means 3. So what got exchanged? X and y got exchanged, right? And after this function, nothing has happened to a and b. We wanted to swap a and b, but then when we try with this code, because of this call by value nature of the C programming language, what happened is x and y got swapped. The local variables which are created in the function, they are also called as formal parameters. Formal parameters got swapped, not the actual parameters. Then how can we handle it? So this is where functions will be useful, these pointers will be useful. So whenever we want to give the access to the actual parameter in the called function, so actual parameters are in the calling function, and in the called function, see, this is called as calling function. Why? It is calling some other function and it is called as called function. Now whenever you want to make some modifications in the actual parameters, you are supposed to send the, or you are supposed to pass the addresses of the actual parameters to the calling function. Therefore once it gets the access to these variables, it can swap it, right? So instead of doing this, maybe we can see what happens with the pointers. So if we send the pointers, what happens is, watch it now. See, now instead of sending a and b, I'll send the addresses. You know what is ampersand, right? So ampersand means we are sending the addresses, right? Address of a and address of b. Now even though I am writing ampersand a and ampersand b, what will be passed is whatever is the value of ampersand a and whatever is the value of ampersand b. Let us say here ampersand a address is 100, I mean a address is 100 and b address is 200, then what will be passed there? 100 and 200. Now when you are sending the addresses or when you are passing the addresses, what should the formal parameters be doing? They should be able to receive the addresses. Now what are the variables that receives the addresses or stores the addresses? They are pointers. So you have to define them as pointers. Yes, now x and y are pointers. Okay, now I can change the entire code like this, right? Now what is the meaning of it is, watch it. Now x and y are pointers, right? So see this, x is a pointer and y is a pointer. And what did you send into x? We have sent 100 into x. And what did you send into y? We have sent 200 into y, right? Therefore whenever I use the name x, it is nothing but equal to 100. Therefore whenever you use the name 100, the address 100, you are actually standing outside, standing here, right? And whenever I want to access a, I have to put a star. So whenever I put a star to x, you are actually jumping into it and you are able to access a, right? And similarly y also, whenever I call it with name, I'll be here standing outside because it is address, and whenever I put a star before y, I'll be standing inside. So star x and star y are now actually a and b, isn't it? So using star x and star y is as good as actually using a and b. Or if you understood this, you can do it. If you didn't understand it, we shall go in the procedure. Okay, so now what happened is a new variable temp is created, right? And see this, temp equal to star a, star x. X is 100, star x is this value, right? Which means this value will move into temp, which is 3, right? And then star x equal to y, star x equal to star y. Star x means the value inside this, this one is equal to star y, which means 4 will move here. So 4 is moving here, right? And then star y equal to temp. So star y means the value inside it. See, star y means inside, not the outside. Y means this one. Star y means inside this, right? So star y equal to temp, which means inside this one I am going to write whatever is there in this, right? Which means 3. Now you got it. So by sending the pointers as parameters, I am able to swap the variables. But then without sending the pointers, you will not be able to achieve this, right? Okay. Arrays and pointers are very strongly related in the sense, whatever you could do with array and a suffix, you could even do it with pointers. And in some sense, array name itself will also act like a pointer. Okay, I'll tell you what I mean to say here. Assume that we have an integer int a of 5, which means there are 5 elements in integer a. Now whenever this integer a is allocated some memory, it will be allocated a block of contiguous memory space. Let's say that memory space is starting from 100. So let's make some basic assumptions here, and after according to these assumptions we shall move ahead. Okay, so first thing is, I'll assume that in this system where I am working on, every integer is going to take 2 bytes and the system is byte addressable. So whenever I say like this, so the system is byte addressable. So byte addressable means every byte is going to get a different address. In case, see, generally systems are word addressable, right? Word addressable means that word is going to get a unique address. In case if I say that a word is 2 bytes and then it is word addressable, then what it really means is for every 2 bytes one address will be allocated. But here I am saying that byte addressable, which means for every 1 byte one address will be allocated, right? And now I am assuming that an integer is going to take 2 bytes of memory. So every integer is going to take 2 bytes of memory, and then I'm assuming that there are 5 elements, right? And so I'm going to write it like this: 1, 2. How many cells are required? So if you have say every cell represents 1 byte and every integer is represented by 2 bytes, then how many bytes are required to represent array? 10 bytes. So I'm just writing 10 bytes. Okay, So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes. Okay, fine. So assume that this space for which A is allocated, or the starting address is here and it is 100, which means A is allocated from here, and this is byte number 100, and this is byte number 101, byte number 102, 103, 104, 105, 106, 107, 108, 109 and 110, right? And every 2 bytes is going to be occupied by one integer, right? Every 2 bytes is going to be occupied by one integer. So this one is A of 0. You know this array suffixes are going to start with zeros, right? Array indexing. So A of 2, A of 3 and A of 4. So I have 5 elements and all the elements are like this. So what is the address of A of 0? Address of A of 0 is 100. And what is the address of A of 1? Address of A of 1 is 102. So one thing you should observe is, even though A of 0 is occupying 2 addresses, whenever you talk about the address of A of 0, you should always say the starting address, which means 100. And A of 1 is 102 and A of 2 is 104, like that. Okay. So now every element is having some particular address. So what is the address of A of 0? 100. Address of A of 1? 102. Address of A of 2? 104. A of 3? 106. A of 4? 108. Right? So this is how addresses are allowed and given. Then the array name A itself is actually a mnemonic. So array name is not a variable. See, till now we have seen this. Int A means A is a variable which will be given some space in the memory, and we could use that space to store some values, isn't it? But then here, whenever you say integer, array name is not a variable. It is just a mnemonic, which means it is a meaning, or it is a other way of representing the address. So anywhere in the memory, no space is allocated to the array name. To the entire array, memory space is allocated, like A of 0, A of 1, A of 2, A of 3, A of 4. But then to the array name itself, there is no memory space allocated. It is just a representation, other representation of the address. For example, like this. If I write anywhere A is as good as writing the address 100. Got it? Okay. So whenever I say we have an address, what does it mean? We are actually standing at that address. So whenever I say A, whenever I use the name A, then it is as good as standing here, isn't it? At the address 100. And if I say star A, then what does it mean? So star A is nothing but you go into the cell where that address is given. So we are going inside. So star A is also nothing but A of 0. Got it? Star A is nothing but A of 0. And now if I have to go to A of 1, you might feel that if A's address is 100, right, and A of 1's address is 102, you might feel that I might have to add A plus 2 in order to go to 102, right? So you might think that if I write A plus 2, it is totally 102, and therefore I am standing here, and if I put a star, I will go inside, right? And so you might think that star A plus 2 is equal to A of 1, which is wrong. So here we are going to have something called as address arithmetic. Address arithmetic works this way. So whenever you try to add a integer to either a array name or a pointer, the addition will be scaled addition. Scaled addition means if the array represents elements of an integer, then the addition will be scaled. Or I'll just tell you in simple words. So here, if A represents the 100, if you are standing here, then A plus 1 represents the next element in the array of A, which means A plus 1 will actually represent 102, this location, and A plus 2 represents the second element from A, which means if A is representing here, then the A plus 2 is 2 elements after this, which means here, right? So this is called as address arithmetic. So whenever you write A plus I, it is not actually A plus I, it will be converted internally to A plus I into size of integer in this case, okay, into size of integer in this case, but in general whatever the type of array A is, right? In fact, whenever you write any address, any suffix A of I, it will be converted like this. So watch it. So now I'm saying, what I'm trying to say is, if A is pointing to the A of 0, then A plus I will point to ith element beyond A of 0, right? A of 1 will point to first element after A of 0, right? And A of 2 will point to second element after A of 2. So what I mean to say is, whenever you have an array name and when you try to add some integer I, then it is going to take you to ith element from that starting point. Are you understanding this? So now assume that you have written A plus 3. What does it mean? If A represents A of 0, then A of 3 represents the third element, after A of 0. And A of I represents the ith element after A of 0. So see this. A of 0 is representing this. Then what is third element? 1, 2, 3. Therefore, this one is A of 3, right? So A plus 3 means you will be standing here exactly at this point. If I put a star, then you will be getting inside it, right? You will be standing here. Got it? Now you can access these two elements or these two bytes using this. So this is equal to A of 3, isn't it? So even though in most of your programs you are going to access like this, a third element of array, fourth element of array as A of 3, it will be converted internally by the compiler to this. This is user friendly, this is machine friendly, right? A pointer kind of representation, right? And even this one is also right. See, you can write it like this, or even this one is also valid. A plus 3 is nothing but the address of A of 3. Understood this? So what is the meaning of it? You go to the A of, okay, one more thing, should I put a parenthesis here? Not required, because this suffix operation, this array suffix operation is having higher precedence over the unary operation. If you remember that precedence order, this suffix operation is in the first row, which means highest priority, highest precedence, and then the unary operator. You need not put any braces. It means that you take the element A of 3, right, and then you take the address of it. This is nothing but the address of it. A plus 3 is also nothing but address of A of 3. Now in order to get into A of 3, what you should do is take the address of it and then put a star. If I put a star, see, A plus 3 is nothing but standing outside. If I put a star, I will be getting inside, which is nothing but A of 3. Got it? So this is how you can add integers to the array name and you can go to any point, right? The same way you can do the same kind of arithmetic using the pointers also, right? So what I mean to say is, watch it. Now at this point we could even do this. Let us say I am declaring a new pointer int star p. Now what does it mean? P is a pointer which points to an integer, right? And now we have an array of integers. If I write like this, p equal to ampersand a of 0, what does it mean? To the variable p, you are putting in the address of a of 0, right, inside the variable p. So if I have a variable p, right, writing like this is nothing but inside the p I am putting address 100. So what does it mean? This p will now point to a of a of 0. Now the same thing will happen if I write p plus 1. If I write p equal to p plus 1 or p plus plus, then what happens is, instead of incrementing the pointer value by 1, it will get incremented by 2, because here the element is here the size of an element is 2 bytes, right? Which means if I write p equal to p plus 1, then the p will become 102 and it will now point to the second element, right? If I add one more time p plus 1, then it is going to point to the next one, right? So how does this pointer know that? How does the compiler know that whenever I do p plus plus, whether I should add 2 bytes or 4 bytes or how many bytes? In order to know that, this declaration is going to be useful. That is why even though all the pointers or of same size, declaring a pointer to be of some type is important, because when you do this arithmetic, address arithmetic, when you try to increment it by 1 or 2 or I, then depending on the type of the pointer, it will increment it appropriately. Got it? And one more thing, if P is pointing to A of 0, right, and I told you that P plus I points to the ith element after A of 0, right, which means you will be actually standing, okay, let's take a small example. P is actually initially taken as A of 0, which means P is having the address 100, okay. And now if I do P equal to P plus 3, then what happens? If I do P equal to P plus 3, then 103 will be incremented not by 3 but by 6, which means this value will now become 106, right? P value will now become 106. So 106 means we will be pointing here, right? So this value now P, if I call P, it is as good as standing here, right? Or let's not increment it, let's put it this way only. I'll just show you with an example. See, let's say P is 100, and now if I write P plus 3, what does this mean? P plus 3 is actually 106, right? So 106 is nothing but address of this point. So when I refer to P plus 3, it is standing outside here, right? And when I put a star, it is actually jumping in, right? Therefore star P of 3 is equal to A of 3, right? And moreover, P plus 3 is equal to A plus 3, that equal to ampersand A plus 3. Are you getting this, or is it confusing? Initially it might be confusing, but later slowly it will be very easy to understand. See, what I mean to say is, if P is pointing to the beginning of an array, P plus 3 will point to 3 elements beyond the beginning of the array, and if I put a star, I'll be entering into it, right? Therefore it is as good as writing A of 3, right? And if this is true, which means if P plus 3 is the address of A of 3, then P plus 3 must be equal to A plus 3, which is equal to address of A of 3, isn't it? There is no need of any parenthesis there. Are you getting this? So now all the representations are equal, right? And one more interesting and surprising thing is, it can even be written as P of 3, which means if P is a pointer, I can use as if it is an array. P of 3 means it is P plus 3. Got it? So now so this is not equal to P of 3, this is equal to P of 3, right? I mean, I could directly use a array name and a pointer both as same. Okay, so now what you understand is, either it is a pointer or a array name, both are almost acting like the same, isn't it? See this, wherever there is array name, I am putting the pointer, and wherever there is pointer, I am putting the array name. Then what is the basic difference between these two is, a pointer is a variable but a array name is a mnemonic. So only difference between a pointer and a array is, if I have the A as the array name, then assigning A to some value, let us say A equal to A plus 1 or A plus plus or anything like this, A equal to P, all these are not allowed, they are all illegal. The reason is, A is not a variable that you can assign it some value or increment its value and then assign. A plus plus is actually equal to A plus 1, isn't it? You cannot do this, or you cannot assign it with any value. But on contrary, P is a variable, therefore you can either increment it, right, which means you can do P equal to P plus 1, or you can do P plus plus, or you can do P equal to some variable, right? So all these assignments are perfectly valid for a pointer. This is the basic difference between array and a pointer. So array name is a mnemonic to the starting address, and if I use a pointer to point to the array, I can just then use the pointer as if it is an array without using any of this, right? So what is the advantage of using all this? Why they have implemented this way is, whenever you try to pass an array to a function, what we really pass is the starting address, and that starting address will be taken by a pointer in the calling, the function called, which means let us say there is a function calling, and now we want to pass an array to different function. Then when we pass this array name as the argument, then the other side, the receiving function, the called function, can use a pointer to take this array name, the base address, and then using that pointer it can do exactly the same operations which it would have performed on the array. Got it? Okay, anyway, if you didn't understand it, forget it, but just understand that array name and pointer both are almost same. This is the relationship between arrays and pointers. Okay, fine. What's this? What are the various, this is called as arithmetic. So what are the various types of operations that are allowed on pointer, right, or address arithmetic? So which means if you have a pointer variable, since it is a variable, you could do many things, right? If you have integer, float and char, we could do many things on the variables, right? So, and pointer is also a variable like all the other variables, right? So what are the various operations which are possible on the pointer variable is, one is assignment of pointers of same type, which means if two pointers are of same type, we could assign them to each other. For example, if I have int star p and then star q, what does it mean? P and q are two pointer variables which are of same type, which is int, right? Then you could assign them. P equal to q is legal, and then q equal to p, it is also legal. Got it? And similarly, maybe you could even assign this also, right? Star p and a. So here a could be treated as a pointer to integer. So p equal to a is allowed, but then you cannot write a equal to p because a is a mnemonic, not the variable. This is also allowed, right? So this is perfectly allowed. So assigning pointers of same type is perfectly allowed. But then if you try to assign pointers of different types, then you have to go through the typecasting, which means if I have char star c, which means c is a pointer of type character, then assigning p to c or c to p, it is not allowed, even though c, p and q all are of same type. Either it is a pointer to a character or a pointer to an integer. I told you that all the pointers are of same size, right? And assigning should not be of any problem. But then why should you not assign it is, when you try to increment it or decrement it, then the compiler might get confused about the scaling. So how much should I scale? If I say p equal to p plus I, then in case of integer it will be p equal to p plus I into size of int. In case of character, p equal to p plus I into size of char, right? So when I have char and then int pointers, assigning to assigning one to other will require some typecasting like this. Now p equal to c, it is a character, is a pointer to character, and now I am assigning it to a pointer to integer. Then you have to typecast it, int star. You should always do it, except in one case. The case is if c is a void star pointer, right? So what is a void pointer is, okay, I'll tell you that later. Unless c is void pointer, you have to do this typecasting and then assign it, otherwise it is not allowed. So assignment of pointers of same type is allowed only when they are of same type. If they are not of same type, then you should go through this typecasting. And next one is adding or subtracting a pointer and an integer, which means if you have a pointer, you could either add a integer or subtract an integer. So what I mean to say is, let us say this is an array and p is pointing to this point, right? If I say p plus 1, it means that you are talking about this one, p plus 1. So don't worry about what is the type of this array and how much how many cells each element is occupying. That will be decided by what the type of p is. In case if p is an integer array, integer pointer, then if the array is also of type integer, then p equal to p plus 1 will increment you exactly by one integer, right? And then p equal to p minus 1 will decrement you like this, right? but whenever you do this decrementation or incrementation, you should be sure that you never go out of the bounds. In case if you go out of the bounds, then you are going to get some error, right? So you are not supposed to fall out of the bounds. If there are only 4 elements, you are not supposed to write p equal to p minus 5, right? That is where you should be careful. Okay, so adding or subtracting a pointer and an integer is allowed, but then you cannot add a float, or you cannot add a long, or you cannot add anything which is not an integer, right? And moreover, you cannot multiply a pointer and an integer. Only allowable operations are add a pointer to an integer or subtract a integer from the pointer, so that if you are pointing to some element in the array, you could either move forward or you could move backward by adding or subtracting. And next one is subtracting or comparing two pointers of the same memory. So this is interesting. So see this, if you have an array like this, and if you have two pointers pointing to the same array, right? So let us say this is p and this is q, both are pointing to the same array, then I can compare them, which means I can check whether p is less than or equal to q. So p is less than q will be true only when p points to an element which is which is to the left of q. So I can compare them like this, which means I can write if p is less than q, then maybe I can write printf p is pointing to element less than q, right? Something like this. Or you can even write subtraction, which means you can do subtraction of two pointers, provided that both are pointing to the same array. So which means I can write like this, I can write q minus p, right? So q minus p decides, let us say I want to find out how many elements are there between p and q including pq, right? Then what I could write is q minus p plus 1. If I write this code, this expression will give you how many elements are between p and q including p and q. Let us say this is an integer pointer, right? Integer array 100, and each element is taking up 2 bytes, right? Then 108. Now what will be p minus q is, actually p minus q has to be 4, but then 4 will be divided by 2 because it is scaled down version, scaling is used, right? So p minus q minus p, even though it is 4, it will be 4 divided by 2, which means 2. Therefore q minus p is 2 and plus 1 is totally combined, it is 3. So number of elements between these two are 3 including p and q. Got it? So that is how you could use the pointer subtraction. Generally pointer subtraction is used in order to see how much space you have between two pointers, right? That is the application of this. And then these are allowed. So one is you can subtract or you could compare. These two are allowed perfectly. But then what is not allowed is you cannot add two pointers, right? Or you cannot do any other operations like left shift, right shift, nothing. So only thing that are allowed is subtraction. You cannot add or multiply pointers or divide pointers, or you cannot do left shift, right shift. Only thing is you can subtract two pointers, right? And then coming to assignments, generally assigning a value to a pointer directly is not meaningful, but then assignment is allowed only if you are trying to assign a 0. Assigning a value to a pointer is generally not meaningful, it will be meaningless. But then only kind of assignment which will be allowed is assigning a 0 and then comparing a 0. So which means we can compare whether a pointer is equal to 0 or not, which means you can write if p equal to 0 or not. This is valid, but then it doesn't look good, right? So just because of that reason, in studio.h we have null defined as 0, hash define null as 0. So whenever you want to use a 0, it is better that you use a null. So if you do that, it will be meaningful. Just like assigning 0 and then comparing to 0, they don't look good. And moreover, C makes sure that in C programming language, C makes sure that there will be no element which is at address 0. Therefore, you can assign or compare with 0. So generally 0 is used for error case, which means whenever you are trying to test whether pointer is valid or not, we generally test whether it is 0 or not. So this is just for testing. So only these are the valid operations on the pointers. Other than this, you are not supposed to use any other operations. Okay. In C programming language, what happens is very often we will not generally try to pass as argument any other arrays. We only deal with, or mainly we deal with this character arrays most of the times. For example, printf is the main example. So printf, scanf, if you watch these functions, so you might have seen like this, right? Printf, something like this, Ravindra, right? So this is called as this particular thing, right? So whenever you put a array of characters, right, within this quotes, then we call this particular array as a string constant, and the string constants are widely used in C programming language. So like this is called as a string constant. And now there are various ways you can declare string constant. One way to declare string constant is you can declare it as a array. Okay, it is not a string constant. One way to declare an array of characters is you can declare it like this. A character, A is a character, A is an array of characters. You can declare it that way. And now if you see it, this array is having 1, 2, 3, 4, 5, 6, 7, 8 elements, right? So you might think that array A contains exactly 8 elements, but then whenever you declare any array like this, and when you try to initialize an array like this, along with this, see R, A, V, I, N, D, R, A. So the array will contain all these 8 elements at 8 different cells, right? That is fine, but then at the end you have a null character. So null character is generally used at the end, or generally stored at the end, just to indicate that this is the end of the string. So whenever you declare any string constant, and when you try to assign it to an array will be actually created, and inside that array you can look the elements like this, right? In fact, this is A of 0, A of 1, A of 2, A of 3, A of 4, 5, 6, 7, 8. And you can go into any element and you can you can change it, you can modify it. For example, after declaring it like this, I can say A of 3 equal to maybe A. Then what happens, in this location it will be changed to A. That is perfectly fine. But then when you declare a character pointer, and when you assign it to the starting address, or when you try to point it to a string constant, then what happens is somewhere in the memory, this entire Ravindra will be created. That string will be created, and it will be assigned at the end also there will be null character, everything is same, but then P will be pointing to the starting of the array. Let us say this is 100, then P will be containing 100. Got it? And you can use the P same way as you are using A, which means you can say P of 3. So when you write P of 3, it is nothing but you are trying to refer this element, right? Or you can write P plus 3. So what is P plus 3? P plus 3 is third element beyond the element which I am pointing now. Currently I am pointing at R. Then what is the third element? 1, 2, 3. Third element, which means this one, right? So P plus 1 is that, and if I put a star, both are equal. These two are actually equal to writing it as if it is A of 3. In case if this would have been an array A, then both are actually same. The main difference between this declaration and this declaration is, or this usage and this usage is, in case of an array is created and you could actually change it. You can go into the array and you can modify the string value present, but in this case you cannot modify the value present in this. That is the main difference, which means you cannot try to assign any value to a location given here. You can access the location using P, but you cannot change it. Why? Because it is a string constant. Okay, so the main difference between array declaration and the pointer declaration is you cannot change here, but you cannot change here. Okay, that is what you should remember about this. And then I have taken an example from this Dennis Ritchie book. Now, this example I have taken it because I like it a lot. It is simple way of copying a character array into the other character array, or string copy. So the same kind of code will be written whenever you have to copy, work with strings or copy the strings. I'll just explain you what they are trying to do here. They are trying to copy T into S, which means there is an array which is pointed by t. Let us say the array is like this, okay, and now there is an array which is pointed by s. Fine. Now this code is going to copy all the elements of t into the element of s. So what you could do is, maybe if you want to implement it, the calling function should have already some string constant or a character array which contains this value, and then it should create enough memory and then send the enough memory means either an array or some memory allocation, enough memory, and then send this pointer and this pointer to this function. Then this function is going to work like this, okay. Watch it once. Star s plus plus. See, this plus plus, when it is mentioned after a variable, it is called as post increment. So post increment will increment the variable only after the operation is done, right? So after everything is done, it is going to increment it. And here also t plus plus, so it is also post increment, which means t value will be incremented only after all the operations are done. Now watch it. Star s plus plus equal to star t plus plus. So what does it mean? It means that you are going to read something from t and you are going to assign it to s, right? So star t means whatever is being pointed by t is taken, which means this value is going to be here r, and it is going to be assigned to star s. Star s means wherever s is pointing to, right? Which means r will be taken and copied here, right? And then s plus plus and t plus plus both will be incremented. Got it? And again the same thing, a will be copied here and both will be incremented. And again b will be copied here, both will be incremented. I will be copied here, both will be incremented, right? And finally, whenever this null is copied, what happens is, after the null is copied, then there will be a comparison, right? I mean, not comparison, the entire expression, the value of the expression. See, whenever t value is null, the value pointed by t is null, and when that is assigned to the value s, right, the entire expression value will become null. So remember this, the value of an expression is nothing but the value of the left hand side. So whenever this one has become null, and this will be assigned to this, and the entire expression will become null. Now it is while 0. Null is nothing but 0, isn't it? So while 0 means it will break. So at the end of the character, it is going to break. That is why we are going to use null. Got it? So it is a simple way to write the code. Just in one line we have copied the entire string. Got it? So if you want to see how does this pre-increment, post-increment work along with the pointers is, or there are beautiful ways in which you can combine these operators and without writing any parameters, parentheses. If you know the precedence and associativity rules, then what you could do is you could write the C programs in a very beautiful way. It will look very precise, in concise manner. You can write a very big program in a small way. So initially it might be difficult for you to read it, but once you master it, the way you write the code will be really beautiful. So I'll just show you how to write it. Let us say we have an array like this, and I'm having a stack. Okay, and now this is P is pointing to the head of the stack, right? And I want to push a value onto the stack. So how does pushing work? Whatever value is being sent, that will be written here, and then P has to be incremented, right? So if P is a pointer, actually you should write it like this, right? Star P equal to value, which means whatever you want to push, you can write it there, right? And then you have to write P plus plus, isn't it? Now we could actually combine these two operations into one line. How? Now see this. How we could combine these two operations into one line is star P plus plus equal to value. If I write like this, then what happens is the value will be written into the star P, and then P will be incremented. These two are equivalent. So just in this line we are going to write it. Understood this? So one thing you should remember about post increment is after the operation is performed, then the value will be incremented. Now let's see how to pop it. So how do we pop it? We have to decrement it first and then return it, isn't it? That is how popping works. we have to decrement it first and then return it, right? So how does it work? P minus minus, you decrement it and then you take the value which is pointed by this. This is what is popping, right? Then how can I write it in just one line using this pre-increment? You can write it like this: P minus minus, decrement it and then take the value and you can assign it to the value, which means value equal to minus minus P. First you decrement P and then you take the value pointed by that. Got it? So this is how you could use without any parenthesis. See, there is no need of putting parenthesis. You might feel that I had to put the parenthesis like this, which means you might feel that I had to put it like this and then this, right? Or you might feel that I had to put the parenthesis like this and then this, just implement. But then parentheses are not required. If you understand the meaning, you can directly write it. But initially it takes some practice, right? So in GATE they will not ask you any such questions, but when you go for interviews, maybe you will see such questions. So with practice you will be able to understand it. Okay. So in order to know or learn how these C programs are written in a simple way, I suggest that you read the code written by others. Maybe you can Google out and you can find some good programs, good libraries, and then you go through the code. There you understand how the experienced programmers will write the code compared to how we generally write it. Okay, fine. So this is about the character pointers and the functions. Now let's see this array of pointers. So now we have seen the normal pointers, and since a pointer is a variable, we can even declare an array of pointers, right? So see this. Now if I write like this: character star char star name and then this array symbol, what it indicates is that name is an array of pointers to character. Okay, so better I'll explain you how it is represented. What does it mean is, name is a array, fine, right? And it is a array of pointers, okay, array of pointers to characters. That is the meaning of it. So which means this name is an array of pointers to the characters. So it has to point to the characters, right? And then it is initialized this way. And this is a string, this is a string constant, this is a string constant. Then whenever you do this kind of initialization, either you can do this kind of initialization, this is called static initialization, which means we are doing it before running the program, or you could do it with the code. How? By using the malloc. I mean, you can declare a memory and then you can write something into the memory using malloc, and then you can point to that particular memory block. Or this is called static initialization, right? So it will look like this. It will have 1, 2, 3 R A V I and then null. Similarly, have 1, 2 R A V I and D R A, right? And then null. Every character will be in one cell, right? And then this one will also be the same. R A V I N D R A B A B U, right? And then null. Right? So what is the meaning of this is, name is an array of pointers to characters. So each pointer is supposed to point to a character, right? So it doesn't matter whether it is an array or a pointer, because even if it is an array, that is also a pointer, isn't it? See, even though it is an array starting address is nothing but a pointer to a character, right? Now if you have to access anything, let us say, now we know that name is an array. So what is the name? Name is simply an array. Now I told you that when name is an array, it is a mnemonic to the starting of the array, right? So let us say this one is 100, right? And assume that each pointer is of size 2 bytes. Then what will be the address of this one? 102. What will be the address of this one? 104, right? And assume that this one is 200. And assume that each character is of size 1 byte. Then this will be 201, 202, 203, 204, right? So like this you can think of it. Okay. Now if you want to access, or let us say you want to print one of the array, one of the string completely. Let us say you want to print this completely. Then how you can print it is, first you point to this starting one, right? So how can I point to this? If name is the array, right, I can write like this, name. If it is starting to the base or starting, then how many elements should I move? One element. Therefore name plus 1 will actually take you to 102. If I say 102, I'm standing here, isn't it? Outside. If I say name, I'll be standing here, and if I say name plus 1, I'll be standing here. And if I get into this, then I could go here, right? Let us say this is 300, then this one will contain 300, this one will contain 200. If it is 400, this one will contain 400, right? Now if you have to print this entire thing, you should give to printf the command, the printf function call the starting of this array, isn't it? The starting of this one. So where is the starting of this one? It is here. Therefore you are here initially, name means 100. Now when I do name plus 1, I'll be here standing outside, and if I put a star, I'll be jumping in, right? So if I put a star here, I'll be jumping in, which means I'll be here, right? So standing here is as good as standing here, right? I'll be here. Now if I want to print it, I can print it. If I give it like this, I can say printf %ls, right? I can say this. Now this entire thing is going to take me to here, but then you are not supposed to see, this is very important, this parenthesis is very important. If I write like this, then name will be incremented first, therefore from here you will go here, and then star means you will jump into this, and therefore you will be standing here, and that is the beginning of this particular string. Therefore Ravindra will be printed. If I write like this, Ravindra will be printed, isn't it? Because at the end there is null, it knows till what point to print, right? In case if you don't give the parenthesis, if you write without parenthesis, let's see what happens, just for the sake of analysis. Okay, printf %ls. Now I will not write this parenthesis, I'll directly write star name plus 1. Let's see what happens with this because of this. Okay, now name, you know that it is 100, and when I have plus and star, I told you that in the table, if you see this, first row is containing the subscripting, and then the string, that membership elements, that dot and star, and the second row is actually that dot and this arrow kind, and the second row is going to contain unary operators, isn't it? So unary operators have higher precedence than the arithmetic operators. Therefore if I write star name, then what happens is name is nothing but 100. So 100 means you are standing here, and now if I put a star, then I'll get into this, which means star name means I'll be getting into this, which means 200. Therefore I'll be standing here, right? And when I do plus 1, I'll be standing here, isn't it? This element. So I'll be pointing to A of the first one. So when I try to print it, since the input given is the starting of from here A, the output printed will be AVI of the first array. Getting this? In case if you want to access only a particular character, let us say you want to access this particular character A present here. Where is A present? It is 0, it is 1, it is 2, it is 3, it is 4, 5, 6, 7. So A is 7th element after the first element, isn't it? In general it is 8th element, but if you start from 0, this A is 7th element after the first element. Okay, and now how we could access it is, see, in order to go here, I have to first come till this point. In order to come till this point, I have to come here, right? And if I have to reach here, I have to reach here. If I have to reach here, I have to reach from here. Are you following it? See, from here, only thing that you have in your hand is the name. Got it? And from there, you have to reach everywhere. So, in order to reach this, I am going to do like this. See this. First, I'll take name, and then I have to reach from here to here, isn't it? So if I write name plus 2, see, name is here, and this element is 2 elements after name, therefore name plus 2 will actually get me here, right? And then I'll put a star. So I'll be jumping inside. Jumping inside means I'll be having 400. So being here is as good as being here. So having a element 400, address 400 is as good as standing at the address 400. Now you are standing here, so this entire thing is actually 400. Now what should you do? You should add to this 400 7, so that you can reach there, right? Therefore plus 7 is going to take you to where you want. Understood this? So if I write like this, I'll be accessing this particular element. You can write printf %c, and then if you give this address, it is going to print whatever you wanted. Got it? So that is how you can think of it. So one way is I'm thinking of name as a pointer, and then I'm incrementing it +1 +2 like this. Or you could even use name as an array. In fact, name is an array, isn't it? Name is an array, it is not a pointer. What is the difference? If it would have been a pointer, you could change the value, but then name is not a variable, it is now an array, it is just a mnemonic, right? So what you could have done is, now if you have to access this one, you could even write like this. If I write name of 2, it is name of 0, name of 1, name of 2. Name of 2 means you will be inside here, right? So standing here is as good as standing here. Then if you want to go till this point, now you could have written 7. Name of 2 7 is going to be like this, right? So if you observe this, now the array of pointers is even similar to the multi-dimensional array, isn't it? So multi-dimensional array and the array of pointers have some similarities, right? So except that, okay, now let's see what is the other way of saving the same information in a multi-dimensional array. So instead of doing this, I could have done some other thing, right? So I hope that you understood this. Okay, I'll do one thing. I'll just tell you how if I would have implemented this as a multi-dimensional array, how it looks like. See, did you understand this one? See, what I mean to say is name of 2, this one is representing in the name array, you go to the second element and inside it, right? So you know this, whenever I subscribe it like this, it is equivalent to star name plus 2, isn't it? So name is 100 plus 2 is 104 and star is jumping inside. So this entire part is 400, which is nothing but the pointer to the beginning of the array. And then whenever you have a pointer, I told you that pointer with the offset is equivalent to array with the index, right? Which means I could even use like this 7. Got it? So it is now like, if you watch it, it is just like accessing the multi-dimensional array. Now let's see what is the actual difference between a multi-dimensional array and then the array of pointers. Okay, the same thing would have been declared this way also, like this. You could have declared this as char, let's write array, 2-dimensional array. So how many rows we want? We want 3 rows. And what is the size of the maximum size of the column? So maximum size of the column depends on the maximum element, 1 2 3 4 5 6 7 8 9 10 11 12. So we wanted 12 elements, and along with the 12 elements you would even like to put a null character. Therefore I am going to write 13, right? So this one is going to create an array, right, which is containing 3 rows and 13 elements, and the 13 elements are going to be, I could even initialize it the same way. Right, then what does it mean is an array will be created which will have 3 rows, 1 2 3 rows, then 13 elements will be there, 1 2 3 4 5 6 7 8 9 10 11 12 13 elements will be there, right? And now the first element, the first row will contain RAVI followed by a null, that's it. And the second element will contain RAVINDRA followed by a null. See, this null is not 2 characters, it is simply 1 character, right? So null is actually 0. I mean null is defined in studio.h. It is defined as hash define null as 0. Okay. And next one is Ravind Rababu null, right? So this is the difference. Now this is an array, right? And again you can go to any element. Let us say if you have to go here, then what is the logic you have used earlier? Earlier you have used the logic name of 2 comma 7. Here also you can use the same thing. This is 0 1 2 0 1 2 3 4 5 6 7. If you have to reach here, you have to write like this, isn't it? Array 0 7, like the earlier only, right? Sorry, 2 7, right? So everything is same, but then coming to the memory, there are some few the memory layout, there are some few differences. One difference is here, even if you use the memory space or not, you are supposed to declare everything to be of same size. So if I use a multi-dimensional array like 2-dimensional array, then all the columns should be of same size, right? Or sorry, all the rows should be of same size. Even if you use this space or not, it is irrelevant. But then if I go with the array of pointers, I have a liberty to have different size rows, which means each row can be of different sizes, right? And here the total space taken is equal to the total size of the array, right? But here the total space taken is equal to the total number of rows and the space taken by each row plus the amount of memory required for pointers, which means these pointers are going to be taking extra space, right? And in C or in any language, wherever these pointers are there, array of pointers are more popular than the multi-dimensional arrays because it uses same functionality, and most often every row, each row can be of different sizes, right? And if each row is of different sizes, this is simply a wastage of memory, and this is a better utilization, right? And moreover, accessing using a array is easier compared to the using the pointers is easier compared to the array, right? So either you use it as a array of pointers or a multi-dimensional array, both are almost same. Only thing is the way they are represented is different, and here the advantage we get is each row can be of different sizes, right? Okay. So whenever you try to pass a array to a function, one-dimensional array, right? Like a character array, that is very often we do that, right? In printf, I told you that the receiving function is supposed to be declared with a pointer. So in C, we actually pass by value, and the value cannot be, we generally don't have any operations in C programming language which will take the entire array and copy it to some other place. We have to do it element by element. Therefore, when you try to pass an array to a function, we are not going to pass the array as a whole, we'll just pass the starting address of the array. So what I mean to say is, see this. Now if you want to send a array to a function, right, then you are supposed to declare the array function like this. Function, if you want to send a one-dimensional array to a function, then you are supposed to declare it like this: int a of 5. So you could declare it like this, no problem. So in case if you are passing an array some array which is having 5 elements, you could send it like this. But even if you send it like this, even if you declare the function like this, in fact a will be considered as a pointer, which means inside the function a will be just a pointer, not an array, which will be a pointer to an array, to a integer, which means inside this function a will be declared as simply a pointer to one element, and that one element will actually be first element in the array that you wish to send, right? And since it is simply a array, a pointer, you need not even specify the size of it. So other way to declare the same thing is, you could even declare it like this. So int a without even saying the size, right? So it is also going to act as the same thing. Somewhere in the main function, if you call function of b of 5, function of b, I need not even say function of b of 5, you can call it with function of b. Then what happens is, if B is an array. Let us say B is an array. In B is an array of 5 elements, right? Then what happens is, this is the B, which is the array, and to that particular B, the starting address of that B will be stored in the pointer A, right? Even if we declare it this way, int A, right, even the same thing will happen, right? So the same thing, B will be there, and 1, 2, 3, 4, 5 elements will be there, and A will be a pointer which will be pointing to the first element of the array, right? So even in case if you are writing it this way, fun, since it is simply a pointer, you need not even use any subscript symbol also, subscription, array subscription symbol. You can even declare it like this, right? And even this can receive this function, and it is also going to act as the same way. We have 5 elements, and then A is going to point to this, right? Everything is same and all are okay. So from this you would understand that you need not really specify the number of rows, I mean the number of elements in the array if it is the one-dimensional array, isn't it? Now how to pass a two-dimensional array, right? So when in case if you are passing a two-dimensional array, then you could write like this. If it is a 5 by 6 array, I could write like this. So it means that this function is going to take as argument an array of 5 by 6 size. So the calling function can send a array whose size is 5 by 6, okay, and the receiving function, this called function, the function which is called, can take this one, right? In fact, here A is again an array of pointers, or it is an array which is pointing to or it is like this, okay? So what I mean to say is, in this case B is a 5 by 6 array, isn't it? So B is a 5 by 6 array, which means there will be 5 rows, 1, 2, 3, 4, 5, right, and then 6 columns, right? Then what actually B is pointing to is, this is B, right? So what actually A is pointing to will be, it will be pointing to an array of 6 elements. Therefore you need not specify again the number of rows, right? So instead of this, what you could write is function int A. You could leave it like this, and you could declare it this way. So which is going to say that A is an array, A is a pointer which points to an array of 6 elements, right? So here A will initially point to the starting row, and you can increment A and you can go to the next row, increment A and you can go to the next row, increment A and you can go to the next row, and access all of them. So in general what happens is, we know that the size of the each row is 6 elements, but we don't know how many rows are there. Size of each row is 6 elements, which means number of columns that can be known because that is declared, but we are free to leave out the number of rows. Then how are we going to get it is, you have to get the size of the array through some other means, or in most of the cases what they do is, in general they will have a null at the beginning here, or 0 or some indicator which indicates that this is the last row, right? But then this is quite popular. You could even send it like this. So what I mean to say is, send it like this, it is fine, but then this is also allowed in C, right? So when you are sending a two-dimensional array, or in fact a multi-dimensional array, you can skip the first dimension completely and you can send all of the remaining. Anyway, that particular element is again a pointer which points to an array of 6 elements. So if that is the case, you could even declare it in some other way, right? See, if it is an array which points to a row of 6 elements, you could even declare it in some other way. So what is it? A is an array, right, which points to an array. A is a pointer which points to an integer array of 6 elements. This is the meaning of it. So even this is this or this or this, all are equivalent, and this is how you could send a multi-dimensional array, right? You could by heart it. At first go it might be difficult for you to understand this, but then if you by heart it, it will be easy, right? So what I mean to say is, with practice it will be easy, don't worry. See, whenever you want to send multi-dimensional arrays, then one way is you can send it like this, or you can skip the first dimension completely. Even if you have n dimensions, you can skip the first dimension completely, right? Or you can even write it like this. So one thing you should do is, we should remember is, this representation, okay, there is a difference in this. If I write like this, int star a and then 6 and int star a and then 6. So these two representations have some difference. So in this case, a is a pointer to an array of 6 elements, right? A is a pointer to an array of 6 elements, to an array of 6 integers, right? So why is this so? Because a is first associated with star, which means a is a pointer, and then it is pointing to an array which is elements of 6. So you could visualize it this way. There is an integer array which is containing 6 elements, 1 2 3 4 5 6, right? And now a is a pointer which points to an array of 6 elements. This is the meaning of it. Now if you write it like this, see, now this means that a is an array, because if you watch it, if you remember that operator precedence table, in the first row the array subscription is present, and in the second row the unary operator star is present, right? Therefore a is an array of 6 elements, and which are all pointers to integer. So it means that a is an array of 6 elements, 1 2 3 4 2 3 4 5 6, and all these 6 elements are pointers to integer, which means there is some integer and is going to point to this, and there is some integer and is going to point to this, like that, right? So this is the difference between these two. So whenever you apply a parenthesis here, it means to say that a is simply a pointer which points to an array of 6 elements of type integer. If you write like this, the meaning of it is a is an array of pointers to integers, because this one will get higher precedence compared to star. Therefore a will become array immediately here, a will become a pointer immediately here. Are you following the difference? See, a will immediately become an array, a will immediately become a pointer. Here a is an array of 6 elements, and all the 6 elements are pointers to integers. Here a is a pointer which points to an integer array of 6 elements. A is a pointer which points to an integer array of 6 elements. Here a is an array of 6 elements. This is a is an array of 6 elements, and each element is a pointer to an integer. Each element is a pointer to an integer. Got it? So in that way you can even declare it like this. So what I mean to say is, whenever you want to send a multi-dimensional array, right, you need not specify all the dimensions, you can skip the first dimension, right? And in case of 2-dimensional arrays you can use this. So anyway, this is not widely used notation, right? But still it is given in that Dennis Ritchie book, and most of the questions are from Dennis Ritchie book, so it is worth knowing about it. So they might ask some questions from this. Okay, fine. Even though a function is not a variable, but still C will allow you to define pointers to functions. And whenever you are using a function, you can even use a pointer to function and make a call to the function. But anyway, this pointers to functions are not widely used. In the sense, if you want to write something with pointer to functions, you could even write it without that concept completely. At least I have never used any pointer to functions, or even I didn't read any good code written by in very good libraries. I never read any code written which is using pointers to functions. But still C has allowed this, and in C programming language it is defined. So let's talk about it. I'll just give you the introduction and uses. You can use it in your programs, you can write the programs, but then I really don't encourage you to write any program using pointers to functions, because it will be very difficult to read. And later I'll tell you, with a combination of pointers and pointers to functions and arrays, the program will become very unreadable, and even the declarations will be very difficult to read. Later I'll show you that. Okay, anyway, I'll just explain you what is the concept of pointers to functions. Okay, assume that I have a function like this: integer sum int and int, right? This is the function which I declared. So what you understand from this, there is a function which is called sum, which is going to take two arguments, and both the arguments are of type integer, and the return value is also of type int, right? So assume there is a function which will take two numbers, add them and send you the result. That is a simple function. Now I want to define a pointer which points to this function, and even I want to use the pointer to call this function. So let's see how that could be done. Okay, so you understood this. So now I want to declare a pointer to the function. So this is a pointer to the, this is a pointer, fp is a pointer, right, and which is a pointer to a function. Therefore I am going to write like this, and the function is having two arguments, right, and it is going to return int. Now, is this a pointer to the function? Let's analyze this. See, what are the operators that are present in this declaration? There are two operators if you see it. So one is parenthesis, right? Parenthesis is used to denote that it is a function, and the other is star. Star is used to indicate that it is a pointer. But then if you observe it, this parenthesis, the function calling parenthesis, that is having higher precedence compared to this unary star, isn't it? Therefore, if you leave it like this, what is the meaning of it is, it says that fp is a function which returns a pointer to integer. That will be the meaning of it. So fp is not a pointer now, it is a function which returns a pointer to the integer. That is why, just to avoid this confusion, we are supposed to write like this, right? If I write like this, then what happens is, you see now, how many operators are there? One parenthesis, two parentheses, and then the star also, right? Now if you look at the parentheses are left associative, left to right, right? So the first row is left to right, which means I have to evaluate this one first, isn't it? Now if I evaluate this one first, then I get that fp is a pointer to a function which is having two arguments, which is returning a int, isn't it? Sum is a function which is having two arguments, which is returning int. Now try to understand this. See, it is initially somewhat difficult, but once you understand it, it's very simple. Okay, see this. What I am trying to say is, fp is a pointer to a function which is taking two integers as argument and which is returning an integer, right? And similarly, sum is actually a function which is taking two arguments as input and which is returning integer as which is returning integer. Therefore, this fp can point to any function like this, right? So in fact, if you want to have a generic pointer, generic pointer to function, then you could actually make this function pointer point to any function which is having two arguments and which is returning one type by using the typecasting. So the typecasting and then combining with this, okay, we shall see it later. For now, let's try to use how to make this fp point to sum. I think you remember that in arrays, whenever I have an array name and whenever I try to make a pointer to point to that array, I never use the ampersand. The array name itself is going to act as the address of the array, right? So similarly here, the function name itself can act as the address to the function. You need, just like the array. So what I could do is, I could assign fp equal to sum. It means that now this fp points to the function sum. You need not write anything. You can write just fp equal to sum. You need not put any braces or anything. The name itself is sufficient. Now let us say you want to find out sum of two variables, and therefore you are calling like this: sum equal to 5, 6. The same function call, let us see, this is nothing but I am calling the sum with 5 and 6, and the result is going to be stored in S. Now the same effect can also be, we can also derive the same effect by using the pointer. So how? Since fp is already pointing to sum, now I am going to call the function sum through fp. then how is it going to do is s equal to star fp, which means in place of this I am going to put star fp, and then I am going to call like this, right? So what does it mean? Star fp is nothing but sum. So sum will be called with arguments 5 and 6, and it will return an integer, and that will be stored in s. So these two lines will now become equivalent after this assignment. Understood this? It is not just that you can assign only this function, you know, with some typecasting you can even assign it to any other functions also. So if you want a generic pointer, and then if you want to point anything, then maybe you could write like this. You could declare a generic pointer like this. Let us say void star generic pointer, which takes two values, void and void type. Let us say we are all working on pointers, void star, void star, void star. So what is the meaning of it? GP is a pointer which points to a function. That function may contain two variables, two arguments of type void pointers, two arguments which are both are void pointers, and that function returns void pointer, right? Now let us say we have some function like this. Some function is, let us say int star, okay, sum int star comma int star. Now if you want GP to point to this, what you could do is you could typecast this function into this type of this pointer. So you can even do like this. See, it is not required, but it is just, I'm just telling you because maybe in interviews or somewhere it might be useful, but generally we don't use it really at practice, and gate there will be no questions on it for sure. So just for the sake of knowledge I'm just telling you. Okay, now I'm trying to typecast this particular function into these types. So I'm just trying to say GP equal to sum, but then I'll try to typecast. How can I typecast it? It is going to return void star, and it is going to take two pointers of type void star comma void star. Okay, so even if you didn't understand this, you can leave it, no problem, but if you are trying to understand it, just see this. What I mean to say is sum is actually a function which takes integer star and returns an integer star, right? Now I have converted that is called typecasting, right? So I am converting it so that there will be no problem with the compiler. Now whenever you typecast a pointer, one type of pointer to other type of pointer, there will be no loss of information, because either it is a character pointer or an integer pointer or a float pointer, whatever, it is just an address, and the address is always going to be constant, isn't it? So you can think of it like this. See, however big the house size is, the address is going to be of same size, isn't it? Everyone is going to get the same kind of address. Depending on the house size, address size doesn't change. Similarly here, a pointer, if it is containing some address, and if you are changing it to some other pointer type, the address will not will not increase. Therefore, when you typecast a pointer to other pointer, there will be no information loss, which means when you are now pointing a character, and when you take the address of a character and if you put it in the integer pointer, the address is going to be of same size, therefore information will not be lost. Only thing is, if you don't do the typecasting, your compiler might create a problem. So once you do the typecasting, compiler will agree happily, right? Then you can do this. This is how you can work with the pointers to functions. Now when I combine arrays with functions, with pointers to functions, then the declarations are going to be very, very complex. I'll tell you some examples. I'll take some examples and I'll explain you how complex this could get. But don't worry, don't get confused. These are not going to be important for GATE, but if you practice them, it will be very easy. And in case if you face any question in the interviews, you'll be able to answer them. Okay, fine. So arrays are the simplest data structures which are random access. Random access means in order to go to an element, you need not cross all the elements. You can directly go into that element. Okay, so how is this possible? It is possible that we could randomly access an element in the array, because when we are storing this array in the main memory, it will be stored contiguously. right? Since we are able to store the array contiguously in the main memory or in some memory, either hard disk or main memory, wherever you are going to store it. Since you are going to store it contiguously, and since you know the size of each element and the starting address of the array, right, you can directly go into whatever memory location you want and you can access it. But the same thing is not possible with linked list, isn't it? So in linked list, what happens is they are not contiguous. So one element can be present there, one element can be present here, and it can be random, right? And only way to access these elements is to go through a chain or a list, isn't it? So in linked list, random access is not possible, but in array, random access is possible. You can go to whatever element you want very easily, right? So there is nothing much interesting about this single dimensional array. There is nothing interesting in the sense if you have one dimensional array, that one dimensional array will be completely stored in the memory and you can go into any element you want. So there are two things whenever you talk about arrays. One thing is what is the index starting with. Sometimes index might start with 0 and sometimes index might start with 1. So that is the only difference. I mean, that is the only point where you have to be very, very careful. So let us say the index is starting with 0. Okay, so this index is 0, this index is 1, this index is 2, this index is 3. Let us assume that each element is occupying 1 byte of memory. 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, right? So in this case, in order to reach an element a of I, what is the address, right? Which means in the main memory, where should I go and look into? So if the array indexes are starting from 0, right, then just observe it. In order to reach the element 2, how many elements I should be crossing? Exactly 2 elements, which is equal to the array index, right? Therefore, whenever array indices are starting from 0, the number of elements that you have to cross in order to reach a particular element is equal to the index of the element, which means in this case the number of elements you need to cross is 2. Therefore, you can write it as 2 will be the address of the this particular element, assuming that the base of the array is 0. Right? In case if the base of the array is not 0, if it is something else, let us say if the array is starting at 100, the location address 100, then what will be the index? Index will be 100 plus 2, right? So in this case 100 plus I. Are you following it? See, I am saying that in case if the indices are going to start from 0, what is the location of the element 2 in case of one dimensional array? So if the array is going to start at some base, let's call it 100 here in this example, then in order to reach element 2, I have to cross 2 elements, isn't it? So similarly, in order to reach element I, how many elements I should be crossing? I elements. If the base of the array is 100, then 100 plus I is the starting location of the element I. That is what I mean to say, right? Now, what if the elements are starting with 1, which means indices 1, 1, 2, 3, 4, 5. Now, in order to reach element 2, how many elements should I be crossing? Only one element, right? Which means I minus 1. So, in case of, in case if the indices are starting from 1, then in order to reach an element I, how many elements I should cross? 100 plus I minus 1. This will be the address. Got it? This will be the address of the element 2. Okay. Now this is entirely, now these formulas are when, okay, don't remember them as formulas, you should be able to derive them on the go. Don't by heart it. Okay, it is very simple. Never by heart it. Now my question is, what if it is, every element is not of size 1 byte. Here I am assuming that every element is of size 1 byte. What if every element is of size 2 bytes? 2 bytes means, if this is the array, it will be stored in the memory using 2 bytes. So what happens is, the first element will occupy 2 bytes, 0 and 1. The second element will occupy 2 bytes, 2 and 3, right? 4 and 5, 6 and 7. Therefore, the element number 0 will be present, a of 0, in case the indices are starting with 0, right? A of 0 will be present starting at 0, a of 1 will be present starting at 2, a of 2 will be present starting at 4, and a of 3 will be present starting at 6. In case if the indices are starting from 1, a of 1 will be present starting at 0, a of 2 will be present starting at 2, a of 3 will be present, a of 4 will be present here. Are you getting this? So now let's consider the case. See, most of the cases our arrays will start with indices 0, and sometimes as it is possible that they might give you even starting with 1. So assume that our array is starting with 0 first, and then let's formula work. So now how many elements you should cross? Now watch it. In order to reach the element 2, how many elements you should cross? If the indices are starting from 0, the number of elements you should cross is the same, which is equal to the index. So in order to reach the element 2, the number of elements I should be crossing is 2, right? So in order to access a of I, the number of elements I should be crossing is equal to I elements, right? But then what is the size of each element? Size of each element is 2 bytes. Therefore the total number of bytes I have to cross is I into 2. Got it? And then in case if it is stored at location 100, then this will be 100, this will be 101, the bytes. This will be 102, this will be 103, 104, 105, right? So not to scale, even take that into consideration, you can add the base. Got it? So what is it now? In order to access an element I, in case if the index was starting from index 0, then we have to multiply I into, this is nothing but the size of each element in bytes. Okay, size of each element in bytes, or if it is word addressable, if they are talking about words, then size of each element in words, and then this is the base address. That is how you could get what happens if it is starting from 0. Let's see what happens if it is starting from 1. See, in order to reach the element 2, how many elements should you cross? 1 element. Therefore, in order to reach a of I, how many elements I should cross? I minus 1 elements. Yes, I am going to cross I minus 1 elements. Okay, and then what is the size of each element here? 2. I minus 1 into 2, right? Plus, what is the base of it? 100. So in case addresses are starting with index 1 in the question, if they are using starting with 1 or 0, they'll clearly mention, they'll say that A is an array which is from 0 to n. It means that indices are starting from 0. They'll say that A is an array which is starting from 1 to n, which means indices are starting with 1, right? So in this case, whenever addresses are starting with 1, indices are starting with 1, then how many elements you should be crossing? I minus 1 elements, and size of each one is 2, right? And this one is base. So what is it here? This one is nothing but size of the element in words, right? Since it is byte addressable, I am in general what you should take is in words. Okay, they'll give you that each is many words. So multiply with the size of the element, okay, and then add the base. This is nothing but the base address. Got it? So coming to the binary, how does the binary work is, so the binary is nothing but when you are multiplying, first you find out the binary representation of this, okay, binary representation of 1, and then what you should do is you should multiply it with the base. I mean, let us say the size of the element is 2 and the binary representation of this. Okay, in this case, what is the binary representation of this? Binary representation of this number, how much? 2 is 1 0, and then size of this one is, therefore we append this the element. Got it? And now 0 in binary is nothing but 4. So in case if we have a base, then I am going to write it as base and then this address. Base also I can convert it into this binary and I can write it with this, right? 100 base 2. Understood this? Convert this into binary and then append those many zeros, whichever is equal to this size, right? Getting this? So that is how we will find out what is the array address. So most of the times they might not give you even the base. So if they don't give you the base, assume that it is starting with 0. In case if they have given you the base, you can assume that it is starting with that base. Otherwise what you could do is, most of the times the a is a representation of the base. So you can write here as a, which means a represents the base of the array. You can write it as a plus this much, right? So there is nothing much interesting about this one-dimensional arrays. Two-dimensional arrays are generally interesting. The way you store the two-dimensional array, see, the way you store the one-dimensional array, there is nothing interesting. In the sense, you will take the entire array and save it as it is. There are no design decisions that have to be made here. So the only decision is either you have to start with 0 or start with 1. Most of the programming languages, they start with 0, because our memory addresses, they start with 0 and it is logical to use 0, and there are some questions which starts with 1. Okay, now let's look at the two-dimensional arrays, which will be interesting. Now let's see how to work with two-dimensional arrays. So the problem is, two-dimensional arrays are different to look at. I mean, the way we conceptually think of two-dimensional arrays is different, and the way they are physically stored in the memory are different. So once you understand how they are stored, you can write better programs. Okay, so anyway, let's see the example, then you'll understand it better. Let us say A is a two-dimensional array of size 3 by 4. What does it mean? It is having 3 rows and 4 columns. And let us assume that, okay, there are two ways, you can generally talk about arrays. Sometimes you can think that arrays are starting with index 0, all the indices are starting with 0, and sometimes you can think that they are starting with 1. Let us take both of them. Initially I'll take the one with the indices 0, and next the one with indices 1. So now if I have 3 rows, the 3 rows can be row number 0, row number 1, row number 2, and 4 columns can be column number 0, column number 1, column number 2, column number 3. So these are 3 rows and 4 columns, right? Then now what is the index of each element is 0 0, 0 1, 0 2, 0 3, 1 0, 1 1, 1 2, 1 3, 2 0, 2 1, 2 2, 2 3. So these are the various indices of the elements, right? And now in case if it is indices are starting from 1, then how does it look like? So index 1, index 2, index 3, right? So these are 3 rows, and then columns are 1, 2, 3, 4 columns. Then how does each element index look? Each element looks like 1 1, 1 2, 1 3, 1 4, 2 1, 2 2, 2 3, 2 4, 3 1, 3 2, 3 3, 3 4, right? And now how to store it? See, even though if you are looking at the array like this, I cannot take this and then put it in the memory as it is, right? Then the random access will fail. Random access is possible only because the array is stored at contiguous locations. In case if you try to put it as it is in the main memory or anywhere in the secondary memory, what happens is from here to here it is contiguous, and then there is a lot of blank space, and then from here to here it is contiguous. Now what is the link between these two? Then you have to use a linked list or something. It is going to be complex. So in order to still have that random access, we have to put this entirely in a contiguous manner. How can I put it contiguous manner then? Then you have to convert this two-dimensional array into one-dimensional array. How can I convert it? There are two ways. One way says that you take each row and put it in this memory, whatever, main memory or secondary disk or cache, wherever, and then you take the next row and you put it contiguous to the first row, like this. That is called as row major order. I'll just tell you. See this. So what is this row major order is? Row major order, which means we are going to store it row by row, first row, second row, third row, like that. Okay, now assume that memory is going to start from here. I mean, from here the array is loaded, then 0 0, 0 1, 0 2, 0 3, and then 1 0, 1 1, 1 2 1 3, and then 2 0 2 1 2 2 2 3, right? So if you watch it, we have placed it row after the row. This is the first row, and this is the second row, and this is the third row. We have 3 rows and we have placed it row after the row, right? Now if I have to reach any element, any particular element, let us say I have to reach the element 2 2, right? I have to reach the element 2 2. So whenever the programmer refers to the array A and the element 2 2, then we have to convert it the array reference in such a way that your the data bus will be able to go into this particular element in the memory and get it. So now the main challenge is, how are you going to convert the array references in two-dimensional array into this memory references, right? So how can you do it? So if you watch it, this element 2 2, in case if I have used the row major order, which means row after the row, if I place it, in order to reach this element, I have to cross all the rows before it. And after crossing all the rows before it, once I reach the particular row in which it is present, then I have to cross the elements which are inside the row, right? So in this case, if you are talking about 2 2, right, the element the indices 2 2, then you are supposed to cross two rows, and then in the particular row, then you are supposed to cross two elements, right? So that is how it should be happening. So what is that here is, if I have to reach 2 2, then I am supposed to cross two rows. So the number of rows I should cross is 2 rows. Then how many elements are present in each row? The number of columns are 4. The number of elements present is 2 into 4, which means 8 elements are present in each row, right? So what does it mean? In order to reach this particular element, we are supposed to cross 8 elements, right? This 4 plus 4 is 8 elements, and then after crossing these 8 elements, you are supposed to cross 2 elements in this row, isn't it? You are supposed to cross 2 elements. Then how can I get the 2 elements from the second array? Okay, so actually, instead of taking this one, this is 2 2, it will be confusing for you. I'll take 2 1, it will be easy, right? So now once I reach this, I'm talking about this element, okay? Now once I cross this particular 2 rows, then after reaching the required row, I am supposed to cross only one element. This second index is going to tell you how many elements you should cross in one row, right? Then this is the total number of elements that I should be crossing, isn't it? This is the total number of elements I should be crossing. So now one more thing you should consider is, how many words is each element occupying. In case if every element is occupying one word, you can directly say that this is the address if this array is starting from 0. In case if this array is starting from 100, the location 100, you can add 100 and you can say that this is the address of this element, right, 2 1. But then sometimes what happens is, each element can be of various sizes. Like they can say that each element is 2 bytes or each element is 2 words. In that case, you should even multiply with the number of words so that you can get the exact address, right? Are you following it? These many elements I should cross in order to reach my particular these many elements I should cross in order to reach the particular element, and after crossing these many elements, right, I have to even see how many words, in terms of words, how many words I should cross. So for that reason, I should even multiply with the size of each element. Got it? And then let us say size of each element is 2 bytes here, right? And then add the base, then I'll get the appropriate answer, right? So in case if it is going to start with 100, then what should this entire number be? Check this, 100 plus, how much is this entire number? If each element is having of size 2, 9 plus 2 is 18. So it is 118, right? 118 is supposed to be the address for 21. Let's check that. If every element is going to take two addresses, two words, then if it is starting from 100, let's see what is the total size of it. 100, 102, 104, 106, 108, 110, 112, 114, 116, 118, isn't it? Therefore, address this element 21, the address is 118. Got it? So that is how you could find out the address or convert the array references into the main memory elements, right? So now it can be extended even for a of ij. Let's say I want to refer to the element a of ij when a is let us say the size of a is m by n, which means there are m rows and n columns, and now I want to refer the element a of ij. Is it visible? I want to refer the element a of ij, right, in an array A, and in this array the size of the array is m by n. M rows are there and n columns are there, and assume that it is row major order, right? Then how, in order to reach this particular element, how many rows I should be crossing? The number of rows I should be crossing here is equal to I. I have to cross I rows, right, which means how many elements in I rows? So how many elements will be in each row? If there are m by n is the size of A, it means that every row contains n elements, right? Therefore I have to cross n elements, I rows into n. This is nothing but total number of elements in rows, or total number of rows in terms of elements I should be crossing. Once I cross these many elements in all the rows, then I'll reach the required row. In that particular row, how many elements I should be crossing? J elements in order to reach the particular element, right? And now I should multiply with the size. So this multiplied with size. So this particular size is nothing but size of each word, and then I can add the base. Got it? So this is how you could represent it in terms of I and j. Let me write it like this again. It is I into n. This is nothing but the number of rows I should cross, and I into n will give me the number of rows I should be crossing in terms of elements, and after crossing these many rows, I am supposed to cross some more elements in that particular row. So how many? J elements, right? And this is nothing but the total number of rows I should be crossing, total number of elements I should be crossing. And if the size of each element is let us say size, then this is the total number of words I should be crossing in order to reach that particular element. And if the element, if this array is starting from some base, then I add the base. So this one will give me starting with some base, right? If this is where the array is loaded, then this entire part is nothing but the address of the array. Now the same concept can be extended even for the case where indices are not starting with 0, indices are starting with 1. Watch it. Let us say I want to reach the same element here, right, 2 1, now which will be 3 2 here, right? Now how can I reach this one? In order to reach this in a row major order, I have to cross 2 rows, right? So how many rows I should be crossing? 3 minus 2, which means whatever is the first index, that number minus 1. Now the element 3 2, right? So the number of rows I should be crossing is 3 minus 1, the first index minus 1, right? So which is nothing but 2, and after reaching that particular row, the number of columns I should be the number of elements I should be crossing is 2 minus 1. Therefore here the first index minus 1 represents the number of rows I should be crossing, and the second index minus 1 represents the number of elements I should be crossing within that particular row, right? So if the same formula can be extended even for the case when indices are starting with non-zero, which is 1, but then you can directly write it as I minus 1 j minus 1. If you write like this, the same formula can be extended even to this case, right? So if you have indices starting with 0, you can directly write it as ij. If you have indices starting with 1, then you have to write it as I minus 1 j minus 1, and everything else remains same. Got it? Okay. Now this is how row major order works. Let's talk about the column major order. In column major order, what happens is we are going to store the elements column by column. Okay. So the first column is 0 0, right? 0 0 1 0 and 2 0. and the second column is 0 1 1 1 2 1, and the third column is 0 2 1 2 2 2, and the fourth column is 0 3 1 3 and 2 3. Got it? So this is how you could represent all the columns, isn't it? So this is column number 1, this is column number 2, column number 3 and column number 4, right? So now in order to access an element, let us say I want to access the element again A21. So if I had to access the element A21, then how can I access it? First you have to cross some particular number of columns and then reach the particular column in which the element is present, and after reaching that column you have to reach that particular number of particular element, right? So watch this. First of all, you have to reach how many columns you should be crossing. In order to reach the element 2 1, I should cross one column, right? This because it is present in the second column. So the second index is going to represent how many columns I should be crossing, right? Therefore I should cross one column, right? And how many elements will be there in one column? That depends on the number of rows. If the number of rows here is 3, then the number of elements I should be crossing in order to cross one column is 3 elements. And after crossing this number of elements, I will be reaching the exact column in which this particular element is present, which means the second column, right? And once I reach that exact column, how many elements I should be crossing to reach the element? The required element, 2 elements, right? Therefore this is the total number of elements I should be crossing in order to reach the required element, right? And if the size of each element is s, let us say size of each element is 2 bytes, right? And if the memory is loaded from 100, then this is the address of this one, right? So how much is this? It is 3 plus 1 is 4, 3 into 1 is 3, 3 plus 2 5, it is 110. Okay, now check it. So if the address is loaded with 100, if the array is loaded from 100, and if the first index is every element is 2 bytes or 2 words, then where is this 2 1 going to be loaded? This is 100, this is 102, 104, 106, 108, 110. Watch it. So 2 1 is loaded at the address 110. You got it, right? So that formula works. Then okay, in exam also you can do the same thing. You can write them all down, and then given the options you can directly check them. If you don't know how to write it, you can check in the options and you can get it also, right? So now let's see A of ij. Let us say A is an array of size m by n, right? And I want to access the element A of ij. Then how can I reach it? You have to first, in case of column major order, you have to cross these many columns. How many columns? J columns. You have to cross j columns. And what is the number of elements in each column? That depends on the number of rows. How many number of rows are there? M rows. Therefore, in order to cross j columns, you have to cross these many elements, j into m elements. Then you will reach the particular column in which your element is present. After reaching it, you have to even cross some number of elements to reach the particular element, right? So how can I cross it? By adding I. Now this entire number is nothing but the number of elements you should be crossing in order to reach the element A of ij, right? In case if each element is of size s, then this is the total number of bytes I should be crossing in order to reach some particular element, right? And then you have to add the base. Then what is the base here? Let us say base is b. This is the address of this element. Got it? So this is the total number of elements I should be crossing, and this is the total number of words I should be crossing. And since it is going to be loaded at some base b, this is the total address. So in case if you are applying this for indices starting from 1, in place of j you have to write j minus 1, in place of I you have to write I minus 1. You need not by heart it, you can just derive it on the go. Got it? So this is how row major and column major order works. So why is it so important that you should understand this row major and column major order is, if you know whether your array is stored in row major or column major order, then you can write your program in such a way that your program will take advantage of this representation. I'll tell you how does it work. Okay. Now this is the sizes or the formulas which are given you in decimal. Now how to get the address in binary? So this is somewhat difficult. and okay, I want you to pay full attention here. Whatever I'm going to teach you is not that easy to understand. I'll try to make it as simple as possible, but then you please focus on this. Okay, so writing the addresses in binary and decimal is straightforward, but when I try to convert the same addresses into binary, then it is going to be a bit tough in a sense. Okay, so let's talk about this. What is the address of a particular element ij in when the indices are starting from zeros? So most of the cases our computers are going to have indices starting from zeros, because the main memory is also starting with zeros, so it is natural to have indices starting from zeros. So I am going to take here, assume that the indices are starting with 0, then what is this? See, in order to get into a of ij, right, where a is a m by n array, if the indices are starting with 0, then I told you that it is I into n plus j into s, where s is size of the element and plus base is anyway there. Okay, so this is the formula. Fine. Now I want to write this entire address in binary. That is what I want to get. Okay, then now one thing you should understand is, in computer science generally everything will be in the power of 2. So even let us assume that even the array sizes are also given in powers of 2. In case if the array size is also a power of 2, okay, what is n here? N is the number of columns, remember? So A is an m by n array, which means n is the number of columns. Let us say, then what is the relationship between j and n? If n is the number of columns, you can clearly understand one thing. The relationship between j and n is 0 is less than or equal to j is less than or equal to n minus 1, which means j will be definitely less than n, right? So the relationship between j and n is j will be less than n, right? Now assume that n is a power of 2 and assume that n is 2 power k, right? What does it mean? The number of columns we have is equal to 2 power k. Are you following it? The number of columns we have is 2 power k, right? And then now if j is a number less than 2 power k, okay, see, j is a number less than n, and I am assuming that n is a power of 2, and if j is a number less than 2 power k, then how many bits will be required in order to represent j? The number of bits that will be required to represent j will be definitely less than or equal to k, isn't it? If any number is less than, see, if any number j is less than n and n equal to 2 power k, what does it implies? This implies that j is less than 2 power k, right? Now what does it mean? In order to represent j in binary, we need less than or equal to k number of bits, isn't it? The number of bits which are used to represent j will be less than or equal to k. Keep that in mind. Okay, now, and you can even assume that the number of rows m is some 2 power l, right? Then what happens? Then I is also less than 2 power l, therefore the number of bits required to represent I will be l, right? So now you can write it like this: I into 2 power k plus j, isn't it, into, you can even assume that size of this size of the element is also a power of 2, let us say 2 power x plus base. I am writing everything in 2 powers, right? Now what you could do is, you could represent this I in binary. Let us say I have represented this I in binary, this is the number I, right? And when I multiply any number with 2 power k in binary, it is nothing but adding k zeros, isn't it? Appending k zeros. So these are nothing but k zeros, which is nothing but I multiplied with 2 power k. And when I add j, right, I am going to add j here, isn't it? And you already know that j is going to take less than or equal to k bits, right? Therefore this entire representation can be represented using I can be represented in L bits and j can be represented in k bits. So the total number represented is L bits plus k bits, and then multiply with 2 power x. Therefore x bits will be here. I don't know whether you understood this or not. Okay, I'll even take a numerical example and explain you, but anyway, just try to focus here one more time. See, what is that I am trying to say is, okay, maybe I'll do it again. This is not very simple concept to follow, but then let's go step by step. Maybe you might understand it then. Okay. So I'm talking about row major order. So in row major order I am talking about Aij. You already know that in order to reach Aij I have to cross I rows, right? So if I have to cross I rows, then how many elements I should cross? Number of columns. I into number of columns is n. These many elements I should cross in order to reach the particular row, and after reaching particular row I should cross j elements in order to reach that particular element, right? So this is the total number of elements I should be crossing, and if the size of each element is s in terms of words, this is the total number of words I should be crossing to reach the element Aij, and base is b. Got it? Now I want to find out the address, right? So what is that I am trying to do is, now I am assuming that m is 2 power l and n is 2 power k, which means the dimensions are, I am assuming that in the dimensions are represented using powers of 2 without loss of generality, right? And now what about I? The I is nothing but the row number. Row number will generally vary from, if you assume that it is starting with zeros, the row number, which means I, will vary from less than or equal to 2 power l minus 1, isn't it? And what about column number? The column number will also be less than or equal to 2 power k minus 1. 2 power k minus 1. So what do you understand? Either in order to represent I or to represent j, the number of bits required will be less than or equal to l, isn't it? See, what is the maximum number that could be represented using l bits? 2 power l minus 1, isn't it? What is the maximum number that can be represented using 2 bits? 3. What is the maximum number that could be represented using 3 bits? 7, right? 4 bits? 15. So 2 power l minus 1 is the maximum number that could be represented using l bits, right? Therefore, if you are never crossing the maximum number which could be represented using l bits, then how many bits are used to represent the number I? In worst case, l bits, right? Therefore, you can represent any number I if its range is 0 to 2 power l minus 1 using l bits. So l bits are enough to represent I. What about j? K bits are enough to represent j, isn't it? Now I'll write this entire address like this. The entire address can be written like this: I into 2 power, what is n? K, plus what is j? Let me leave it as j, and let me say the size of each byte, size of each element is 2 power x words, right? Then it is 2 power x plus b. Got it? So this is the number of words for each element, right? And now see, how many bits are used to represent I in binary? L bits. So L bits are enough. So using L bits I can represent I. So I is represented using L bits, right? And now when I is multiplied with 2 power k, right, then what does it mean? Whenever any binary number is multiplied with 2 power k, it is nothing but left shifting this number those many k times, right? Therefore I into 2 power k is nothing but appending it with k bits, and all k bits are zeros, right? So I is nothing but L bits, and L bits I is represented, and this entire number is this one. And now I have to add j, right? So what is adding j? Adding j is nothing but convert j into a binary number. How many bits are required to convert j into binary number? K bits, right? Therefore you can get j which is represented in k bits, and you can add it, right? Therefore now this entire number is actually represented using k plus l bits, isn't it? So now this entire number is going to be represented using, here there are L bits and here there are K bits, right? And what is this? This is I and this is J. So I is nothing but the first index, isn't it? I is nothing but the row number, and this is nothing but the column number, isn't it? See, if Aij is given, I is nothing but the row number and j is nothing but the column number. So you can represent row number here and column number here using the L and K, right? And we got this entire number in how many bits? The number of bits required is L plus K bits, right? And then you have to finally multiply with 2 power x. So what is multiplying with 2 power x? Appending x number of zeros. Got it? So this is the entire address of this element in our in binary, right? And finally, anyway, you have one more binary number which is base. You convert this base into binary and you can add it, right? Anyway, that doesn't make any difference. So only important part is this. So what did you understand from this? In order to represent in order to get any address, right, you have to do this. You have to take the take the address, and then the least significant x bits is going to be the size of the element. If the size of the element is 4, it is going to be 2 zeros. If the size of the element is 8, it is going to be 3 zeros. And then in case of row major order, here it is going to be column number and here it is going to be row number, right? Depending on how many ever bits you want to represent row and column, right? So this is how the address can be found out in case of row major order. What happens in column major order? The same thing, right? In column major order, same thing. You have to have this x number x where x is the size of the 2 power x is the size of each element, and then here you should have row and here you should have column. So why do you think that this way it is followed in row major order and column major order is, in row major order we have to cross first rows, we have to cross first the rows, and then after crossing the rows you are supposed to go into this after crossing the rows you are supposed to get into the row which is required, and you have to cross the elements to get to that element, right? That is why row number is here and column number is here. By writing row number here, this will make sure that you are going to cross all the rows before you get into the desired row, and after getting into the desired row you have to cross these many elements, right? See, row and column doesn't mean that you have to put the number of rows and number of columns. Row and column means that what is the first index and what is the second index. In case of column major order, you are supposed to cross the columns. That is why the second index here and then the first index here, right? So which means, see this, instead of putting a row column and column row, if you are getting confused, you can even put like this. So if A of ij is required, what I mean to say is this one is the first one, this one is the second one, right? So in case of row major order, put the first one here and the second one here. In place of column major order here, put the first one here, put the second one here, and then the first one here, right? This can be extended even to 3 dimensions. In case if you have 3-dimensional array, put the first one here, second one here, third one here, and finally the size of the element, right? So it can be extended to any number, right? Fine. And so this is how you can think of the array elements, right? So this is all about the row major representation and column major representation. So one thing is, why is this important that you should understand all these concepts is, depending on the way in which you have written your program, or depending on the way in which the memory is organized in the 2-dimensional array is organized in the main memory, you can write the programs in such a way that they will take the advantage of this organization. See, in case if you think that row major order is used, then what happens? This entire part will be placed together, and then this entire part will be placed together, and then this entire part will be placed together, right? And then let us say the entire part happens to fall in, if this is the organization, then what happens is, in terms of paging, the entire row might fall in one page, right? Then if you try to load one element, or if you try to access one element, you will get all these elements in that page. Therefore, you can write your program in such a way that it will take advantage of this organization, and immediately when you get one element, you can try to access all the elements without any page fault. So in case of row major order, accessing the elements row by row is going to give you less number of page faults. In place of column measure order, accessing the elements column by column is going to give less number of page faults. Why? Because whenever you try to load one element, in case of row measure order, the entire row will be loaded in one page. Therefore, if you try to access them row by row, only for the first element there will be page fault, and for all the remaining elements there will be no page fault. Got it? So whatever the memory organization is, you could still write some kind of program which will take the best advantage of it and give the best performance. But then once the program is fixed, which means once you have written the program and once it is fixed, then the performance of the program depends on what kind of organization they have used. In case if they have used row measure order, then the performance will be in one thing. In case of they have changed it to column measure order, the performance will change, right? Therefore, knowing the organization well ahead and then writing the program will give you better performance than writing the program and then asking it to adapt to the organization. Are you getting this? See, what I am trying to say is, in case of paging, if it is row measure order, there are chances that one row will fall in one page. Therefore, when you get the first element, we access all the elements of that row only. In case of column measure order, then there are chances that one column will fall in one page. Therefore, when you get the page for the first reference, then you try to access all the elements of the first column. Are you understanding it? The same thing can be applied even for cache also. In case of blocks, and whenever you are using this row measure order, whenever you load one block, there are chances that the corresponding elements which are in the entire row will be loaded. Therefore, you write the program in such a way that it will access all the elements row wise, not the column wise. See, if you are using row measure order and if you are accessing the elements in the column wise, what happens is, whenever you load any program, whenever you load any word, then the entire row will be loaded, then immediately you will be asking for the next column instead of asking the next element in the row. That is why, depending on the organization of the two-dimensional array, either row measure order or column measure order, you choose the program, but not the other way around, which means you don't write the program and then you don't think that it will give the same performance in all kinds of organizations. Got it? So what I mean to say is, either it is row measure order or column measure order, you could still write the programs in such a way that it will run efficiently, but then only for one order. Let us say the given organization is row measure order, then I'll write the program in such a way that I'll try to access the elements row wise, then that will give the best performance. If the program is column measure order, then I'll try to write the program in such a way that the elements are accessed column wise, then that will give the best performance, right? So once you have fixed up the organization, either row measure order or column measure order, then it is up to you to write the correct program. Got it? Okay, we shall see some questions on that, you will understand it better. So especially in CO, we shall see how to combine the arrays, the concept of two-dimensional arrays and the memory organization along with the blocks, then you will understand what is really going on. Okay, fine. Now let's see the C program. Determine whether two arrays A and B have an element in common, right? So let's say the name of the function is common, and now we are going to have it is going to take two arrays, one is A and other is B. It is nothing but, we are having first argument as a pointer to an integer and second argument as a pointer to an integer. Generally, address to the first element of the array which has to be processed will be passed to this, and that will be held in this pointer. Similarly, here also the address to the first element of an array will be passed and that will be held in this pointer, right? And then int n, int m. Okay, so what is int n and int m are? They are the sizes of the array A and sizes of the array B. Generally, when we pass strings, we don't pass the size of the string. The reason is every string is null terminated. Therefore, the function which is processing it is supposed to find out the size by itself by going till the null. But coming to the integer arrays, we don't have null terminated concept here, right? So for that reason, we are even sending the sizes. Whenever we send the pointer to the starting of an integer array, we also say send the size. Okay, int I comma j, for I equal to 0, I less than n, I plus plus, for j equal to 0, j less than m, j plus plus. Now what it means is, the logic here is simple. Let us say the array which is being pointed by A is this, and the integer array which is being pointed by B is this. Okay, and the numbers in this array are like this. Assume that it is 1, 2, 3, 4, 5, and the numbers here are like this: 10, 5, 2, 4, some 6, something like this. Now what we are trying to do is, we will first consider for I equal to 0, which means we start indexing this one from 0, and we first consider for every element, for let us say for 0th element, we will get into the second loop, which means we take this element and we get into the second loop, which means we will start j from here. I will be pointing to this, indexed into this, and j will be used for indexing into this. Now for this element, I'll search the entire array by using j, whether this element is equal to any of the elements present here, right? So for j equal to 0, j less than m, j plus plus means all the elements here are being searched. How they are searched is, if a of I is equal to b of j, which means I'll check whether this element is equal to any of the elements here, right? Every time I take this element and I'll check with this. If it is not equal, I'll check with this. If it is not equal, I'll check with this. That is what is going to happen with j plus plus, right? The next element is going to be searched. Now whenever let us say we didn't find element number 1, right, and after this complete search is over, we come out of this for loop. Once we come out of the for loop, again we go to I plus plus, right? Now I is going to be the next element, which means I is equal to 1. So we take this element and now we start searching with all of them. Again I start searching from the beginning, which means I search with j equal to 0. This element will be searched with this. If it is not equal, then this condition will not execute. Therefore from here again I increment j. Next element will be searched. Next element will be searched. Let us say this element is now about to be searched. When will this hit? Whenever I equal to 1 and j equal to 2. Let's see what happens. I equal to 1 and j equal to 2. Now if it checks, compares these two, a of I and b of j, which means a of 1 and b of 2. If it checks these two, it is going to see that they are actually equal. Now the question is, check whether they have an element in common. Even if there is one element in common, we stop executing the program there and we directly return to the calling function, right? The function which is calling this function will go there directly without doing anything. See, if you look at break, by using break we will be coming out of the enclosing for loop, right? By looking at continue, will not execute the statements which are after the continue, but will go into the increment or decrement phase. But if you have any return statement, we directly come out of the entire function, will not do anything, we stop everything and we go back to the calling function. Got it? Now if we didn't go back from this for loop, which means if this is never hit, it means that there is no element common at all. Then we are going to come out. If we have searched all the elements for all elements in A, if we have searched all the elements in B, and if we are not able to find the common element, then we come here and we simply return 0. 0 means we didn't find anything. Got it? So since the return type is an integer, successful is going to return 1. On failure, we are going to return 0. Got it?